Hey, hey, check, 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 yep. Thank you so much for everyone coming back on day two. I hope you all enjoyed yesterday and the one day of Dutch summer that we had, and we're back to normal. I'm gonna keep this slide. Yep. I'm gonna keep this nice and light. For anyone who was at the barbecue, I hope you appreciate my tagline here. Don't mention the devops. The lights are a bit bright. For everyone involved here, I think. But I do want to do one thing, and just a quick poll of, well, first of all, who was here yesterday and who enjoyed their day? Give me some noise, yeah? Yeah, oh, not too much, but yeah. And who all got a chance to attend the open spaces yesterday? Show of hands. Any thoughts, feelings you enjoy? Yeah? Great, it's great to hear. Yeah, good fun? Good to hear. So what we're doing, I'll kick through straight into my first slide. So today we are doing our best as organisers to kind of keep the show on the road. We've had a few cancellations due to people that couldn't travel, unfortunately, due to a variety of reasons. So we are on the fly doing our best to kind of mitigate against it, and we'll let you know as things come up. There may be a one or two remote talks today as well, just as a heads up. So once again, the URL is available if you go to DevOpsDays. The program is available at devopsdays.org, and you go to Amsterdam and then program. It'll also be outside, but it may be marginally out of date. But we'll do our best to kind of keep you informed. And this afternoon as well, we'll be doing the open space topics again. So anyone who didn't get the chance or really enjoyed themselves yesterday, please participate. We'll have some lovely people talking us through open spaces again. Is that right, Baz? Yes. And if open spaces you found is not your thing, we'll have some amazing talks that are going on in this hall as well. So we took some feedback from yesterday as well, and I'm going to just take a moment to give everyone the chance to kind of take down the Slido. You can open up a tab on your phone. Just make sure you've got scan the QR code, or you can take down the number 2119168. We've also nudged it to the front of the stage here as well. We found yesterday that people couldn't see it because we're promoting it at the back. So I'll just wait just a moment. We'll be gathering questions for each speaker throughout their talks, and please, for the questions that have been added, please go in and upvote, even if you're not asking your own type of question. See no more cameras. I think we're good, and we've also got it here, so I think it's good. The one call out I've got to do today, or I want to do today, is for Eindhoven. It's upcoming, I think, if I remember correctly, it's mid-October, maybe 20-something of October. But the important bit for everyone here is that the call for papers are still open for another 3 weeks. So I'd encourage you to check it out, submit if you have any talks. You see exactly, it's going to be a very similar event. So if you've liked the feel, the vibe here, please do submit your talk to Eindhoven. Additionally, they're still looking for sponsors, and the early bird tickets are available if you've enjoyed yourself and you would want to be an attendee. So I think, without further ado, we're probably just going to kick off if we're ready. So now, I want you all to welcome you up to the stage. However, let's just conscious clapping. Conscious clapping. There's a lot of hangovers, so please welcome to the stage, Job. You want to switch into this one?
Yeah. I have an HDMI port, so I can just plug it in directly.
Yes. Over to you.
Does this work? Yeah, great. Hello, everybody. Good morning. Incredibly glad to be here. I've been at the DevOps Days here in Amsterdam many years ago. If you're wondering why, what do you have to do with DevOps and whatnot, I used to lead product at GitLab from when it was founded until I left to found my current company, which is called Remote. This talk is not going to be about DevOps at all, so I'm sorry to disappoint you. I do encourage you to ask me questions. I know quite a bit about remote work. I've done so since 2013 until today. I've worked with many thousands of companies working remotely and have some idea of DevOps. Before I get into what I want to talk about today, it makes sense to provide you a little bit of context about what I've been doing. So, as I said, I used to lead product at GitLab, and I was convinced the most complicated thing in the world was setting up Kubernetes in an infrastructure you never saw before. I was convinced it was the hardest thing. And at GitLab, we worked remotely. We had a fully distributed team. What we did is we just worked as an open source project, and that's how we scaled the company. So rather than establishing an office somewhere and looking for people that could work from there, we would just hire whoever was great, top contributors to the open source project, people that were excited. And we didn't care where they lived. And that's how we grew the company. GitLab went public last year and did really, really well. And we managed to create a company culture up until today where we have no offices and people can work from wherever they really want. It was genuinely a great experience. But the one thing we never really figured out was we would hire someone in a country we never hired someone before. And now we somehow had to solve for all the bureaucracy that comes with that. Meaning we had to be able to actually pay them and provide them benefits and provide them some sense of security in their job. And what we found was that that was incredibly hard. And we just wanted to build cool stuff. We just wanted to build software. But now we had to deal with bureaucracy in about 70 different countries. And honestly, we never found a great solution. We tried many different things. We tried setting up our own organizations in all sorts of countries. We tried to work with all sorts of vendors. And it tended to be either OK or usually kind of a disaster. But this whole remote working thing, it had some merit. It was clearly something that we thought, this is how companies are going to operate in the future. And so I figured, you know what? I believe other companies are going to work this way. I believe that independent of where you live on the planet, you should have access to great opportunities. So I'm going to solve that. And I figured, I did all these super complex things related to DevOps and CI/CD, and I can probably fix this. Oh, look, that's great. That's great. There we go. All right, good. This is, you're no longer in tech for a while. I figured, well, I can fix this. I did complex things in my job before. I can probably solve this problem as well, just as easily. So to build remote, so what we do is we make it possible for you to hire anybody anywhere. We provide payroll and benefits and compliance and everything else you might need to be able to do that. And to do that, we have to set up a company in every country in the world. And again, I thought, I did tech. I can program. I'm pretty smart. This is easy to do. So to give you an example, a few months ago, I tried to open a bank account in Turkey. To open a bank account in Turkey, I had to sign 50 pages, full signature, name, date, every single one of those 50 pages, 5-fold in front of a notary. I did that. I had a huge stack of documents. It was notarized. Then I took those documents, and I do this literally every week. I took those documents to the court to get them apostilled, where they put a wax seal on the documents, which then I ship to the country where I have to go, where it ends up in someone's desk who is going to get to it when they are going to get to it. And this happened, and I'm not kidding you, 2 months later, I get a note back that we forgot one signature on one of the pages, in one of the 5 times that I signed these 50 pages, and now we have to redo it from start. Again, 250 signatures. And this is to open a bank account in one country. We have entities in 90 countries now. Just a bank account in one country. So that is remote, and that's what we... It's a pain in the ass to set it all up and to build this, but it works now, and it works quite well. We have a large organization, and we grew to about 900 employees in about 3 years. So, but that's it. That's all I wanted to tell you about the company and what we do. What I really wanted to talk to you about today is remote work itself, because I've learned quite a lot, having grown 2 companies with about 1,000 employees over the past 9 years or so, about how to work remotely and how to do it well. And so I figured I would start with meetings are the death of productivity. Who here feels like they spend too much time in meetings? Yeah. it's not necessary. It is not necessary to spend a lot of time in meetings. Great people working in our organization and that of many of our customers, especially if they're not managers, they can do with one meeting a week and that's it. And that should be the goal of today. And that is what I want to walk you through. How do you get to this point? Well, this is the typical example. Let's say you want to deploy something that needs component A, B, and C. And so you're working with a team. This is what we typically see happening in many organizations. We're starting to work on one thing, and then you get stuck. You need some input from another team. So you have a meeting, you stop all the work you have, and then you continue to work. Now, this works if everybody is together every single day in the same place in the office. But imagine that you are in different time zones, then this becomes an incredibly long process, right? Because this becomes, well, I'm starting to work on A, my colleague who's working on B is sleeping, and so for us to sync up, there's going to be at least a 24-hour time to just figure out when we can meet, if we can meet at all. And this keeps going forward until we ship one or until we ship the other. It's a very slow sequential process. It does not work. And the answer to this is asynchronous work. Who here has heard of asynchronous work? Yeah, most of you. Asynchronous work essentially just means that just like you run a process asynchronously, is that you don't continuously need to catch up. You need to be able to continuously provide output as an individual. And if you hit a roadblock, you should be able to start working on something else. And there's a few important ways to go about this. But how this works in practice is essentially this, which is I start working on A1. The moment I hit some sort of roadblock or I get stuck with something, I can move on to something else. And the trick here is not so much that I do something magical. It's more about the fact that I am empowered. I've given ownership about taking decisions. And whenever I get stuck, rather than waiting to set up a meeting, to set up a call, I just write stuff down. And that genuinely is the secret of asynchronous work and how you can do all of it, which is you just write shit down. That's it. That's all there is to it. So if I'm starting to work on this project with A, B, and C that I need to deploy, what I'm going to do is I'm going to start working on A. I write down what is happening. I write down what I'm doing. I make sure that it's transparent and accessible to everybody else that I'm working together with so that they don't have to come and ask me. And if I get stuck, I should have sufficient ownership so that I can move on to something else, to C, for example. And then when my colleague who was working on B wakes up, they can look into the thread, they can help me get unblocked, and the next time I start working again, I move on. And I don't rely on having set up that meeting. I always find that this is like one of those things that is incredibly obvious, but in practice, it happens so many times that I hear from people that are like, well, I got stuck, and I had to wait, so I just spent the rest of the day doing not much, waiting for us to have that meeting. And it genuinely can be this simple. And this also comes in play, especially when you're thinking about flow and when you're thinking about focus. This is a really famous example that I'm sure you're all aware of, which is to get into anything that is complex, it takes you a while to ramp up. You ramped up, you're in the flow, you're being highly productive, and now this colleague who does not work asynchronously comes in and says, hey, sorry, can I ask you something? Gone is the flow, gone is your focus. You have to now focus on solving this problem, and you have to get back into it. Again, this is completely avoidable. And the beautiful thing about working asynchronously, which, by the way, you can do it remotely or not, you can do this when you're in an office as well, is that you can just block your entire day and just get a lot of work done. And then at the beginning or at the end, or whenever it's convenient for you, you can get into those tasks where people are blocked, where you need to help them. That's it. Asynchronous work. And that was the most important message I wanted to give you today. Asynchronous work is really straightforward. But it's important that you give and that you get ownership of the projects that you're working on, and that you just write down what is happening. Where are you getting stuck? where do you need help, and make sure you have sufficient capacity to move on to other things. What about everything else, which is, admittedly a lot? I figured, why don't I talk you through the things that we've learned as a company working with many other organizations about remote work? Like, what are the fundamentals to making a great team work remotely, making a company work remotely really, really well? First and foremost, you must lead with trust. Whether you are managing a single person, whether you're not managing anybody and just collaborating, or whether you are an executive in an organization, the single most defining feature between companies that do remote work really, really well and those that don't is trust. And it's very easy to validate if you work in an organization that trusts you, right? Which is, do they monitor what you do during the day? Do they care about the hours that you work during the day? The amount of times that you spend online? Do they check on that? Because if they do, they don't trust you. The only thing that matters, that truly matters, is your output, right? It's the thing that you produce, the value that you create for the organization. It shouldn't matter when you do that, how you do that, in what time you do that. That should be the only thing that matters. And so if you are in a team or if you're in a position where you manage people, that is essentially the solution to building a great remote organization, is to lead with trust. And then one of the things that we did when we started the remote, and the same thing we did when we had GitLab, is we said, well, how do we make sure we're all aligned about what we think is important in an organization? And again, this is something you might have heard many times in a lot of startups do this, talk about values. But it's hard to overstate how important they actually are, because they give you a common framework to reason against, to evaluate performance against, and to say, well, we do these things in this way because these are our values. And so what I figured I would do today is I would just walk you through the values that we have at Remote, why we set them as they are, and why I think they're important and they might be helpful to you. They should be pretty straightforward. And again, I often feel with these kind of talks that I'm just stating the obvious. So if you feel that way, then let me know at the end in the questions and comments. But yeah, let's go through them. So when we started the company, the first thing we realized was that if we start a company, we can say we don't want to work with anybody who's essentially an asshole. So I couldn't write it down. So we call it kindness, but that's really what it means. And again, it seems incredibly obvious to say, well, kindness is one of our values. But the beauty is that by stating it, you immediately draw a line. If you behave unkind towards each other in this organization, there's no place for you. I'm in a fortunate position that I can actually make that decision, but I make sure that everybody else in the organization is in that same position. You can do amazing at your job, but if you're unkind to your colleagues, there's no place for you in this organization. And again, it's super straightforward, but the nice thing is, it's actually a nice place to work. We created a place where there sometimes is stress, and there sometimes is pressure to get things done, but you never have to feel like, well, people are just acting unkind or worse than that to me. They don't have to, and if they do, we can actually make a meaningful change to how the organization works. That was our first value. And the second one should sound familiar after all the things I was saying just now about asynchronous work, which is ownership. Ownership means that whatever you are working on, you truly care about, and you have sufficient of a mandate to actually make changes to make sure that the outcomes are met, right? So you shouldn't feel like you're just pushing paper, but you also shouldn't feel like you can't do anything else than exactly what is written down in a spec, in an issue, in a ticket, or whatever. Ownership is an incredibly important property, and it is mostly given by whoever manages, right? They say, I give you ownership of this project. It's up to you to reach the outcomes that we're hoping for, not to just do the task as it is described. One of the things we did is we wrote down excellence about doing things well. This doesn't apply to everybody. This is definitely not something that I think works in every circumstance, but in our case, it was very important. We felt very strongly that the nature of move fast and break things in startups which at GitLab we fully embraced, broke a lot of things, deleted the production database once. When we were building a payroll company, we realized that if you delete a database in payroll, or if you make a mistake, that has unfortunate consequences for everybody involved, such as not being able to pay for their food. So we made a point out of making sure that everything we do, we have to do well, which is why we created excellence as a value. And then lastly, transparency. I mean, you all know the saying, don't repeat yourself. Transparency is like a hack for a great remote culture. And the hack here is that whenever you do anything, you default to working transparently. You default to public, so public within the organization. So if you and I are having a conversation together, rather than having it in private in Slack DMs, for example, we have it in a public channel. And one, this feels unnatural. Two, you start to think, well, I'm creating noise. I'm creating distraction from everybody. This is not necessarily valuable. But the beauty is that the moment we need to bring anybody into the conversation, whether it's an FYI or actually bringing them up to speed, it's right there. If you are starting to work, if you're developing something, rather than going to the point where you have like a first version that can be reviewed, immediately push a branch, make it visible, maybe even open a pull request and say, I'm working on this, but here you can already see the state of this, so that it's easy to collaborate. Defaulting to transparency is incredibly easy once you get used to it, and it has immense benefits, especially over longer periods of time. It's super easy, and then, yeah, you don't have to repeat yourself, because whatever you decide, whatever you write down, you do it once, and then you can refer people to that. And what you would find is that most things don't have to be private, right? Most things don't have to be hidden. Most things, in fact, should be public and very accessible. And so those are our values, right? It's kindness, because we don't want to work with assholes. It's ownership, because it's important that everybody that works on a thing should actually feel like they impact the outcome of that thing, and they can focus on that rather than just pushing the paper. Excellence, because we're in payroll, we can't really make mistakes. And then transparency, because it's like the ultimate hack to solve for so many problems that otherwise you would encounter in traditional organizations. And so if you do all of these things well, which is, it's not a lot, right? Like it's only a few things. You have a really solid foundation for building a remote team, for working asynchronously. Even if you get together in the office every single day, it makes your life a lot easier, because you need a lot less moments where you get together and you sit together in a meeting. The next thing, and especially if you work remotely, that you should take care of is you. Because once you start working asynchronously, once you start working remotely, and especially if you don't go to an office and you can do your work from anywhere, you can always work. And you can have Slack on your phone, and you can have your email on your phone, and work is always there. And I've seen this. I have about 1,000 employees now. I have tens of thousands that are working through us. And I see this every single day. People that tell me, I feel like I can't leave work behind. I can't shut down work. And I will not leave here today without telling you that you are not the exception to this rule. If you are very comfortable today saying, I like to do work here and there, and if I'm on the couch watching Netflix at night, I like to check work, don't do it. Create a clear separation between what is work and what is everything else. You should create a situation in whatever means you have where at the end of the day, whenever you end your day, if you like to work at night like I, then that's fine, you work at night. But when you're not working, you should be not working. You should not receive notifications from work. You should not check in on work. You should not check on email. If you're on call, you're on call. But when you're not, don't be on call. It is the single biggest mistake I see so many people make. Keep track of yourself, take care of yourself, and don't think that you're the exception. And don't think that because you don't feel that today, that not one day is going to find you, because you will feel it. And that is essentially how people burn out. Oh, look at that. Talking too much for a single slide. Separate work and life. This was a random thing in there. If you have a manager today that manager should be your coach. And they should support you in these things. They should help you grow. They should support you in these things. They should help you separate work and life. They should help you get better. They should put pressure on you when you need to do better. And they should give you space when you have significant ownership of something. They are your coach. If you feel like today you're being micromanaged, that is not what a manager should do. And it's a good reminder to keep. And then as last thing, and this is all over the place, but I didn't practice this. Remote work is here to stay. I know that many of us are hearing about layoffs and companies returning to the office. What I'm seeing, and I have a lot of data points, is that remote work is not only here to stay, it is growing significantly. And if you enjoy having some sort of flexibility in your work, meaning working whenever you want or wherever you want or both, don't fret, it is here to stay. And what we are seeing, and this is what I'm leaving you with, is that the power has completely shifted from employers dictating, I want my employees in the office, to individuals saying, oh, but I don't want that. Because there's now, still today, with layoffs and everything else, the demand for talent, demand especially for people working in software, is far greater than the supply. And so that means that if you're working in a place that is telling you to go back to the office to work in a way that you don't want to, you can go elsewhere. The dynamics of power have completely changed, and remote work is here to stay. And with that, I'll leave you, and I'm happy to take any and all questions that you might have. Thank you.
Thank you so much. Oh, we have the questions rolling in. Where do you want to start?
Yeah,
start
also
from the top.
Yeah. What channel would I use so each individual exposes what they are currently working on in blockers? Jira and Friends, Slack and Friends, other approaches? Yeah, this is a great question. So for any piece of information, you should have a single source of truth. So that means that wherever that happens, that thing happens, that is where you write things down. Right? And so if you're working on a ticket in Jira, for example, then that is where you have this discussion. This is where you provide the updates. That's the most logical place where your colleagues are going to be. And it's also not ephemeral, right? Like it doesn't disappear when you disappear. It doesn't disappear over time. It's just the single source of truth for that particular thing. If you have a conversation, like a discussion that's really one-off, Slack can be that, but typically it is something like Jira or GitLab or GitHub or anything else where the actual work is happening, a project management suite, whatever. That is the typical place. Of course, for discussions that are more ephemeral, that could be Slack. But I would generally not recommend you to use Slack for important conversations that might be interesting over time because it is ephemeral. Some companies, and GitLab did this, have an auto-delete policy that every 3 months every message gets deleted, and that forces you to do that really, really well. So yeah.
Thank you, Al, for the upvotes as well. So how do you onboard and train your juniors remotely?
The same way. We just don't smell them. If you are working together in an office, how do you onboard and manage people and train people? Well, if you work remotely, you do the same thing. You can just not know how tall they are, unless they do a lot of effort, and you can smell them. That's it. You do the same thing. How do we do it? We make sure that we have, one, a lot of material that is available at all times, so asynchronously. So that's things like videos and written documentation that they have to review up front. Would do that in an office as well, because, well, it seems pretty obvious to not have to repeat yourself every time. And then if someone needs a lot of one-on-one coaching, which often juniors need, then you make sure you do that one-on-one coaching, right? Like you have the technology. You can't do this if the time zones are really mixed up, but generally between two people, it's almost always doable.
And yeah, we'll go with the next one. How do you manage stand-ups, retros, refinements, and reviews? Do you skip them completely?
Yeah, this is a great question. So each team in our organization manages their own, and you can do it however you want. We have teams that do these things depending on the nature of them asynchronously, so they all provide input in some way, shape, or form. And there's teams that do it synchronously, so they come together. And if you have a team that really wants to have a lot of these kind of meetings, then you have to make sure that the time zones are accommodating to that, right? So you have to make sure that they're somewhat able to all get together at the same time. So yeah.
Yeah, and I would like to go for the next one as well. For the poor souls who still work at an actual office, what should be the main intervention to bring the principles of remote work to the physical office?
Yeah, I think the first thing to do is how many meetings are you in? And then go through each of these meetings and make sure none of them are longer than 30 minutes. If they are, they're probably a useless waste of time. Then consider, are you actually contributing to them? And then consider, how could we get rid of this meeting? Right? I think one thing worse than meetings is recurring meetings. Because you're always going to have it. And so a good trick, and yeah, you have to have the permissions for this, but the good trick is to just delete the recurring meeting, have it not happen, and see what breaks. Or see, start using the phrase, can we do this async? Which is, can we do this async? It becomes very nice to say that, because every time you say it, you kill a meeting. And so that's a really, really good start. Because then you start to immediately realize, well, if we're not having a meeting, then I don't have the information. Okay, so if I don't have the information, how could I get it? If people were to write stuff down, where do they write it down? Okay, we need something to write stuff down, right? You go all the way until you solve for that meeting. I think that's a really good way to start.
Cool, and I think we'll do one more, as we're running everything quite live at the moment. Do you think text is an efficient way of communication?
I mean, yes. I think it's a great way of communication. The bandwidth of consuming text is incredibly high. The bandwidth of producing it depends a little bit on the person, right? And sometimes you need to use other ways. Asynchronous communication doesn't mean that all your communication has to happen through text. So you can record a video, you can record audio, and all of those things. Most of the tools, they transcribe them immediately. So even if you're not able to listen to things, you can still consume that as well. And so yeah, and if you have a quick back and forth, then yeah, maybe it makes sense to jump on a call instead of just writing text. But yeah, generally, yes, I think text works great. We've been using it for decades.
Perfect, thank you so much.
Thanks so much.
Another round of applause for you. As well. Thank you. Okay, so I've just been told there's been a slight adjustment to the schedule, so we have a speaker that's backing us up, preparing just now, and I think we'll be moving ahead in a moment. Yeah. So I'd like everyone to welcome to the stage Stacey, and thank you so much for stepping in for us. Yeah.
Let's see if we can get the tech to work. Back. So then, oh, that's fun. It's cool. I did a tech check this morning and everything works, so of course it doesn't work now.
It's like when you take your car to the mechanic, right?
Yeah, and that's still not working? Come on, you can do this, little computer. Ah, okay, I know what's going on, possibly. No, that's interesting. Honestly, this did work earlier. Anybody know anything about computers?
No. There we go.
Okay, we have a screen. This is good. Now, hey, look at that. PowerPoint can even see the screen.
Oh, thank you so much, Stacey.
Thank you. So, good morning, everybody. Now, I must admit, when I heard everybody had a hangover, I was going to do something deliciously evil and scream good morning to you, but I'll be nice, so I won't do that just yet. So, I'll just do my nice little good morning. So, I love working with my colleagues. And I love bouncing ideas between my colleagues and complementing each other's knowledge so that we can use our combined talents to solve some complex business or technical challenges. And I guess I just love working in close-knit teams. Unfortunately, throughout my career, that really hasn't happened as often as I would have liked it to. All too often, I've been in a team, but everybody's been doing something different. Different stories, different projects sometimes. And everybody was working on something different because for whatever reason, they wanted to be, or they had to be, independent from each other. And I find this an interesting word, independent. Because if we're independent, are we a team at all? Or are we simply a collection of developers working at the same island of desks? And that word, independent, it comes with some costs associated with it. Outside of that stand-up that we do in the morning where now everybody's talking about completely different things, and I'm sure we've all been there where everybody just zones out after 2 seconds because you've got no idea what the other people are talking about. But that's the only insight I get into what they're doing. And because of this disconnect, because we are losing some disconnect between our colleagues, it gets so much harder for us to bounce ideas between each other, for us to help each other out, for us to produce some awesome stuff. Because when we want to do that, we have to do all of that context switching that Joop was just talking about. And on top of all of this, for the person and the individuals, we see other problems within the team when this happens. First one is a work in progress. Everybody has their own story. Everybody has 2 or 3 stories. They're all waiting. We were not doing asynchronous communication. We were just waiting, and things didn't happen. And it took an age for a story to get through to being completed. And because each person picked up their own thing that they liked, it ended up that people had their own areas that they wanted to work on. And that gave us a huge problem with resilience. Because what happens if that person with their area wins the lottery and they quit? Or maybe more realistically, they just go on holiday, or even if they're just ill. All of these things provided us, or all of these things interrupted our ability to provide value to our customers in a timely fashion. But I said I'm going to talk to you about pair programming, and I've not done that yet. So why do I think that these things are connected? Well, one of the ways that I've found that can help us not falling into that trap of being independent colleagues working at the same island of desks is to pair program. When we do it, and when we get it right, we can work together, and I mean really together. We bounce ideas between each other, we encourage those better solutions, and we work to get things done. Hi, I'm Stacey Cashmore. I am a Tech Explorer DevOps at Omniplan, which is a financial advice software company that's about 3 buildings down on this side. For the last 2 years, I've been honored to be able to call myself a Microsoft MVP in developer technologies, and I've been coding since the middle of the 1990s. Over that time, I have worked in many different industries, companies, quite a few different roles. And I've seen lots of different ways that people and teams can work together. Some have been absolutely awesome, some really haven't. My previous job, I was working there for 14 years, and I saw the whole gamut of ways that we could work together. When I started there back in 2006, we had a department and we had no teams. Everybody was just an individual. In fact, my first assignment on day 1, by myself, was to introduce a really complex algorithm in the middle of the car insurance software. That was interesting when you've got no idea what you're doing and you're just given a laptop and get on with it. There were bigger projects, and they did have multiple people on them. But they all had their own facets, and they all owned their own area, and there was no real joined-up thinking. We saw the issues that this could bring to us. So in 2012, the company introduced Scrum, teams with stable products that they owned. The idea that we produce something as a team, and we work through to get stuff done. It didn't work. And it didn't work because all we did was put people together and say, get on with it. And we had complaints from the teams. Complaints like, well, how are we supposed to do this? We're all working on the same code base. Sometimes we even need to be in the same file. We're in merge hell. This is really slowing us down. This is impossible. So over the next few years, we tried different things to try and improve this workflow. And the last team I worked at before I left We did lots of experimentation. We tried lots of different things just to see what we could do. And one of the ones that we did was pair programming, and it was an amazing learning experience. It took a lot of effort to make it work, but we did get dividends given back to us on the effort for individuals, the team, and for the company too. So if I say that this is so fantastic, why is it not really done that much? Well, it's really hard to get right. I'm going to say that up front. And when it goes wrong, and if you're starting, it's going to go wrong, it makes it slightly less than great. And I want to talk about just a couple of things to do with that now. Number one is sleepy pairing. Now, if anybody's ever tried to pair programming, I'm sure that you've seen this. It's where you have two people, one computer. You have one person at the keyboard, and they're feverishly working away. They're thinking through the problem, they're coming up with a solution, they're putting it into the computer. They are flying. And you have another person, and they're generally doing either one of two things. Either they're sitting just behind the person at the keyboard, staring over their shoulder, making them feel really uncomfortable, or they're about a meter away. They're not really paying attention. They have their phone. And just occasionally they look up at the screen and go, yeah, okay, before going back to Twitter, Facebook, TikTok, shooting zombies in an MMO game for some reason, one of the guys I worked with. And I liken this to a long car journey. You have a driver concentrating the whole day. They are looking for traffic problems. They're trying to figure out which way they need to go. They're trying to keep everybody in the car safe. And you have the passengers. And you've got that backseat driver sitting behind the person at the wheel, watching everything they do, making them feel awful. You've got the person that just sits looking out of the window, watching the world go by. And you have the person that I'm really jealous of. They don't get motion sickness, and they can just binge Netflix until the battery's dead or their data's gone. And at the end of the day, the driver gets out of the car, they stretch, they walk inside, they've got a pounding headache, they just need to stop and recharge. The passengers, they are truly exhausted because they are bored because all they've been doing is sitting down for 8 hours, not actually having anything to really keep them triggered. And it's the same with our pair programmers. We have that person at the keyboard that's been doing all of the heavy lifting. They've been doing the same thing that they would normally be doing, only now they're doing it with somebody watching them, making them feel really bad and really nervous, and am I doing this right, and are they judging me? And that person watching over the shoulder, do not underestimate how tiring it is to watch somebody typing code when you're not involved. And they got the idea, this isn't a good use of my time. And that person a meter away with their phone, they have an awesome score on that zombie game. But they also know that maybe this isn't what they're being paid for, and they feel a little bit useless. So the next day, everybody returns to their own machines. They put on their noise-canceling headphones to drown out the open plan office when we're allowed there, and they go back to working independently. Previous day, it was a complete waste of time, and so is pair programming. But it's not only the navigator that can be sleepy. The driver can be sleepy too, and the results can be just as bad. I've seen this almost every time that a team started to move along their journey and they've introduced the driver and navigator roles. You have the driver, their job is to put the code into the machine. You have the navigator, and their job is to tell them what to put in the machine. Now, doing this does do one immediate thing. That person can't play on the phone anymore. That person can't just sit watching anymore. Neither the yupper nor the zombie killer can do that, otherwise the driver can't do anything, because they're waiting for the input from the navigator. We have involvement from all parties. We are working together to solve problems. The navigator's now thinking through the solution. They're coming up with the problem. They're telling the driver what to type. It kind of sounds like the idyllic thing that we want, this interaction between two people. People around the typist have to be actively involved now. No more yupping, no more zombies. Only I'm not so sure. There is a zombie here. It's just no longer on that phone game. It is the typist. and I'm using that word deliberately, typist. They're sitting there, they are bashing away on their keyboard, they are putting in what the navigator tells them to do, but they're not thinking about what they're doing, they're just simply following instructions. Have you ever seen stories in the news of drivers using satellite navigation and ending up in the wrong place? They end up lost. They end up in the middle of a field. The two worst stories that I've seen of people ended up in water, and one person who put in the street and the city, and it turns out it was in two different countries that were next to each other, and yet they drove across a border without thinking what they were doing. The navigation system says, "You have arrived," and you go, "Sure. Where am I? How did I get here? Why are my feet wet?" And so it is at the end of the day when we get into pair programming with a sleepy driver. The navigator, they are truly exhausted. They have been doing all of this thinking throughout the day, and they've been trying to tell the driver what to do, only that driver doesn't use the same keyboard shortcuts they use, they don't use the same extensions they use, things are taking longer than you want it to do. You can't carry on with your solution because if you lose the driver, you're going to have a huge disconnect and you're both going to get really lost. And that typist, bashing the keys with no thought. Yesterday, they were exhausted because they were doing all the heavy lifting alone. Today, they're exhausted because they've just been listening to somebody and putting the code into the computer that they say. And you know what? They didn't become a developer to put somebody else's code into the computer. I am not including Stack Overflow here. So the next day, we return to our own machines. Put on the noise-canceling headphones again, drown out the open plan office, and go back to working independently. Previous day, it was still a waste of time. And you know what? Except for really complex problems, so is pair programming. Now, these two issues, the sleepy driver and the sleepy pairer, I honestly don't think I've been in a team that's tried this. It didn't have to work through this stage, and we've got stuck a few times trying this. But there are things that we can do to try and get around this problem and to try and make the pair programming give us those dividends I was talking about on the effort that's involved. Tackling the sleepy navigator. Distractions. When we're in the office, we have a world of distractions around us. Too many of us work in open plan offices, which means somebody's having a meeting 2 desks down and they're really loud. People are walking past the desk and they're in your peripheral vision and they pull you down. You're a software developer and you've not got your fingers at a keyboard, so everybody thinks, of course, you're not busy, because if you're not typing, how can a developer be busy? And they keep on interrupting you. Some distractions are more virtual, like, say, our phones. I think I have one in here somewhere. I'm addicted to my phone. I think many of us are addicted to my phone. Quite often when I do this talk, there's like a few people go, as I get to this point. And it provides so much dopamine to us. We have Slack, Teams, Twitter, Facebook, WhatsApp, TikTok, email, all the other apps that we use. And the dopamine hits we get hit, there's been studies done, it actually changes the structure of our brain so that we just want to go chasing that dopamine. When you're coding, it's not too bad because your fingers are busy. When you're a navigator, your fingers are doing nothing and they can really easily go to your phone and start doing things. I can only speak for me when I say how I got rid of this, because I think this is a really personal thing. But the only thing that worked for me is getting rid of my phone. Now, I first tried this just by putting it out of reach on the desk next to me. That didn't work, because all I did was just go across, get the phone, check it, and then put it back. Great for the dagelijks beweging, not so good for actually trying to concentrate. The way that I got rid of it eventually was I was working opposite my colleague at the time, so my desk was behind his, and I tossed the phone really gently, glass smartphone, not a Nokia 3310, and just made sure I couldn't actually get close to it. And the result, it hurt. It really, really hurt. Like I say, I'm addicted to my phone. But after a while, that pain went away and I could kind of concentrate on what I wanted to do. I came to realize that most of the things that I was doing, it was just FOMO. all of that, Twitter, Facebook, WhatsApp, whatever else. It goes after a while. What took longer for me was emails. When I'm sitting at my computer, I can get a notification if an important email comes in. Now, we can have a discussion on whether or not that's a good idea or not, but it was there. And it meant that if there was an urgent question, I could answer it. If there was a big problem and we needed all hands on deck, I would know about it. If production was on fire and the website's down, again, I know about it, I'm there, we can deal with this. When I'm working with somebody else, I don't get those emails, but I have them on my phone, so I can quickly check every 5 minutes. Is there an email? Is there an email? If I don't have my phone, I can no longer do this. And it took me a while, but eventually I realized, you know what? If I don't answer an urgent email, it's not the end of the world. Because I've not disappeared. People know where I am. People can find me. And if they're not actively looking for me, then I don't care how urgent they say that email is, it's not that urgent. So working to remove the distractions, we could get more into the flow and work better together as a pair. But we've only done the navigator so far. So for the driver, this wasn't a personal thing. We had to figure out as a team how we're going to work together to get this driver problem solved. And we did this by re-examining the driver and navigator roles. So we expanded it a little bit. The navigator, somebody who thinks of the solution, but doesn't tell the driver what key presses to do. Rather, they explain their solution to the driver, and they do it in such a way that the driver understands what they want to achieve, and they can then do something. And the driver is somebody who listens to the navigator, works to understand what the navigator is trying to say, and then puts their own solution into the system. Returning to our driving metaphor one last time. When you're driving, and you've got a sat-nav, your job is not to follow everything that it says without thinking and causing dangerous situations on the road. Rather, your job is to look at the instructions, to think whether or not they're safe, to think whether or not they are right, and to get your car and your passengers to the right location safely. And so it is with the driver in pair programming. It's not to put that if statement on line 19 and making sure that you call that variable timer or whatever else. It's your job to make sure you understand what you are putting in the system and make sure that you agree with what you're putting in the system. And when you don't understand it, you just simply don't code anything. And as a navigator, when you're in this situation, your job is to change how you're explaining it. Try and help the driver get that level of understanding. More often than not, we actually, when we fell into this situation, stood up, went to the wall, and started using whiteboard markers to do lots of diagrams to get our thoughts out. And that had even better effects than just talking about it. And don't think it's easier as a driver either, because as a driver, at some point, it's going to click in your brain. You know what you need to do now. You have this awesome idea, and what you don't do is put your undoubtedly amazing solution and code into the computer. Second you do that, you've got a very sleepy navigator, because they don't know what you're doing, they don't know why you're doing it, and they're not involved. So rather, you excitedly pass your keyboard to the navigator, you explain your awesome idea, and you switch roles. And if we ensure that each person fulfills the roles in this way, without distraction, then we can move from sleepy pairing into strong pairing. And this gives us a lot of advantages inside of our team. The first is a collaboration that we had as a team. It went from nobody knowing what was going on to really working together, to making sure that we had similar solutions, or we had solutions that we all agreed with, that we all understood, and actually finishing things. We started to bounce ideas between each other when we were trying to explain what was going on. We helped each other improve. We helped each other improve our knowledge of the domain, the tech stack, and how to combine the two to make something that users were going to find really useful. We communicated more, and we communicated in a far better way. Now, this one is a little bit chicken and egg for me. I don't know if we improved our communication and so we started to pair program better, or if we started to pair program better and our communication kind of evolved as we did so. Either way, the end result, it was far better than it was before. And that meant that we were sharing knowledge far more, which meant that when that person won the lottery and quit, or went on vacation, or was just ill, I'm not going to say it's great, but it's not the same issue that it was before, because we still have one person who knows what's going on in the task, the other person in the pair. And they can then pair with somebody else, and then we spread the knowledge yet again. Another thing that improved when we started doing this was our pull requests. They used to be quite a nightmare as you finish your work and you throw it over the fence and you wait for somebody to pick it up and they do something with it, and a couple of days later it comes back with comments. And it's like, do I interrupt what I'm doing or do I wait? You answer the comments, you throw it back to the other person, they've then got to do the same thing again. And I've literally seen pull requests take a week or more to finish. And it was just a nightmare and so frustrating. When we were doing pair programming, we were validating the ideas we were coming up with as it came from the navigator into the driver. When the driver was translating those ideas into code, the navigator was checking what we were putting into the machine was actually correct. So when it came to pull requests, and we also helped each other keep them smaller and more manageable because we kept each other on track, basically we just double-checked what was going into the commit, made sure we both agreed with it, made a pull request, the navigator approved it, we grabbed a coffee, and then we could continue with the next task. Now there's one thing here, it is super important that you don't skip that last bit. You have to double check what you are putting in the commit because things can always creep in, and from experience, if you are not double checking your commit when you do this, this whole benefit disappears entirely and you get to the point where pairs can get blinkered and it can actually be worse than not doing it together. The last benefit that I want to talk about today is onboarding. It's not something that we're expecting to improve with pair programming. We kind of found it by mistake, but it did actually help us a lot. Starting a new job. You get a computer, you get introduced to 100 people whose names you instantly forget, and then you go back to your desk and you get a pile of paperwork or a wiki link or whatever else, and you work through what you're doing. I've been in companies where the management has said they don't expect a developer to be productive for 1 or 2 months because of the complexity of the system. And I just think that's mind-blowing that that's something that's accepted. But rather than doing that, how about, once they've got their machine installed, once they've forgotten everybody's names, we put them with somebody who knows the system. The newbie gets all of the insights from that experienced person then. How the domain works, where to find the code, what processes we use, why certain decisions were made, where we can find things. And it's not all one way, because that experienced person, they get the input that only somebody with no preconceived ideas about a project can bring in. These newbies are going to bring up questions that everybody else knows, but they ignore because they've just been there for so long, it's just accepted. Now, this isn't going to be as predictive as 2 experienced people working together, but it's an awful lot better than saying we don't mind that person not being productive for 2 months because they've got to get used to everything. Now, one of the things that I get asked a lot is why I am so passionate about advocating for pair programming and why I try and do it. And I like to paraphrase G. Paul Hill on Twitter with what he says about test-driven development. I love pair programming because we are in this for the money. In my experience, when practiced, when done right, pair programming has allowed me to get value into the hands of users quicker, with more thought put into what we're doing and how we're doing it. I love pair programming. 1 or more people. I love it because of the benefits that I can see that it brings to me, to the team, and to the company. Now, make no mistake, this is hard. If it was easy, I wouldn't be talking about it. It'd just be the default way of doing things. But I invite you to give it a go. Go through those sleepy stages. See what you need to do to solve the pain of what you find and see what benefits it can bring you. I've been Stacey Cashmore. Thank you so much.
Thank you so much. Thank you so much, Stacey, for stepping in.
You're
this is
welcome.
for you. And I'm just double checking if we have any slides, questions at the moment. Doesn't appear like they're popping up at the moment, so I think.
Fair enough. Oh, we do?
Oh, we do.
We do.
Do you have examples where developers apply their pair programming with end users, customers, also attending during the process?
Kind of. I have one example. It's from many years ago, but it's one that always sticks in my head. It's also how I started working in an agile way. I was working for a company. I was thrown in the deep end of basically just been told in an interview, hey, do you want to manage this project? And I had no experience. So I went, yeah, sure, because I'm not going to turn it down. But I went to see my customer every 2 weeks. And we went through the code went through what we'd produced, and they were semi-technical. So we also kind of went through some of the changes that we could make for performance, for other things. We even had one person who really hated how slow one part of the system was and came up with his own solution on how to make it faster. And we actually worked through that together. It turned out the bit that he made fast was already fast. We just had issues with data, because in 2000 it took a long time to process. But we had great collaboration with that customer, and it made working on that project amazing to do. So it wasn't pairing directly with that customer constantly, but it was getting that input both on a product and on a more technical level at regular intervals, and really making sure we had that close communication.
Thank you. And I can see the upvotes coming in, and I really want to do the next one as well. Any tips on how to deal with imposter syndrome while pairing?
I don't know about the imposter syndrome itself, but you do need to make sure that you have psychological safety in the team, because part of pair programming, when you are improving your domain knowledge, when you're improving your tech knowledge, is to be able to say, I don't know how to do this. And the best thing that I can say, as I've got more senior in my career, it is for us as seniors to show the leadership and to show that it's okay to say that I don't know this. I've learned an amount from junior developers, and I try and make sure that I show that openness so that the junior developers can also see that you don't have to know everything. And by working together, we can actually fulfill things. I don't know if it solves the imposter syndrome, but it at least opens up the space for the psychological safety.
Appreciate it. Thank you so much.
You're welcome.
Round of applause for Stacey. Thank you so much. Okay, so up next we're going to hear a few words from our sponsors, and on stage first is going to be Schubert. Schubert Phyllis, sorry.
Hi, morning. My name is Radek. Yesterday, a few of my colleagues came here on stage. They told you about the food, the train, and how we've been a part of this community for the last 10 years. And like, I want to expand on the last bit by saying what we do at Schubert. And well, what we do is we share our thoughts, opinions, and feelings freely and frequently. We plan, build, and run the psychological safety needed to do that. And yesterday on this stage, we had Amanda and Nathan tell us about the DORA metrics, the 4 technical ones, and then the cultural one. And if you visit their booth, they have a really cool mind map where psychological safety is one of the pieces of the puzzle. So if you want to talk about it, or how it's fundamental to really create a generative culture, a shout out to Ron Westrom, feel free to grab a hold of me or one of my colleagues, so we're easy to spot. And otherwise, have a great day. Thank you.
Thank you so much. And up next, we're going to hear from Contrast Security.
Hey, good morning. I see a lot of tired faces, so as a beer sponsor, I think we did a reasonable job. I'm thinking about branded aspirins for next year, for the second day. But yesterday I told you about how we improve AppSec programs by observability, because it's really difficult to scale AppSec programs because of all the false positives, because the security knowledge you need to have. We fixed that, as I mentioned before. Come and go to our booth to learn more about it. We'll show you a quick demo. We also have a raffle, a Nintendo Switch. So if you want to join the raffle, just come to our booth and sign the QR code, basically. Thanks, guys.
Thank you. And up next, we'd love to hear from Elastic.
Hello, hello. How's it going? Okay, I came yesterday to talk about a lot of stuff. So I'm Arvind. I work at Elastic as a developer advocate. Elastic from Elasticsearch, Logstash, Kibana. So if you have questions about Elasticsearch, if you have doubts about anything related to Kubernetes, cloud native, microservices, we are here. You could ask questions. We also run a raffle as well. And I don't want to take all my swags back, so please visit us. Thank you, and have a nice one.
Thank you so much. And up next, we'd love to hear from Nosana.
Hey everyone. I hope you had a great day yesterday. Just in case you need it, Nosana will be offering free drinks during lunch. So yeah, free drinks during lunch if you need something else than a coffee in the bar downstairs. Now we have your attention. So I've spent a lot of time and energy maintaining and contributing to open source repos. And I think, like many of you here, I've done this with a lot of love and passion, because open source has created these beautiful, tight-knit communities that are working together to build today's software. But when it comes to CI/CD, this love story abruptly ends. Because when you hand over control to an external company to compile and deploy your code, is this really necessary? Not anymore. I'm Jesse, and I'm introducing Nosana. Nosana is the first CI/CD platform that uses crowd computing to run your pipelines. This means that your community can run your pipelines using their own hardware, like their mobile phones, their laptops, or their server racks, and they will get rewarded for it. Not only is Nosana completely transparent, but it also offers a layer of security and trust among your users, because we provide an audit trail between your compiled binaries and your source code. Well, I can see a lot of you here are very passionate about open source. So we are offering €1,000 of free pipeline credits, especially for DevOps days. So if you're interested, please find us or go to nosana.io/devops. The power and the future of CI/CD will be powered by your hands. So thank you.
Thank you so much. And last but not least, we'd love to hear from Cosley.
Hi everyone, I'm Mike. I'm the CEO and co-founder of Cosley. Cosley's like a database for your DevOps. It looks a little bit like a version control system. So kind of like Git, we have snapshot-based content addressable storage for all the dynamic stuff that happens after Git. So your builds, your deploys, your security scans, and we also track how your environments change. So for instance, you can do things like log an environment, do the diff between staging and prod, and check out what was in prod at any given time in history. And we do this for Kubernetes, for Fargate, for EC2, for S3, pretty much any kind of runtime environment you might have. So if that sounds like fun and interesting, come and talk to us. We've got stickers, a few t-shirts left for kids, and yeah, we're hiring. So come and say hi.
Thank you so much. And organizers are keeping me on my toes today, and I think up next we do have Wemanity. Yeah. Yes, thank you.
Thank you. Good morning, everybody. I'm Danny Egler. I'm working as a DevOps coach for Wemanity. And at Wemanity, we do Agile and DevOps coaching transformations. Really fun company, headquartered in France, around 400 people in total in the whole of Europe. In the Netherlands, we're especially focusing on transforming teams, enterprises, changing the way they work, not necessarily agile or doing a safe transformation by the book, but really changing the way they work with measurable efforts, measurable results. And we're looking for new people. We're looking for tech people who also like to go into coaching, not into coding, but into coaching. So if you want to make the transition or you want to know more about the company, please visit the booth. We don't have t-shirts anymore, but we do have stickers. Thank you.
Thank you, thank you. Okay, I think we're just going to keep the show rolling while we can. It seems like we're running about 5 minutes over, but we'll do what we can. Please do remember that the Slido's up here. Do ask your questions throughout the talk. And as for the next talk, I'd like everyone to welcome to the stage Deepu, who's going to be talking about is containerless the future of Kubernetes?
Okay,
Okay, I'm going to... is it supposed to come up here? Yes. Okay. Okay, I'm going to put this in somewhere. Yes. Yeah, works. So, hello everyone, and you all look quite fresh. Morning beer? No? Okay. So, welcome to my talk. Thanks for coming. Today we're going to talk about the future of Kubernetes and if containerless can be part of that. So, short introduction. My name is Deepu K. Shashidharan. I'm the co-lead of JHipster and Java Champion. I do a lot of open source. I have built tools like K-Dash, nifty dashboard for Kubernetes, among other things. Polyglot developer, author, speaker, all those developer advocate stuff. I work as a developer advocate for Okta. So do check Okta out if you're, if you urgently need some security, because we find your lack of security quite disturbing, if that's the case. Hopefully not. Okay. Containers on Kubernetes. I hope most of you are familiar with how containers work and how Kubernetes works and how they work together. That's why I hope you are in this talk. But just to refresh our memory, I think we all can agree that Linux container technology revolutionized the way that we work with software, right? It revolutionized how we build and deploy our software. Gone are the days of app servers, WebLogic, and JBoss and stuff, and bare metal infrastructure where you have to, constantly manage fiddle and stuff. Now we do the complex dance of orchestrating our containers using Kubernetes on cloud platforms and stuff like that. So we have wantedly or unwantedly made our stacks much more complex in certain ways, but we also made our life much more easier in terms of how we build and deploy software. So that's all thanks to the Linux container technology. So tools like Docker and Kubernetes have become irreplaceable in our stack these days, right? Anybody here who does not use Docker or Kubernetes? Oh, yeah, 2, 3. Whoa, 4 people who do. Really? No Docker? You have never used Docker? Wow. Okay. Huh? Lucky people, yes. So in some ways. Unlucky in some ways, but yeah. I have done. I used to do JBoss and WebLogic and these kind of things back in the days. I'm not that old, but still. Again, to refresh our memories, so a container image is technically nothing but a layer or a snapshot of a file system, right? A container runtime unpacks these layers and makes it into a sequestered file system. And to the application that you're containerizing, this file system is the root file system, and it will to the application to look like an entire OS. It doesn't know that it only has parts of the OS that is required for that particular application. It doesn't have everything. So that's basically a container image, right? On Kubernetes, there are 2 important layers that makes it possible for you to run containers inside a pod, for example. So there is the CRI, or container runtime interface. So Docker, Podman, Containerd, these are the stuff basically that forms this layer. And then there is a lower level. So this is the high level runtime. And then there is a lower level runtime called the Open Container Interface, the OCI runtime. So cron, runc, yogurt, and these are the stuff that normally forms this layer. So these 2 together makes it possible for you to run containers on Kubernetes. So again, before I go to containers, we also have to understand the advantage of containers, right? It was not something that was useless. Of course, today's infrastructure is much more complex than it used to be, and we joke around about having to use Kubernetes and having to use Docker and everything. But jokes apart, they actually made things much more easier to do, and it made building stuff on scale possible. That's why we now have stuff on scale. That's why now we have complex microservices, because it has become so easy to orchestrate them using Docker and Kubernetes. That's why we are doing this complex stuff. Back in the days, it was way more complex to even imagine doing things that we could do today with Kubernetes. So that's one reason it has become complex. So container images are much more lightweight compared to their VM counterparts or var jars and stuff that you used to do. They use much less system resources than a VM. They are much more portable, consistent, reproducible builds. That was one of the best-selling points for container images. They are faster to boot and run than a VM, and of course, easier to scale, more secure, and much more. There are many more smaller things that you can find as advantages. Doesn't mean there are no disadvantages. Of course, container images are quite OS dependent. We can only run those in Linux and Windows, for example. They are also architecture dependent, so they are not they are portable, but not that portable, And they still need a lot of OS primitives. So depending on the application that you're containerizing, you still have to include everything that the application would, all the OS primitives that the application would need. You still need that. You need a thin layer of something that is closer to an OS there. You still need that. And containers provide a secure sandbox, but it doesn't provide us that much control over that security. Of course, you can script your way around. You can do stuff with whatever you can do in a Linux kernel kind of thing. But still, it's not very fine-grained. So these are some of the disadvantages of containers, and keep this in mind when we talk about containerless. So containerless, again, not a real word like serverless or whatever we invented, so it's not a real word. It's nothing but WebAssembly with WebAssembly system interface. So WASM plus WASI, that's about it. So WebAssembly, or I like to call it WASM. It's easier to pronounce and put in a sentence. So it's one of the most exciting and underrated technology that that have come out in the recent past. It's a binary instruction format for a stack-based virtual machine. So a runtime knows how to run WebAssembly binaries. So they are all in a standard format. So you can have any runtime. You can put a WebAssembly binary on any runtime, and it will figure out how to run it. You don't have to worry about providing OS primitives. You don't have to worry about adding a thin layer of the file access libraries or thin layer of whatever your application is going to do. The runtime will figure it out. It's quite similar to how you will run a binary on your operating system, like a binary application on your operating system. Your operating system figures out how to run it, how to make it work. So the WebAssembly runtime will figure out how to make it work. And this binary is supposed to run at near native speeds with a memory sandbox and with a secure memory sandbox. So WASM is also highly portable. It's cross-platform, language agnostic. It is supposed to be a build target for languages. So if you're working with the language, then this is a build target for that. It's not like how you would build for OS X or Windows, whatever. So it is another target. So WebAssembly, as probably most of you know or don't know. So WebAssembly, from the name web, was originally meant for the open web platform. It was invented as a way to speed up your JavaScript applications. So you can have something in your JavaScript application that is much more faster. You can do faster computation. That's why WebAssembly was built. But WebAssembly now has found usage way outside of the web. It is now used in the cloud, IoT, of course in the web, Kubernetes, Dino, Node.js, and everywhere. It has found use cases outside of it. So do check out the link if you are interested. There is a lot of useful information there. So this is what Solomon Hykes, the co-founder of Docker, has to say about WebAssembly. And he's right, actually. If we had WebAssembly back then probably we might not have invented something like Docker. We might have started building everything towards WebAssembly, and we might have had an ecosystem where we are just deploying applications using WebAssembly. So, but that's not the case currently. Let's see how it works on Kubernetes. Again, exact same thing as we saw earlier. The only difference you can see is there are no containers. So it's like there are no containers with your app and then the libraries and stuff. There is just binaries. So WebAssembly binaries, you just put them on your pod, and your OCA runtime will figure out how to run it. Of course, your OCA runtime should have support for WASM. There are multiple ways to go about it. So the binaries are in a standard format, right? And as I said, the runtime can figure out how to run them. So, which is quite similar to containers, right? It sounds very similar to containers. And WebAssembly is even more efficient than containers because it is faster, it is lighter, it is much more portable, and projects like WasamTime, which is, they try to implement the WASI standard. WASI is nothing but WebAssembly system interface. So WebAssembly originally was meant for the web, so they had to come up with a new standard to make it work outside the web, because there are things that you do outside the web that you normally don't do in the web, right? So that is the WASI specification, and WasamTime is a project that is trying to implement the WASI specifications. They have projects, so they have a runtime which you can use. So they all make it possible for us to run WebAssembly on Kubernetes before we go into details. So WebAssembly on Kubernetes, of course, is relatively new. There are a lot of rough edges at the moment. It's probably not production ready for every use case. You can do some use cases in production, which is stable, but not every use case. The workloads can be extremely fast, so fast that normally, if you have the same application as a Docker container and a Wasm binary, the Wasm one would execute even before your Docker container has initialized. So it's that fast. And currently, there are a lot of rough edges aside, but there are also workarounds to, if you really want to do it, there are workarounds. I'll come to those a bit later. As I mentioned, so for Kubernetes, nothing much has to change. Some runtimes have support for Wasm, and if not, there are always Wasm shims for your CRI runtimes. There are plugins that you can add to add support. There are plugins you can install onto your runtime to add support. So it's all possible. And if you look at existing ecosystem, so if your Kubernetes provider or if your Kubernetes installation has any of the components in green, then you're already good to go. So for example, if your Kubernetes distribution uses cron as the low-level runtime and Creo or Containerd as the high-level runtime, then that means it can already run WebAssembly, because the cron runtime has built-in support for WebAssembly now, and this combination will, with this combination, you don't have to do anything. You can just run WebAssembly on those Kubernetes setup. And of course, the tools like Kubedge, K8s, Kind, and all these, they also have some sort of support for running WebAssembly. And of course, in order to run WebAssembly on Kubernetes, you need to have support in your registries as well. So any OCI compliant registry actually can have Wasm binaries in it as well. So in an OCI compliant registry, you can have Docker images, you can have Wasm binaries, and the OCI containers which supports WebAssembly can pull from those registries. Currently, unfortunately, Docker Hub doesn't have any support for. Docker Hub is not OCI compliant, so you can't put Wasm binaries there. But we also have GitHub Package Registry, the Azure one, and the Google Container Registry, which supports OCI specifications. So you can push your Wasm binaries there, and your Kubernetes OCI runtime can pull from those. And when it comes to language, again, not every language has support for WASI at the moment. For example, like JavaScript has Wasm support, but it doesn't support WASI. So you cannot build applications in JavaScript and put them on Kubernetes. But of course, you can build applications and put it on Kubernetes using any of the ones in green, like Python, Rust, Go, Ruby, .NET, etc. So this is kind of the top languages. There are also a few other languages that has support. I think Objective-C has like partial support. I think R has support, stuff like that. So I think I mentioned most of these advantages in passing when I was talking about why WebAssembly is groundbreaking and stuff like that. So again, to summarize, the biggest advantage of WebAssembly is the speed. Because WebAssembly binaries can execute at near native speed, and I mentioned they can execute faster than containers it takes to start. And near zero cold start time, which is very important for use cases like serverless, functions and stuff. When serverless and like cloud functions started becoming a thing, everyone was like excited. Hey, yes, now I can have stuff that needs to run only on demand. But then the reality is you define those functions or whatever, and then you have to keep them running because of the cold start delay, right? So if you want a fast response time, then you have to keep them running. Then what's the advantage of having on-demand functions, right? But with WebAssembly, you can actually have on-demand functions because they start so fast, the cold start is near instantaneous, that you can actually have on-demand functions for any kind of use cases. And a lot of cloud providers are actually like using this. Clever Cloud, for example, is working on that. I know I read some articles from Azure, who is using WebAssembly for these kind of stuff. I think Alibaba Cloud is doing something for their the cloud function stuff with WebAssembly. So you can use WebAssembly for those kind of use cases where they would shine really well. And the second most important thing is the security isolation or memory sandboxing that WebAssembly provides. So WebAssembly has this least privilege model for security, and any kind of, for example, file system access, or resource access has to be predefined in your application. So it's more kind of like how Android permissions and stuff works. So whatever you have to do, you have to predefine that permission. So it's highly fine-grained, so the attack surface is very much reduced. It depends on how you design your application. You can design an application with the exact permissions that it needs, so which is much more secure. And even if there is some sort of malicious code running in your binary, it will not have a wide attack surface due to this model and due to the fact that WASI applications follow the least privilege principle. And memory safety and efficiency, of course, the binaries are quite efficient. WebAssembly has a linear memory model, so it's much more memory safe as well. They are really lightweight and portable, truly portable across operating systems and architecture, because you're building a binary for WebAssembly. You're not building for OS X or Windows or Linux or whatever, and doesn't care about architecture. You build a binary, it will run, it should be run, any runtime can run it wherever they are deployed. And the runtimes will take care of architecture, OS, and stuff like that. So you don't have to worry about that. And of course, no technology, there is no technology without downsides. WebAssembly also has its downsides. The biggest, in my opinion, when comparing to container technology, because that is what we are trying to see if this can replace, right? So the biggest is you can't just take an existing application and WebAssemblify it. Like you can take anything and containerize it. You have a, 20-year-old application, and probably you can take it and containerize it by doing some magic around some scripting and whatever it takes. But you can still containerize it. You won't be spending months on it. You might spend maybe days or weeks on it, but not months and months, porting them. But that is not possible with WebAssembly. Even if you take a modern application, making it work as a WebAssembly binary is a lot more work, because WebAssembly standard and the WASI standard, they are much more strict, and not every library that you use can compile to WebAssembly. So you have to make sure that your application actually can compile to WebAssembly. That means when you try, things will fail. You'll start seeing, okay, this library doesn't work. Or, okay, I'm using this particular library, which doesn't have WebAssembly support. So you'd have to replace library. So it's not a trivial thing to just take any application and, hey, I'm going to deploy this. You cannot just decide that, hey, I'm going to containerize my application. That is, you can actually do that. But here, no. You have to work towards that. So ideally, you have to design your application with this in mind. That okay, I need to deploy this as WebAssembly. So you have to start from there, so that's a huge barrier to entry, I would say. So this technology is also suitable for newer applications where you can actually design with this in mind. All the rest of the downsides kind of have to do with the fact that WebAssembly WebAssembly is not that new now. It's quite mature, I would say, on the web. But VASI is quite new, and WebAssembly on Kubernetes or on the cloud is quite new. So that means some things are not finalized. For example, networking is not finalized in the VASI spec. File access and all those things are, but networking is not. That means a lot of the runtimes currently doesn't have any networking support. You'd have to add some experimental plugins, or you'd have to, do some workarounds. That means network isolation, security around that is also not still finalized. It's still not mature. It's still evolving, and the ecosystem is quite small at the moment. So these are the main disadvantages. So since we are talking about ecosystem, let's look at the current ecosystem that we have and what you can actually already do. So first up is Crustlet, which is a kubelet written in Rust. So you will see Rust a lot in these examples. Crustlet can run a Wasm OCA workload in Kubernetes. You can schedule Wasm pods based on tolerations with your standard Kubernetes manifests and stuff. It's a CNCF standard project, can be installed on most Kubernetes distributions, including the cloud ones, Kind, Minikube, and so on. It doesn't have networking support, but there is, depending on the language you're using, for example, if you're doing Rust, there is a library that can add that support. It's experimental, I think it's called Wasm experimental HTTP. You can use that library to add the support. So depending on the language, you might or might not have networking support. So I have a blog post about using Crustlet on Kubernetes on the Octadev blog. Do check it out if this sounds interesting. So this is how Kubernetes pod definition would look like with Crustlet. So you can see the annotations, they actually define the permissions that the binary would have. And the tolerations, they are defined so that the normal Kubernetes pods do not schedule these. Only Crustlet-enabled pods will schedule these. So I can show you a small demo. Am I on the right space? I hope so. Nope, not on the right. Okay. Yeah. So this is K-Dash, the monitoring dashboard I built. So you can see that I actually have a Crustlet node. The thing with a lot of error running, that is Crustlet. So it is providing that node with Crustlet support. So I have a Crustlet node on my local Kubernetes installation, and you can see I have this particular thing which failed, apparently. I think I didn't do any sacrifice to the demo gods today. So yeah, normally you have to always do that. Otherwise, this happens. But yeah, I'm just going to reapply it. The easiest way to fix things on Kubernetes, delete and redeploy. Right? Yeah, so this is a Wasm binary. It prints cat facts. So, so this is running on Kubernetes, and I think, so this is the image being pulled. So this is the Rust Wasm is the image being pulled. It's on my GitHub package registry. So let's get back to, which one? This one, yes. Yeah, so that's about Crustlet. So another runtime. So Crustlet is not a runtime. It uses Wasm time as a runtime. It's a kubelet. Now we have a lot of runtimes. So Wasm time is one of the most popular one, which started implementing the WASI spec. Again, written in Rust. It's kind of a JT style runtime. You can run Wasm outside of a browser using Wasm time on as a CLI or as an embedded thing on Kubernetes. So it has a CLI and a library. So you can use the library, which Crustlet does. Crustlet uses the Wasm time library to run Kubernetes. You can also use the CLI to run it locally and stuff like that. Very fast and secure. they're quite compliant to the WASM-WASI standard. Does not have networking. You'd have to work around, as I mentioned, yeah, used by project like Crustlet and Spin. Spin we would see a bit later. Then there is Wasmer. Another, all these are open source. All these projects that I'm showing here are open source. So another runtime, again in Rust. So they focus a bit on running WebAssembly on the server. They don't really, yeah, they have a focus of running on server. They also provide CLI and language SDKs for Rust and Go, Python, etc. They're used by a lot of projects like Open Policy Agent, Clever Cloud uses it, Hyperledger, Scalable, and all these projects, they use Wasmer. It's a bit more mature than Wasm time. It's also fast and secure, can run Wasm modules or can run Wasm modules embedded in other languages. Then we have Wasm Edge, which is slightly different. It's again a runtime, but it is focused on edge computing, and it's written in C++. Wasm Edge can run on Kubernetes because it is compatible with Dapper and Kubernetes, but it can also run outside of Kubernetes as some sort of edge computing, distributed edge computing setup. So it can power serverless apps, yeah, embedded functions, microservices, and all these stuff. It has SDKs for some languages. It can be used as an OCI compliant runtime on Kubernetes. So you can, if your Kubernetes distribution doesn't have support for Wasm, then you can use Wasm Edge as the OCI runtime to get that. Yeah, this has networking support because they are not strictly following WASI standards. They just make things work. So it has networking support. So Wasm Edge is actually already baked into the CRUN OCI runtime. So if your distribution has CRUN, latest versions of CRUN as the OCI runtime, then it already has Wasm Edge in it, so you can run WebAssembly on it. They have a nice quick start to get started if you're interested. Then we have Wasm Cloud. Again, written in Rust, focusing on distributed actors rather than Kubernetes. So this, it can bridge with Kubernetes, or it can run on Kubernetes as normal containers and stuff, but that's not the point of Wasm Cloud. The point is having something outside of Kubernetes that can do distributed microservices as actors. So they follow this Kafka kind of model. Very secure and fast, has SDKs for Go, Rust, and everything. It also uses OCI registries to pull artifacts, but as I mentioned, can work outside of Kubernetes. Then finally, we have a company called Fermion that is doing a lot in this space. They have a WebAssembly platform, again, replacement for Kubernetes kind of, sort of. And they have some tools that you can use to build and deploy WebAssembly binaries. So the platform provides most of the things that you would expect from Kubernetes or like a service mesh, like orchestration, service discovery, package management, and all this stuff. And they have a project called Spin, which is, again, open source, which you can use to build WebAssembly microservices and stuff like that. So again, fast and composable, written in Rust. They also have a micro CMS, a WebAssembly micro CMS that you can use. So with this setup, like what Fermion offers, Kubernetes is not required. It's redundant because it offers everything that you would use Kubernetes. So if you are going to do WebAssembly, then this might be much more efficient than putting it on Kubernetes. Of course, you can do it on Kubernetes, but this might be a bit more efficient. Of course, again, depending on what you're doing, again, this is new, so it's not going to completely cover everything that Kubernetes does, but for most use cases, they provide some sort of solution, and it's going to evolve. So all this is evolving, so that's the most important thing. So yeah, as I mentioned, so it's evolving. More platforms and projects are coming. More people are seeing the advantages. The cloud vendors like Amazon or Google or Azure, they have all seen the advantages that WebAssembly can offer. So they are all working on providing support. So I think it will be. I think soon their Kubernetes distributions or their serverless platforms, they all will start supporting WebAssembly binaries because I think it is inevitable. And when it comes to language ecosystem, I think Rust has one of the best tooling and ecosystem for Wasm. It's also my favorite language. So you saw a lot of these projects are also written in Rust, right? So Rust or C++, because when you look at the advantages of WebAssembly, you combine it with Rust, then you get real speed and memory efficiency. So non-networking workloads are a bit of problem now. There are workarounds and plugins. Once the spec is stabilized in WASI, I think if all runtimes will start implementing that, then we will have that bridge crossed. So containers are definitely here to stay because we cannot just Wasamify any application. So all those use cases will still be handled by containers. So Docker containers and WebAssembly can work side by side in Kubernetes or outside wherever. They can work hand in hand. New applications could actually consider WebAssembly from start on so that it can be designed with that in mind. And cloud providers have already started offering these services and it will soon be there. So I think at some point we'll be there where containerless is also an option. So thank you for coming, and I hope this was useful. Thank you.
Thank you so much. This is for you.
Oh, thank you.
No problem.
Questions?
We may have time for one if we have one.
Okay.
Pushing one question, I think.
Yeah, there is.
Try to.
Very quickly, can you elaborate on the limitations of no networking? I don't know that much. I'm fairly new to Kubernetes.
Oh, yeah. Yes, it's a big one at the moment. So the sample that I showed you, the cat fact thing, it is actually doing networking. It is calling an API to get the cat facts. So you can do it, but I'm able to do it because I'm doing it in Rust, and there is a plugin that bridges that gap. But again, that plugin is not compliant to the WASI spec. That part of the spec is still being finalized. So all these plugins and workarounds can be used. Your binary to outside call is easier, but building a WASM binary as a REST API that you can call is much more difficult today because there are no plugins that does that, and the standard is still not there. So that part is not possible. So ideally today, again, this is only if you're using something like Wasm Time or something. If you're using Wasm Edge or Wasm Cloud or Fermion, they all provide full networking support and everything. So that's a different story because they don't follow the spec exactly. Once that the Wasm Time is the one that follows spec exactly, so Crustlet and some projects that uses it will have the limitation, and currently you can do things that like jobs or like file processing and these kind of things. Again, it will be nicer because it will be very fast in these. So that's the limitations currently. But networking is, with those.
Cool. Thank you so much.
Thank you, everyone.
Okay, so I just want to respect everyone's valuable coffee time as well. We'll make sure that we get that moving right now. One call out is that there's been some lost and found, some glasses. Please go down to reception if you feel you're missing anything. Please do go visit our sponsors throughout the floor here. And we'll probably be starting off, if I can do my math quickly, probably about 10 past 11 or so. Check, check. Yep. Hey everyone, welcome back. I hope you all had some coffee. For those that are sitting outside, please make your way back upstairs as well. I think my voice is audible outside. My apologies for that, but you got to live with it. So just one small announcement for those who've been going to the sponsor booths and entering raffles. The raffles are going to be conducted after the close of the open spaces today. So when the open spaces all finish up, please all kind of come back to the room. We'll be doing the sponsor raffles. So we're going to be moving straight into our next talk, and I would like everyone to welcome to the stage, Leanne, who's going to be talking about secret management the soft way.
Woo. Right, can you all hear me okay? Yes, we can. Okay, yes, take your seats, welcome, come back from the outside where it's raining, but from where I hear, so not great time. I'm just trying to time my talk so I know what I'm doing. All right, great to be here, great to be in person, great to breathe on everyone again. I really missed that. I only have 20 minutes, so I'm going to be really quick about everything. So first things first, my name is Leanne Lee. I'm a developer advocate at Loft Labs. We are a company that's trying to make multi-tenancy on Kubernetes slightly less of a pain. You can reach me if you want to talk to me later on the Bird app, also known as Twitter. Leanne makes things. And you can also send me an email to leanne@loft.sh. Before I was a developer advocate, I used to be a consultant specializing on helping customers move into cloud native, transform their organization. Also have a background in software engineering. So yeah, some of the stuff that I'm talking about is taken from the experience that I had working with big companies moving into the cloud space. So as I said, I'm going to be really quick about it, so let's jump right into it. One of the things that when we are on our Kubernetes journey, something that you might have also experienced is that secrets are not technically speaking secret when you're on Kubernetes. The reason why has to do with the secret resource. This is how the secret resource looks like. And if we take a closer look at the data, we will see that these values here, they're not encrypted. They are base64 encoded. So anyone who has access to your cluster or namespace that contains these secrets is able to copy, paste, decode them, and then they know your secrets. This is bad. So in the olden days, what we would probably do is just not give developers access to the environment, not give them access to the infrastructure itself. But now we're being told we should be doing something called GitOps. And GitOps, I think personally, is great for a lot of reasons. We can deliver all our resources in one place, one convenient lump. We can use the built-in access control that Git gives us. And we have a, let's say, persistent history of the states of the environment at the time that we wanted to deliver something. There's a slight caveat. Obviously, you could mess with the history if you wanted to. If you really want to, you can. But there's ways to kind of prevent that. You could protect your branches. You can only allow changes through pull requests. So it's, let's say it's semi-persistent. And finally, devs will have to have write access to a GitOps repository. Maybe indirect, maybe through some kind of automation, but they will. And once they have write access, they will have read access. So then we're back at the original problem that if I have read access and everything's in one place, I can then see the secrets and I can read them and decode them, and then I know everything. Going one step back to think about, okay, what is the good solution? I want to talk about something called desire paths. And desire paths or desire lanes are something that we can find in nature when humans or animals kind of erode a specific path through the way that they walk. So they will choose kind of the path that's most convenient for them, and this is kind of the end effect of what it looks like. I'm sure you've seen this. And if you have infrastructure that's just really badly built, like the one on the left, or that's super inconvenient, like the one on the right, people will take a different way. That's just how we're built. We're just lazy, inconvenient people. And as you can see there, once people start doing that, it will start to erode kind of the overall system that you have. So it will weaken the structure and the security of your system or your organization as a whole. So thinking about that, what are the things that our desire paths are built on? Like, what are the things that people desire? So, by the way, these might be different for your particular organization, but I think these are fairly general. So don't be alarmed if you have different objectives or desires in your organization. But for me, it would be, I want to consume my secrets consistently across environments. So there are some applications that will do something like, if I live on prod, I'm going to read my secrets like this. If I live on dev, I'm going to read my secrets like that. And that is really not a good thing, because your application should not need to know about where it lives and what it should do. It should just do the thing that it's doing. The second thing is that we want to keep the secrets out of the hand of the developers, specifically on prod or maybe on some staging environments. So that is second most important to us. We also want to improve the developer experience when they work with secrets. So we don't want them to have to open like a bunch of Jira tickets and wait on other teams and all that jazz, because that's when people will take other paths, and maybe even the architecture of the system itself will suffer because of just like an inconvenient way to like get to secrets. And then finally, this is something that I personally very passionate about. I would like to use open source tooling. Bless you. I think for one thing, it's just a good, like open source, great idea, great thing to do. Also, if you know how your tooling is built, it will improve trust because you know what's happening. And also, if you know about the vulnerabilities of a specific tool or service or system, then you can maybe mitigate it at some other place, and that again will increase the overall security of what you're building. All right, let's talk about the setup that I've invented to kind of like find some solutions for this problem. So we want to end up with a Kubernetes secret like this. It's very similar to what I've shown you before. And then in the data field, we have a key that's the environment. So either we're on dev or on prod. And the source, which in this case is YAML, because we're reading this from a YAML. And then we need something to consume that secret, which is a pod in this case. And here we are mounting the secret into the environment. So we expect the secret called test secret, and we are reading the environment and the source, and we'll just be echoing this into the logs, which you should not be doing in real life, right? This is just for demonstration purposes. Do not do that. This is just to prove that I'm actually reading the secret, and it's a real thing. So we have now, to solve this problem about secret management, we have two options. We can either encrypt our secrets before we deliver it into the GitOps repository. And to do that and show you that, I will be showing you a tool called sealed secrets. So what we're going to do is we're going to encrypt the secret, put it into the GitOps repository, and then deliver it like all our other resources. The other option is that we store our secrets somewhere else, and all we deliver is a reference to that secret that we then have to pick up and then put it into the cluster. So to show you that, I'm using HashiCorp Vault, great open source tool, and the external secrets operator, which, again, also a great tool, that will then go to Vault, pick up the secret that we have stored there, and then put it into our Kubernetes cluster. OK, you're with me so far, right? Yeah. Are you all tired from last night? OK, yeah. I do remember some karaoke being done. All right, so option number one, sealed secrets. This is the general architecture. There's a, let's see if this works. Yeah, so these ones with the normal lines, these are the responsibility of the ops team. And these ones with the dotted lines, these are the responsibility of the developer. This might be slightly different for your organization again, but that's just to kind of generally show you that the devs only have to care about what's happening on their machine. So we have a Kubernetes cluster and a GitOps repository that are owned by the ops team. And on the cluster, we have the sealed secrets operator that lives there. Once we install it, it will create a public and private key pair that it will use to end and decrypt secrets. And the first thing we're going to do as a developer is we're going to ask the operator to give us the public key, store it on our local machine, so we can use that public key to now encrypt our Kubernetes secret and make it a sealed secret. This is what a seal secret looks like. It is very, very similar to a Kubernetes secret, except that it has this field called encrypted data. And here, this is actually encrypted. And I'm not able to decrypt it just by looking at it. I will need the key that I don't have access to. And here I can basically define how I want the secret to then look like that I'm creating later. So I could like change the name if I wanted to here, or like add some more specifications. So once I have this sealed secret, I could now put it into the GitOps repository with all my other resources, and then have the whatever system I'm using to deploy, Argo, Flux, whatever, put that sealed secret into the cluster, where the operator will constantly be monitoring for changes of my of all the sealed secret resources that I have in my cluster. Once it detects that, it will now go to the private key, take that, and then decrypt the secret and put a Kubernetes secret in there. And the private key should never leave the cluster. Only the operator should have access to it, and that's the way that it will decrypt that secret. So let's see. I don't think I have time for it. Actually, you know what? Let's YOLO this. OK. I don't do live demos. I do live recordings and then I live comment on them. So that's working well. OK, let's just go with it. So here I check that I have the seal secrets controller already installed, and there's just the regular default namespaces. Oh, great. And then I will use a tool called DevSpace that's just managing the environment for me, because I don't want to type everything out by myself. And what it will do here is it's deploying, first it's creating a sealed secret, which we can't see right now. Then it will deploy the sealed secret after we've sealed it, and the application. So this is what it's done. This was very fast. And now I can look at my pods and see, oh, there's a pod now that's called sealed secret, reading secret. And if I look into the logs, I can see it's outputting the contents of my secret. I can also look at my secret just to make sure that it actually is there. And here I can see the owner reference is Bitnami. It's of kind sealed secret. So this is actually, I didn't just put the secret there. This is what the sealed secret controller did for me. And yeah, sure, let's skip through this because it's we're tight on time. OK, so the secrets need to be managed separately if I'm using sealed secrets. That's the big thing. Like it's not a secret management tool that I can use. But I can, with using sealed secrets, I can now deliver my secret with the rest of my GitOps, with the rest of my resources in the GitOps repository. I don't really need anything else besides I obviously need like an operator with the private key to decrypt it. The controller pub keys, or the cert, that can be shared outside of the cluster safely. So I don't actually need access to the cluster to use the controller, which is pretty convenient, I guess. And the one thing, though, is that because the public-private key pair are tied to a specific controller or specific environment, I do have to reseal my secret for every different environment. Theoretically, you could share that private key as well, but that's not recommended. Obviously, once it leaves the cluster, you're already weakening the structure and the whole system. So moving on to part number 2, which is using HashiCorp Vault and the external secrets operator. So this is a tiny bit more involved. We have the cluster, the ops repository, the dev machine as before, but now we also have Vault, which is now in dotted lines. Because Vault could theoretically live anywhere, and it could also theoretically be like the responsibility of a third team, of a security team. Maybe, maybe not. In my example, I'm just having Vault installed on that cluster itself, just because it would make things simpler. But you could have a shared Vault over multiple clusters. That's totally OK. So now our secret starts as an entry in our Vault. And I have now an external secrets operator living on the cluster. And this operator has a service account that is now associated with a role and a policy. So in Vault, you can have different policies allowing you to read different secrets, entries there, and then a role can associate it with one or more policies. And what you then also need is a secret store that basically will tell the service account how to connect to Vault, how to authenticate, and where to go. So this is a very important part. This is why I'm looking at it a bit closer. So here I'm using a cluster secret store. And I'm telling it, OK, there's a vault under this address, and everything that you need is behind the path KV, because we're using a key value store here. And the way that you can authenticate is there's a specific type called the Kubernetes authentication type. It's mounted behind the path Kubernetes. So that's actually where we find the service account, the token for the service account. So that's how it authenticates. And you can assume the role, ISO role, which I also have to create. So once we have that set up, we can now create an external secret on the dev machine. And that, again, is a reference to this value that we find in Vault. And yeah, let's take a look at that as well, because that's also quite interesting. So in this resource, we have the secret store ref, which is a reference to the secret store. And we can completely, this is pluggable. So we can, if you want to one day maybe use GCP Secret Manager instead of Vault to store secrets in, we can just change the reference. We have to create a new secret store, and we just change the reference in the external secrets, and the rest can stay exactly the same. And then we also have to specify the target secret that we want to create. And here we basically say, there's an entry called test secret. It has 2 keys. One is env, one is source. And please map those to a Kubernetes secret that also has 2 keys named env and source. So once we have that, we just do a very similar thing. We put this external secret into the GitOps repository. We deploy that into our cluster. We have the operator there constantly monitoring for changes to external secrets. And if it realizes there is a change, it will go to the service account. The service account will take the information from the secret store. That one will assume the role to pick up the entry. Then we'll come back to the cluster, and it will make a Kubernetes secret out of everything that we got. What's my time? Can someone give me like a quick, how much time do I still have? 3 minutes, OK. Let's just look at the first couple of seconds then. So here, again, just checking that I have Vault external secrets operator and console installed, and I don't have any additional namespaces. So I'm again using devspace just to speed things up. And you can see here that I'm opening a port forward for Vault. I'm creating a entry, which I already created. That's why I'm getting a 400 here. And I'm deploying the external secret, and I'm deploying the app. And then I have to open a second shell because I have the port forward running. And now, same thing. I'm looking at the logs, and now I can see, OK, so now I'm on, oh, this is a mistake. This is on dev, not on prod. Anyhow, 95%. Yeah, and if I look at the test secret, I can see again that the owner reference is the external secret. And this is how they created that secret for me. I will share the slides later. You can look at these demos in your own time. OK, so in summary, the external secrets operator works with many cloud providers. It works with HashiCorp Vault, but if you want to use GCP, AWS, I think they're both called Secret Manager, and the Azure one, or whatever, you can use those as well. Probably works with Okta also. The dev teams now have a way to manage secrets, so they can actually safely manage the secrets through something like Vault without having to actually look at the content. And you have all the built-in security best practices because you now use an actual tool to manage secrets. So something like key rotation, all of that you would have to do by yourself if you're using sealed secrets, but now you can use Vault, for example. The downside of it is that it's quite an elaborate setup. I have to do quite a lot of things to get it to work, get it to do anything. So if you are just 2 people in your organization, you might not want to do that. But if you are 100, then maybe that is a better alternative to actually sealing 100 secrets. So in conclusion, we're almost at the end. You can check out the demo. It's a repository. I love how everyone's already scanning it. I'm giving a security talk, and you're just like scanning some random QR code here. But I promise it's safe. Well, maybe. only one way to find out. The repositories behind that QR code is what I'm going to tell you now. And yeah, you can check it out in your own time, as I said. I just want to come back to kind of the main points that I'm trying to make. So this is a cartoon where a manager is saying, right, I've decided we have to use an SQL database, and the next thing is you have to explain to me what an SQL database is. So that's basically Kubernetes. With the exception of maybe pods, Kubernetes doesn't really understand a lot about the resources that it's managing, and that's fine. But what we need to understand is that that means that it's not managing secrets. We have to manage the secrets somewhere outside of Kubernetes. And also, you have to secure a cluster. All of that does not, negate that you have to make your cluster be secure as well. And then going back to this imagery of desire paths, what I'm saying is you need to understand what your developers actually need, how they work, what they want, and then build on top of that instead of trying to force the system just because you think it's cool, because that's not going to work and it's going to weaken your overall structure. And that is it. I think we have a couple of minutes of time maybe. And just one thing, just want to say happy Pride. Trans rights are human rights, and thank you.
Thanks so much.
Oh, thanks.
So we're going to take one question. We're going to take probably that one from the top there. How can you keep your secrets separated by pod, i.e. stop one pod from accessing another secrets?
That's a big question. So it depends. Exactly. The long answer, you maybe want to talk to me afterwards. But then the question is, how do you generally separate your namespacing? Could be one way, for example, or you can restrict access to the secrets themselves to put them somewhere else. I need to understand more about the use case, I think. So just come to me after the
Hanging
thing.
around.
Yeah, I will be here. I will be here for a while, probably. Thank you so much.
Thank you very much. Leanne. Okay, we got a lot moving on today, and I think now it's some words from our sponsors once again, and I'd like you all to welcome to the stage at PVH.
Thank you. Yes, I'm from PVH, Stephen Evans. Who or what is a PVH? PVH is Tommy Hilfiger and Calvin Klein. Spoken to a few of you at our booth yesterday. Hope to meet more of you. I mean, I can kind of smell the integrity in the room, at least I hope that's what that is. So I know that you would not be tempted by cheap trinkets and feign interest just to get your hands on some goodies, but we do have those as well. We also have beers from our beer sponsor, Contrast. Thank you to those guys. But we're here to just really connect with you guys, connect with the community. We're not selling anything. We're not on some big recruitment drive. We're just here to share our story, hear your stories, understand how we can be more involved in the DevOps community. So if you want to chat, if you want to break from all of those hard-selling vendors, come to us. And no, they're all lovely, and they've got cool stuff to show. But please come to us, and hope to meet you soon. Thank you.
Thank you so much. And up next, I'd like to invite Mondo on stage.
So I'm one of those hard-selling vendors. Hi, everyone. I'm Sue Choi, co-founder and CEO of Mondu, the full-stack security company. Our goal is to make security more accessible. Well, what's wrong with security? It's just too much. It's too expensive. There's too many tools. There's too many false positives. There's too many manual processes. There's too much paperwork, right? Does it remind you of QA 20 years ago? Well, where is QA now? QA is now automated and part of the pipeline. We believe we can do the same with security. If you are interested in talking to us, we're the ones in the purple shirt, and we won't sell you too hard. Anyway, cheers.
Thank you so much. And up next, we'd love to hear from Trent Bankero.
Thank you. Sebastian van der Meer, still working for Trend Micro just like yesterday because nobody offered me anything. So we do security as well. We have a platform that we call Cloud One, where we do security for containers, serverless applications, and servers. Yeah, that's it, actually. So come find us. We are usually by the charging stations. We do have QR codes that lead you somewhere. So have fun with that.
Thank you so much. And I believe next we're going to be hearing from New Relic.
Thank you. Good morning again. It's day 2. How's it going? Yeah, right. So New Relic, we do stuff. Today I want to mention Pixie. Who's heard of Pixie? Pixie? It came up yesterday in the closing keynote, people. Pixie is our Kubernetes instrumentation solution using eBPF. eBPF? Yeah, eBPF, woo! So Pixie is an open source project we donated to the CNCF. If you're curious and hearing about Pixie, come stop by, hang out, play some Mario, talk some Pixie, we'll have a great time. I still have hats. Yesterday I had hats because it was too sunny. Today I have hats because it is raining. You're such a great audience. Have a great day, everyone.
Thank you so much. Okay, so there's only just a couple of items for myself before we welcome the next speaker, and just want to remind everyone the code of conduct is in place, and please do seek out a member of staff if you ever have an issue throughout today. Furthermore, that the sponsors are doing raffles, and we'll be looking to close off those raffles on stage here after the last open space, so please do come back to the room to hear if your name's been called for if you've entered into one of the lovely sponsor raffles. And now, I would like to welcome to the stage Simon, who's going to be talking... Oh, you're going to build what? Please welcome to the stage, Simon.
Thank you very much.
No problem.
G'day, folks. Can you all hear me? I'm so sorry. How was last night? Did you all have fun? Some of you did. Okay, I'm going to stop asking you questions because it's an unfair thing to do, right? I'm going to wait for this Mac to unlock. Come on. Ah, good. All right. Excellent. I'm going to go up here. Before I begin, one question. Live demos or recorded demos? Claps for live. Claps for recorded. All right. I've sealed my own fate, really, haven't I? I'm just going to plug this in, and then I've got a clicker as well, which will be very, very exciting. Does that click in? No, that goes in there. You wouldn't know that I do computing. So I come from... okay, there's no remote control. Never mind. I come from the development side of DevOps. How many people here are like software engineers as their primary role instead of like operations or anything like that? Okay. How many of you run continuous integration builds or some sort of CD pipeline? Okay, far more of you. I feel a lot more comfortable. You may know me from my previous role as the lead of the Selenium project. I created WebDriver like 1 billion years ago, and I stepped down as a lead at the end of... Thank you very much for that. And I stepped down as a lead at the end of November, so it's not my fault anymore. I have also been involved with builds and build systems for an incredibly long time. Like, I really love this stuff, which is a bit unusual, but then I'm surrounded by people who do DevOps and who think that Kubernetes is a neat thing, so can't be all bad. There are an absolute ton of generalizations in this talk. That's fine. Roll with it. We all know what continuous integration is. If we don't, it's the process of continuously integrating our code. What does that mean? We tend to run some kind of pipeline, and we do this to verify that the garbage that our developers have written is OK to put out into production. Obviously, the developers don't think it's garbage. We don't think it's garbage when our users have got it. But when they first send us that initial PR, we don't know, right? Like, they've given us something. It could be brilliant, or it might not be. And there's only one way that we can think of finding out, and, well, that's to run it through some kind of pipeline, right, to verify that everything is correct. And gross generalization, this is what your CI pipeline looks like. It begins normally with a clone from Git. And then because we have no idea about the state of the system, we tend to actually do a clean before we do anything else, because God knows what crap has been left on the disk. Sorry, is that the kind of language we're OK with? Okay, good. Okay. Then what we do is we tend to fan out, right? This is a fancy technical term for doing more than one thing at once. We run our small tests, our unit tests, because they're quick and they can give us a sanity check. And while we're going about it, at the same time, maybe we run linters over the code base to make sure that people have followed the coding inventions that we have endlessly argued about. When those unit tests pass, then we know that it's probably going to be all right. Now, we know it takes a really long time to deploy a new PR into our user acceptance testing environment. So what we're going to do is we're going to fan out again, and we're going to start deploying to the UAT as we run the tests that can run on the local host that take a little bit more time, but that we know give us a sort of sense of confidence that things are good. And then finally, when everything has been deployed to the UAT and the tests that we can run locally have all run, the only thing that's left for us to do, run all the tests, right? And assuming those all pass, then we deploy and upload, and everything is tickety-boo, which is an English expression for meaning, I think it works. So why do we do this way, right? We have just run every single possible test, right? And it's taken just a vast amount of time. Like, who's done a build and it finishes in like 15 seconds with a CI build? Yeah, none of us. Who of us have like a CI build where it takes like 2 or 3 hours, and yeah, we kind of live with that and we go like, well, it's as fast as it's ever going to be. I'm here to tell you it's not as fast as it's ever going to be, otherwise this would be a very short talk. But the reason why we do this is we don't actually know what's changed. We've put some code in, and in order to be safe, we have to run everything because we have no mechanism for determining what has actually changed, what the minimal set of work is that we need to do, right? It would be nice to do better than that. And there's another problem in our code bases, which is other people. Like, when we're working on our own, we can run all the tests and we know that everything is going to be fine. When we're working on a code base with 5, 10, 15, 20, 100 other people, then it gets really hard to keep that repository stable. I think we've all seen that. We've all had like the CI run fail, and it's like, oh, well, I don't know why that failed. I'll just run it again. Yes, lots of nodding of heads, like, oh, sure, you know, it's a classic computer science answer to everything. Have you tried turning it off and on again? Right, and there's several reasons for our builds to fail. Part of it is maybe code review didn't catch a particular issue, and some code has landed in the tree, and now, like, part of the tree is never going to compile. Or maybe we've just got some flaky tests, and although our change hasn't touched that test, because we're running everything again, that test fails, and then we go like, well, that's nothing to do with me, and like maybe we'll try and force our change in, or not, as the case may be, and it's suboptimal, right? So really does need to be a better way than this. This sounds fairly primitive, right? If you were to describe someone like what we're doing, and we go back in time, they go, that's positively medieval. It's like in the old days when they used to sort of, you know, bleed people to cure them of the ill humors. It's like, no, we want to apply science to this problem. We want to do better than this. And also, I can't be bothered to wait an hour and a half, 2 hours for my CI build to pass, because all I've done is I've added a comment in a file somewhere saying that I like cheese. I do love cheese. So what we're going to do is we're going to take a look at the thing called the build graph. What, in the name of all that's holy, is a build graph? Well, under the covers, all build tools do is they take a look at the inputs into that build, which are probably your source files, right? And then they sort of figure out the steps they're going to do that they need to perform. And normally, that's a tree of some sort. This is, in fact, a directed acyclic graph. Directed means there's arrows in it. Acyclic means there aren't any circles in it. All builds rely on being both directed and acyclic, right? It's fancy computer science language, but it basically means, oh, look, it'll work. And in order to do a build, like conceptually, this is any build system: make, Gradle, NPM, Amazon Mechanical Turk, if you're asking people to do manual steps, I don't care. At the bottom of the graph, we have these three things, and they have no dependencies, and so you could do them first. And then you go up the graph, and once you've done those three things and the thing it's pointing to, you can build that, and so on and so forth, right? And there's a thing called a topological sort, where you go, what can I do before anything else? And then you sort all the tasks, and then your build is merely just iterating over that sort of tasks that you need to do, right? And it doesn't matter which build tool you're using, they all basically do that. That's all well and good. I'm going to suggest taking a look at a different build tool. And the build tool that I am going to suggest you look at is one called Bazel. It was open sourced by Google in 2015. I put it up on the slide so I didn't forget. And it is one of the new breed of build tools that are coming out. It is the sort of leader of the pack of these new tools. The thing that makes it stand out is it's a polyglot build tool. So who here has like a front end written in JavaScript and a back end written in like Go or Java, or if you're really lucky, Rust, right? Who here has like a Go build, and then like maybe you've got to have some make files or some scripts to coordinate some code gen beforehand because you've got some proto buffs or some Avro or Thrift or something exciting like that, right? Like our builds nowadays used to be just one language, and now there's dozens of the bleeding things, right? And somehow we've got to marry all these things together and make them work. And a polyglot build tool really helps with that because it enables you to describe everything using a single tool with a single UX for doing building, testing, and running. That's really nice. So why do I like Bazel? The first reason is it gives me a chance to do a dad joke. So Emily Freeman, thank you very much for encouraging me to do that by using them in your talk. Hermetic builds. So a hermetic build is an isolated one, and that's one where we try and reduce the it works on my machine. So typically when you're doing a build, people are responsible for installing their own version of Go, their own version of the NPM, their own version of Ruby, their own version of Python, their own version of the JDK, and everyone does this at a different point in time, so everyone has a slightly different version, and occasionally things will work perfectly on one machine and fail miserably on another. And you look at the code, you go, the code is flawless, and you spend half a day trying to figure out what the heck has gone on, and you realize that this person is using Python 2 for some reason, and this person has moved into the 21st century and is using Python 3, right? And you've wasted so much time. What Bazel allows you to do is it allows you to pin down the tool chains that you're using. So you say, I'm using this version of Python, this version of Java, this version of NPM. And it's encoded in the files you check into the repo. So when someone does a build, it will download those particular bits of the tool chain, and it will be using those regardless of what is on the machine. And that is hugely advantageous because it reduces the works on my machine. Second of all, I like it because it's purely functional. This is more computer science, I'm afraid. A pure function is one where, given the same inputs, it performs something, you get the same outputs, right? For a build step, that means that given the same input files, whatever happens, you will have the same output. That gives you a repeatable, bit-for-bit repeatable build, right, which is fantastic. Now, that doesn't always work, but it is a safe assumption to make. Right, this also means that we have to shift our mindset a little bit because we're quite used to our builds being a series of tasks that get executed regardless of whether or not they're needed. So people who like increment a counter every build, this will mess you up. But it's really nice because you can hash your inputs, right? You know what if same input, same output, you can hash your inputs. You know what's going to happen. If you can hash your inputs and get the same output, well, that's a key value store, right? You can put everything into a content addressable storage server, and away you go. Brilliant. You know, same input, same outputs. So you can have a massive distributed cache, and that means that if I've done the work, you can benefit from it because you can just download it from the store. So you get a huge increase in how fast your builds are, decrease in build times. The other thing that this allows you to do, where we've pinned down all our dependencies, we know exactly what they are, we know exactly what our inputs are, is we then don't need to do them locally. Like, this laptop is a really nice M1 Mac. It's got 10 cores. I love it. It is got far fewer cores than an absolutely massive Kubernetes cluster, where I could have 1,000 cores. Like, even the most advanced, like, Xeon workstation you can lay your hands on doesn't have that many cores. Now, the advantage of having more cores is you can parallelize work more easily, right? If you've got a build graph, we've already known you can do a topological sort. You can parallelize really easily. So not only can you put things into a distributed cache, you can also do distributed builds. You can get someone else to do the work of doing a build, running a test, compiling something, whatever it is. You can do that in the cloud. And that cloud can either be a Kubernetes cluster that you own, and there are open source implementations of these distributed builds. Build-Barn is one. Or you can use a commercial service like NGFlow or BuildBuddy. So builds in the cloud, fantastic. And the other thing that we can do is we can scale down as well as up. Like, most build tools are pretty good when the repo is small. And Bazel is fine when the repo is small, but when you have like massive mono repos, then you have to like do some head scratching, and normally we break our repositories apart, and then we try and glue them together using integration tests later, and it's an absolute mess. Bazel is derived from Blaze, which is the internal build tool at Google. Google is notorious for having an absolutely gargantuan code base. It's huge. So it scales down. How does it work? Well, this is a build file. Don't worry, this is quite a complicated bit of a build file. The only thing you need to know is right up there on line 3, we're preparing a Java library. That's a jar. Everything has a name, good, so we can address it. A list of the sources, a list of what we depend on, and away we go. Now, unlike regular build systems, this means that there are build files scattered all the way through your tree. Right, so people working on code are responsible for the build files that are right next door to them, whereas like in a traditional build file, your make file, your Gradle files, your package.json is at the top of the tree. So you have loads of these build files. That sounds really painful, but it's okay because we can generate them for Java, Python, Go, protobufs, right? And there are efforts to make that easier. So although it's painful to have these, it's fine. And the advantage is that now we have a really fine-grained build. And Bazel has a query command. So unlike most other build tools, we can take a look at the build graph, and we can start asking difficult questions like, when I change this, what do I need to look at? Why does this library depend on that dependency? You know, lots of fun stuff, right? Like, suddenly you get a lot of introspection into your build. So here's our example of a hypothetical project. And what we're going to do is we're going to make our CI builds faster by building the bare minimum amount of stuff. Now, I've seen people spend a lot of time and effort on machine learning and stuff like that. You don't need to do it. You just need to query the graph. This, by the way, is an example of this, which is an actual live project. It's composed of 2 basically independent sections. There's Gazelle here, and then there's some Java code. So let's change a file. I'm going to change it here. I'm going a little slow, so I'm going to do the canned demos, I'm afraid. We change this file. Obviously, looking at the graph, we only need to do this. There's a tool called Target Determinator, which was released by Apple recently to the Bazel Contrib project. And it works. So you will see Target Determinator. For the previous revision, there's some wording, there's some clanking, and we can see here that we have modified 42 of 130 targets. So we can now just run those, and we know with certainty that our build is safe, and we are safe from the changes that other people have made in the tree in the other, like, 90 targets that we don't care about. Well, you know, that was quite a lot of stuff. But what if we change a file in that other piece of independent code? If we change that, it's a smaller tree, and clearly, we only need to do this, right? Well, let's take a look. Again, it's exactly the same command, Target Determinator. Here's the revision I want you to look at as the previous one. And this time, we only have to change 7 files. So that's really nice. Well, what if you add a file? Like, you'd have to redo all of this work, right? Well, let's do a demo. the demo going to work? Do I have to press a button again? Yes, great. It's exactly the same command as I did before, target to terminator, head. This is actual software, by the way. You can download and use this. Oh, my expectation of having to rebuild everything was wrong, because this was a test file, and nothing depends on it. It's one of those leaf nodes, and the build graph tells us that this is the minimum amount of stuff we need to run. Well, we're going to remove a file, right? That's going to cause absolute carnage. So we remove a file. Here's the PR. I'm going to run targets terminator head, same command again. And it will whir and clank, and it will tell us 31 of 130 targets need to be rebuilt. So we can save a huge amount of time by just doing that. And bonus content. What if we tell the world how much we love cheese in our configuration file? Now, this isn't used as an input to anything. In a traditional build system, we'd still run and build every single thing in the repo. In this particular case, nothing. So that build would be instant, right? We could just land that. And we know that's safe because we know that's not an input to anything. So our new CI pipeline is pretty simple. It looks like this, right? And we can build that today. We use Target to Terminator, which is an open source project on GitHub, Bazel Contrib. And we can find out what has changed. Once we do that, all we need to do is run our tests. Build everything, run our tests. We know the minimal subset of the build graph that we need to do, which saves us a huge amount of time. And of course, because we're using a build system that supports distributed builds for any language, so Java, Go, Python, Rust, building Docker containers, you name it, we can do that in the cloud. I hate that phrase, on our own Kubernetes cluster or a commercial service. We can parallelize beautifully. When you do this, you see build times collapse. So I was working on one project. Its build times were 2 hours for a clean build. We now routinely see PRs go through with all the tests that we need to do in 2 minutes. Yes, right. It's absolutely staggering when you see it happen. And then, once we've checked that the minimal set of stuff is correct, we can then deploy, and away we go. We're done, right? We could live in this utopia, and it would be wonderful. How do we get to this utopia? Well, the first thing is we use a build tool that allows us to introspect the build graph. I'm suggesting using Bazel because it makes it easy to query, and we can also use remote execution and caching where necessary. Second piece of the puzzle is a target determinator. There is one for Bazel. You could write one for any build system, right? You just need to be able to understand how the pieces fit together. But the target determinator for Bazel is great. It makes it easy to share a repo with other people, so you don't need to worry about them breaking their build as long as your build is fine. And it allows us to identify the exact minimal subset of tests to run. Finally, that combination of tools allows us to dramatically reduce our CI time. We can go from 2 hours to 2 minutes if we architect our builds correctly. And with that, ladies and gentlemen, boys and girls, everyone who is here, thank you very much for your time.
Thank you so much. This is from us.
Oh, thank you very much.
We may have time for one question, if, yeah.
That's a really good question. The answer is Bazel has a near vertical learning curve. Like the first time you use it, it is very alien, and it helps to have someone who's gone through that journey before. Now, I used to work at Google. I was the lead of the build tool team at Facebook who built something very similar. Like, I've been using this kind of build for a long time. So I go and I sit with teams and I help them migrate. If you don't have someone like that, it's not going to be a comfortable journey. Now, that's okay, because there are consultancies out there who do offer support for Bazel and migrating onto that. And also, the documentation is excellent, if somewhat cerebral. And there is a really good Slack channel where you can ask for help. And the advantage with Bazel being the leader of the pack of this new wave of build tools is you can also go to Stack Overflow, and somebody somewhere is suffering the same problem that you were suffering and is giving you an answer you can copy and paste, or at least go, oh, I don't know what that is, and you can Google an answer. So the catch is, it's not easy to get onto Bazel, and a hermetic build can be painful to get to. But once you've done those things, it's great.
Yeah, I think that's all the time we have. Thank you so much.
Thank you very much.
Okay, and we have a next talk, and somebody who's looking absolutely fabulous, but I think I might be a little bit biased. Please welcome to the stage Matt, who's going to be doing the Avengers Assemble at the Thanos incident. Thank you.
Going to run a risk there and move water around by electronic equipment. That seems real smart. So very cognizant of the fact that I am standing between everyone and lunch. So don't worry, my talk is only twice as long as it's supposed to be. It'll be totally fine. All right, let me just get, come on. Slide, oh, you got it, okay. We tested this, thank you, okay, good. Like we weren't gonna have an Emily incident, we're having a Thanos incident. All right, awesome, fantastic. As I said, welcome, Chris introduced. We're gonna be talking a little bit about incident response. Again, call back to the keynote that started us yesterday. And, come on, there we go. Okay, clicker goes. All right, so my name is Matty Stratton. I am a developer advocate at Pulumi, and I also really love Marvel. You can find me on Twitter at Matt Stratton. Couple things, I am going to provide a quick spoiler warning. I am realizing I'm providing spoiler warnings for a movie that came out over 4 years ago. So if you haven't seen the Avengers Infinity War or Endgame and you plan to see it, you might want to leave. Don't leave, it's totally fine. But this is spoilers for basically anything in the MCU leading up to Endgame, so leading up to 2019, but especially Infinity War and Endgame, you've been warned. Oh, and then I was gonna, I have a clock over there, that's totally fine. All right, so we're gonna think about, our intent of this talk is to take what we call the Thanos incident, which was the point at which Thanos, the Mad Titan, snapped his fingers with his Infinity Glove, wiped out half of the life in the universe. Bad thing happened. But we're going to take a look and say, how did the Avengers, Earth's mightiest heroes, respond to this incident? How might they have done things better? What can we learn from them? And hopefully it'll be entertaining along the way, because that's really what I'm banging on here. So when we think about what actually happened, right? So what we're gonna do is we're gonna start by creating a very brief postmortem or incident retrospective of the snap, of that incident. And our approach will be to address this in a blameless fashion. How many people have heard of blameless postmortems? I mean, this is a DevOps Days in 2022. That's okay if you haven't though, because we're gonna talk about them a little bit. And we wanna understand what happened, as well as the process that the Avengers used to respond to this incident. Emily talked about yesterday, incidents are a fact of life. They continue to happen. Hopefully the incidents that occur in your environment are not quite as catastrophic as wiping out half of all life in the universe, but I don't know. There are definitely some high impact systems where this come in. And then again, as we talk about incidents, one of my favorite phrases and ways to think about this, Ryan Heinrich has said, oh, you want to get better at better at incidents, have you considered having more of them? And that's actually really good advice, because it's more about how we treat incidents and we approach them, we understand they happen regularly. And for purposes of the discussion, when I talk about the Avengers, this will include characters might necessarily generally considered Avengers, just bear with me, right? We don't have to completely nerd snipe on this. We can do that during lunch if you want to come and tell me everything that I'm doing wrong with the pop culture here. Okay. So granted, one of the things we do when we do a postmortem, the first thing we do is we construct our timeline of what happened. Now, we're talking about the Avengers, we're talking about this. Timeline is kind of a goofy term because time travel gets involved, but usually time travel is not part of our blameless postmortem process. That's not really what we're talking about here. And when we construct our timeline, we're not really ready to start analysis. We're just getting the facts. And we want to avoid hindsight bias, which I'm going to talk about in a minute. So our timeline actually starts a little bit before the actual incident occurs. So in the case of maybe an incident of service disruption in your environment, that timeline doesn't start when the service disruption occurred. We kind of back it up to the beginning of that. So when we're thinking about constructing a timeline, we stick to the facts. We're not doing analysis yet. We're including any key decisions and actions that are taken by the responders, and we're trying to avoid evaluating at this point what we should or shouldn't have done, right? It's just the facts, and we start the timeline at a point before the incident began. So when we think about the high-level incident of the snap, I'm not going to dig into this entire thing. We don't need to have 5 minutes of me giving you a recap of these 2 Marvel movies, but fundamentally this will give you kind of an idea of what we're looking at. We're saying these are the things that happened. But this is all stuff that led up to the actual snap, which was, occurred at the culmination of the movie Infinity War. This is all the stuff that happened before that. And this is all data. And you see the very last thing that's in the timeline in this case is what occurred. Now, we have a timeline so we can start our analysis of our incident here, and we're going to dig into what we can learn from this now. So shout out to Ryan Kitchens from Netflix, who really came up with root cause analysis. But this is my favorite joke of the whole talk. It's all downhill from here, just so you know. So bear in mind, systems are complex. And I really love this GIF as being my example of a complex system, because holy crap, is there a lot going on in these couple phrases. And this is the systems that we're dealing with. You may recall yesterday, Nathan Harvey and talking with Amanda said, I don't want to alarm you, but something's broken in your system right now, right? Our systems are so complex right now, they're kind of always in some state of failure, and that's okay. But again, when we think about complex systems, this has a lot to do with how we address where we get to in our incidents. And so this is the thing. I made a joke about root cause analysis. There is no such thing as a root cause. Actually, I'm sorry, there is one single root cause. That root cause is the Big Bang. The alternate root cause is capitalism, but that's a different talk. But remember, there is no single root cause. So our goal is to identify the multiple contributing factors that led us to failure. Dr. Richard Cook has a great paper. It's very short. Don't worry. It's called How Complex Systems Fail. And I have, at the end of this, I have a link that'll take you to all my resources you can read about. But that's one of the things that Dr. Cook talks about, is that our systems are well defended against simple failure, right? So when we have an actual failure of the overall system, it's multiple factors have to occur for us to get that to happen. We're well defended against simple failure. So I talked about blameless. So the idea of a blameless postmortem was all the way back to, started at Etsy years and years ago. John Allspaw came up with it. We've been doing this for over a decade now. And when we think about the idea of blameless, it sounds really great on the surface, right? Sounds like it should be relatively easy to do. Well, it's not. But the reason we're trying to do this is we want to focus on the systems and not the people. And so why does it matter, besides the fact that, DevOps thought leaders keep saying blameless, 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 and there's a whole startup called Blameless as well, so it must be important. But it matters because we have this impulse to blame, and punish usually comes along with that, and has an unintended effect of disincentivizing knowledge sharing, right? So if people are afraid that they're going to get blamed or in trouble when something goes wrong, you're less likely to volunteer that something happened. If people are afraid that there will be a negative repercussion of an error or something going wrong, that's not going to, or if they're going to be punished, if people are afraid they're going to be punished for making mistakes, that will not cause them to make fewer mistakes. It actually just helps them become subject matter experts at hiding their mistakes. And now you are well and truly expletived, as Nathan would say, because you have no idea what's going on in your system. So when we have a culture of blame and that, it just makes us really good at hiding things that go wrong. And the goal of our incident respect, our postmortem, our retro, whatever we want to call it today, is to understand what are the systemic failures that led to the incident, identify actions that can introduce and improve the resilience of the system. And I want to talk about the word resilience for a moment. And I generally try not to be super pedantic about words, but this is a word I'm going to get really specific about, because let me ask a question. Does anybody believe you could make a Kubernetes cluster resilient? So see, that was really mean, because you can tell from the way that I said it that the answer, if you raised your hand, you would be wrong. The reason you can't is because resiliency is the ability of a system to respond to unpredicted disturbances, right? So you know what can be, the only thing that can affect resiliency is the humans. We can be resilient. We can affect resiliency. Our systems can be made reliable. They can be made robust, which is the robustness is the ability to respond and rebound to a predicted type of turbulence, right? But resilience is something happened that we had no frickin' idea could happen, and we have to use our human skill and brains and creativity to be able to bring that back. So the system that we're talking about here is the socio-technical system. And the systems that we build and manage and operate are just that. They are socio-technical. The socio is the people. They're made up of people and they're made up of technology. The resilience, so the system is not necessarily the technology. And again, the idea in Blameless is to focus on on how a mistake was made rather than who made it. You may have heard of something called the 5 whys. That's a common way that there's folks who like to do that. It says, okay, we keep asking why questions. John Allspaw has talked about this idea of instead of the 5 whys, it's the infinite hows. I'm going to talk about the difference of doing a how question versus a why question. Why questions tend to turn into very blameful answers, whereas how are just sort of, again, we're getting to the facts of what are the things. We're talking about how the mistake was made rather than who made it. Okay, well, this sounds great. Like, I don't think there's anything I just talked about that anyone would say, well, that sounds terrible. I don't want to do that. So why don't we just do this all the time? You know, why isn't DevOps just called common sense? Well, because this stuff is hard. Why is blamelessness specifically really hard? Well, when we're processing information, our human mind, we unconsciously take shortcuts. Who was here at DevOps Days Amsterdam 2019? Okay. Do you remember my zebra talk? I talked about organizational trauma. And one of the things that I talked about, how the human brain responds, and one of the great things about our prefrontal cortex is we take shortcuts with it, which can be great, but it also makes us jump to conclusion because we're trying to pattern match. So we're processing information, and we're going to unconsciously take a shortcut. And we are hardwired from millions of years of evolutionary neurobiology to tend to do that. Our oldest ancestors looked for these shortcuts because that's how we help process information. So don't feel bad if being blameless is hard because you're fighting millions of years. So instead, so we optimize for timeliness over accuracy, which is reinforced by some of our cognitive biases that I'm going to talk about in a second. One of the things that I like to think about is instead of being blameless, because blameless is almost impossible to achieve because of this, it's part of us, is to be blame aware, which is to be aware of our tendency to go in this way, and then what can we do to compensate for that, versus saying we're just not gonna ever have blame. Our brains are wired to do this. So I said we're wired based on these cognitive biases, so we're gonna take a minute to talk about what some of those cognitive biases are. And a cognitive bias is what its name implies. I'm going to define it by using the exact same words. It's a bias in our cognition, which means it's a bias in how we're thinking, right? So there's a few, there's about 12 that are commonly identified. These are 4 that come up a lot when we think about incident response and learning from incidents. And if we're aware of these biases, we're able to identify when they occur and work to move past them and figure out how we can reframe and we become aware of them. So one of the first ones is fundamental attribution error. And this is the tendency to believe that what people do reflects their character rather than the circumstances. Sidney Decker talks about there's in the field of safety, so there's the idea of like safety 1 and safety 2. Safety 2 was the more modern way of thinking about safe systems. Safety 1 was an older one where you think about bad actors, bad apple, right? These things happen because people do bad things. Whereas in safety 2, it's not about that you're a bad person, that there's something fundamentally wrong with you, that a mistake occurred. So that's assigning responsibility. Safety 1, it was assigning responsibility for a failure to bad actors who maybe are careless or incompetent. Ironically, we tend to explain our own actions by our context, not our personality. So we're really good at not blaming ourselves. I mean, I don't know, if you're me, you actually blame yourself a lot, but that's not necessarily always happening. And so how do we combat fundamental attribution error? Is we combat this by intentionally focusing the analysis on situational causes rather than discrete actions that a specific individual took. And there's a few techniques around that. One is slightly controversial. A few of these things are things that people love to fight about on Twitter, so that's fantastic. By the way, again, you can fight with me on Twitter at Matt Stratton. So there is one tendency or thing which is to avoid using names. Like when you're writing your post-incident review is to not actually use someone's name in it. There's a couple, you talk about a role or something. There's a couple reasons why that's important. One is that is actually a way to help us abstract it away a little bit, but also, not everybody in your organization is going to embrace blamelessness right away, and there might be people reading these post-incident reviews who don't understand that we don't blame individuals and they'll find someone's name, and that's just not great. We talk about confirmation bias. This is a very pervasive one, which is a tendency to favor information that reinforces our existing beliefs. Boy, has this been going on in social media for the last 5 or 6 years at least, right? So it's getting worse. So when we're presented with ambiguous information, we interpret in a way that will reinforce what we already were thinking, right? That's confirmation bias. And then when we combine that with the older view of human error, the safety one way, that is going to be really dangerous in our postmortems because that seeks to blame that bad actor. But when we approach our analysis with the assumption that an individual is at fault, you'll find a way to support that belief despite evidence to the contrary. So one of the ways that you can combat confirmation bias is maybe appoint someone to take an intentionally contrary position during investigations, but you need to be cautious because that can actually introduce a negativity piece to that, or combativeness, which is not what we're attempting to do in a post-incident analysis. We're trying to learn. But you can also do this. One really great trick is to invite someone from a different team who was not involved in the incident or the system at all themselves to participate in your post-incident analysis, because they will not have those confirmation biases in the same way. That surfaces questions that your team might not be used to doing. Hindsight bias, this is a kind of memory distortion where we recall events to form a judgment. And when we know the outcome of what happened, it's really easy to go back and say, well, how did we not see this coming? How did this get messed up? Clearly, we should have known this was going to happen. Well, it's because we have hindsight, right? You've heard hindsight is 20/20. So we recall events in a way often to make ourselves look better. And so this can create some defensiveness and divisiveness within the team. And one of the best ways to avoid hindsight bias is to evaluate our events in terms of foresight. So again, remember I said we talk about our timeline not starting at the time of the disruption, but before. So we're working forward instead of backward, right? Instead of starting with when things went south and then moving backwards. And then finally, we have the negativity bias. This is this notion of a more negative nature having a greater impact on our mental state. So social judgments, research has shown that negative information disproportionately impacts our impression of others. And again, social media. People are also more likely to attribute negative outcomes to the intentions of another person than being neutral or positive outcomes. So this again is why we tend to blame individual characters. The reality is things tend to go right more often than they go wrong. Now, I spent a couple decades as a sysadmin before I got into the DevOps thing, and I've always sort of said that sysadmins are inherently pessimistic and cynical, but because of that, that does tend us. But we have to remember that it's actually, things go right more often than they go wrong. Our systems are up more often than they're broken, unless it's my code, then it's broken almost all the time. But if we focus and this exaggeration and internalizing incidents as something that's a negative event, that's demoralizing and it leads to burnout, right? Incidents are a gift. Incidents are a way that we learn more about our systems that we didn't know before. Incidents are a way for our technical systems to tell us things, because they can't usually in that way. So when we reframe incidents as a learning opportunity, and also think about what was handled well. So when we think about doing our incident retros, it's not just about what did we F up, it's like actually what went well. And this helps us balance that perspective. So what are a couple of things we can do to avoid blame? Like we said, we're not gonna remove it, but we're blame aware. What are some actual practical things we can do to avoid it? So one is, again, we said talk about what and how questions rather than who or why. So I'll give you a link at the end. You can read John's article about the infinite hows, helps a lot with that. And then considering multiple and diverse perspectives. So one of the ways might be to bring somebody into your post-incident analysis, like I said, that's from a different team. You know who's really great at helping with this? Is your junior engineers. Right? Because again, a lot of us, if we've been working with a system or a technology or something we support for years and years and years, we have a lot of just assumptions we will make. And this is one of the great things about someone who's new to your team, new to the technology. They're going to ask questions it wouldn't occur to you to even ask. And you'll go, people say, well, why is it like this? Or how did this happen? And you're like, well, because, and you're like, well, wait a minute, you know what? I never even thought about that before, right? Another one is we want to say, ask yourself why a reasonable, rational, and decent person may have taken a particular action. And it's pretty easy when we're analyzing incident to fall into victim, villain, and helplessness stories that propel us to be emotional when we think about it and attempt to justify behaviors. So we can move beyond that by telling the rest of the story. Consider your role, others' roles in the problem, and say, like, this helps us focus more on the systemic factors that led to the incident. And again, talk about abstracting to an in-specific responder. This is a really convoluted way of saying don't use people's names, right? And the idea is because anyone could have made that same mistake. It's not something particular about Maddie. So I think it's important to contrast what you did not intend with what you do intend. Now, when we talk about dealing in our society, impact matters more than intent. But in this case, thinking about the difference of what we intended and what we didn't, because as much as we try to have a best effort to remain blameless and blame-aware, people could still become defensive in a post-mortem meeting. It will happen. So we can work to restore mutual purpose and trust and respect so we can continue our conversation by reiterating that our goal is to figure out what the systemic failures were. And so this is one way to think about it is say, when we're doing this analysis, all practitioner actions that happen during an incident are gambles. That is, they are acts that take place in the face of an uncertain outcome. And that's Dr. Richard Cook said that, who's a well-known person in the resilience engineering space. Another way to put that is that you never know, you hope for the best, and then you make do with what you got, and that was said by Nick Fury. So those things kind of come together. So when we think about what can we learn now? So we talked about some of those ideas. So now let's apply this to how do the Avengers work together on these things? So one of the things that when we kind of look back at how they work together or not, as the case may be, blame is a real big thing for the Avengers. Especially Tony Stark loves to blame Captain America. And we're going to now kind of focus on the incident response process of the Avengers. It isn't about prevention as much as Tony might want it to be. Tony thinks about prevention, right? Tony Stark. He wants to build a suit of armor around the world. But we can't prevent Thanos. Thanos is inevitable. But we can learn how to get better at responding to incidents. I used to work at PagerDuty, and one of the things that would drive me up a wall was how much of our marketing message was about preventing incidents. And the reason I try to avoid that is because it's a good way to have your leadership get really mad at you, because they're like, how could you have prevented this? Well, the answer isn't necessarily that I could prevent it, but we can minimize and mitigate the impact, okay? So when the Avengers actually work well together, they have someone calling the shots. And we think about this in incident response. It's really great to have someone in the role of incident commander. Which is, boy, is that a really military kind of way of thinking about things. But terms aside, now you might think that Captain America, Steve Rogers, he tends to be the incident commander for the Avengers, right? But he is also a responder, right? He's trying to solve the problem while he's also trying to run the show. This can be tough, and this is true within your own incident response. When you have someone in an incident is trying to be the incident commander and also as someone that's trying to solve the problem. So these are the things that need to be true about an incident commander. They need to delegate and coordinate. This is one of the important roles of the incident commander. They are a decision maker, okay? Regardless of what their job title might be. But during the incident, they are the decision maker. And again, regardless of what their actual job is in your organization, They are the single source of truth during the incident. Incident command is a role, it's not a job. And again, someone who is an incident commander should not be a responder, because to change pop culture references for a second, as Ron Swanson would say, never half-ass 2 jobs, whole-ass 1 job. So it's really hard to be the incident commander and a responder. So we think, who would be a great incident commander for the Avengers? So you might think that it's Fury. You would think he'd be a great one. But he gets pretty emotional. He gets pretty invested. He has a lot of other things. And, so actually, Maria Hill, I think, would be my pick for incident command for the Avengers, or S.H.I.E.L.D. And he's not an Avenger. Again, go back to the thing. So one of the problems with the Avengers is that they are always on call. And if you aren't part of a rotation, it means you never go off call. So a lot of times, developers, not to pick on developers, developers don't want to go on call, right? Again, I'm an old school sysadmin, so this doesn't sit well with me. They're like, well, if I wanted to be on call, I'd be a system engineer, I'd be an SRE. The thing though is, I got news for you. If you're not on call, you're always on call. The thing is, if you're in a rotation, there is a time that you're not on call. And so if you're always on call, this can cause a massive amount of stress and burnout. One of the things that always makes us wonder is, I always think about this. During these individual movies, like, where are the rest of the team when these things are happening? So it's like, how do we bring people in? Like, where was Tony during The Winter Soldier, right? Where was Iron Man when this was happening? For our teams, this means, remember that our systems are complex, right? There's a lot of things besides just our functional team. We need a way to call in resources from other areas that help us out. We don't have to try to do everything ourselves. Again, bad example of this would be Iron Man, Tony Stark. He says, I have a plan, attack. So quick thing, and I'm running slow on time. I don't want to be between everybody and lunch, but we're almost done. Years and years ago, when I was a little baby sysadmin, there was a poster that we had in the office where I worked. It was from Microsoft, and it said, how does it feel to save the day every day? Not all superheroes wear capes. And I loved that poster at the time. I was like, yes, I want to be that person. I will save the day every day. And I look at it now, and that is terrible. That's what leads us to burnout, right? You don't have to save the day every day. Also, that creates brittleness in the organization. So, teamwork, maybe you are the most senior person on the team, great, but you still can't do it alone. Diverse perspectives, experiences are all essential in response and incident analysis. And this is where we go into the idea of sharing on call is really, really important. Think about it in the Avenger. Captain Marvel's the only one who had a freaking pager on the whole team, right? But the more people that are on call, the less the load for everyone, right? So I think back to days when it was like me and 2 other people. That meant I was on call every 3 weeks for a week at a time. If we have a broad team, I can be on call for just a couple days over time. And then this gives us a consistent mechanism for bringing in experts that I need to escalate to. And I wondered a while ago, I wonder if PagerDuty works in space. And so I said yes, but wow, the latency. So finally, what have we learned? Let's just wrap this up here. All of this stuff is all about trust. We can't work together without trust. Blame erodes that trust. And perhaps most of all, the most important thing to remember from all of this is never ever put the Avengers on call for your software solution. They are quite literally the worst at this. So you can find these slides, which aren't terribly interesting, but all of many supporting links are at speaking.mattstratton.com. And these are just some acknowledgments I like to bring in. So Jeremy and Carissa helped me think of this talk years ago. A bunch of other fun folks when it comes to that. So thank you very much for that. And I was the last one staying between you and lunch, so we can have lunch now. And that brings us to the end.
It's nice of you to dismiss the audience, but not quite yet. Here you go, Matt. That's for you.
Oh, I already have one.
Oh,
well, I got one from the workshop. Cool. Thank you.
One question, though. Where can we get the cat?
Oh, yes, that's a really good point. I have a few more of these. So did anybody ask? Where can we get the cat ears?
That's the important question.
I will give you the same thing that I did at KubeCon. I have a few of these in my bag. You can have a pair if you tweet a selfie of yourself wearing them with a certain hashtag, per Lumi, and the conference hashtag. So there's that. So you can find me during lunch or something. Yeah.
Yeah, cool. Well, thank you once again. Right?
Yeah,
thank you.
My pleasure.
Okay. So before you all run off, I can see you all running, I would do the same. So downstairs we have, from our sponsors, we have tacos and ice cream, so please go and enjoy. And we have a special attendee gift down at reception. Make sure you do pick one up as you go out for lunch. Thank you all. Hey everyone. Welcome back in. I hope you had all had a great lunch. For those that are still outside, please make your way back in if you can. We'd love to see you back in the room for our lightning talks. So up next, we've got 3 talks in rapid succession, all for 10 minutes each. And first, I'd like you to put your hands together and welcome to the stage Shul, who's going to be talking about open source Terraform modules for Datadog alerting. So welcome, Shul.
Thank you. Yeah, okay, so let's try this. Yeah, this talk for me started a while ago. I filled in a form for a Datadog partnership, and they said, maybe we can bring you in at bigger enterprises. And I was like, yeah, whatever, we'll see. But a few months later, I was working for Toyota. They had this Kubernetes cluster. They wanted it monitored. And at that point, I already was saying, okay, we're clicking around the monitoring, but I think we should do it more consistent. But before I go into the talk, I'm Jules Janssen. I work at Cabisa. We're a small, or 100-ish consultancy company in Weert, in the south of the Netherlands. I mainly do DevOps. I already do quite a long time that I do monitoring. Nowadays also then application performance monitoring. I'm trying to set up the Datadog monitoring for Toyota in Europe. I have a weird hobby. I have this big macaw. We actually train him to fly around. You see my wife up there. We do bicycle runs with him. He flies along. People ask me all the time, doesn't he fly away? Yes, he does, but he just sits in a tree, and at some point, he'll come along. We also leave him outside flying around, but lately less so because he picks the washing pins when people hang their clothes out to dry. So we're not doing that much anymore. So back into the talk. This started with, am I the only one having this problem? We're monitoring several systems for Toyota, and sometimes you have development, production, acceptance, maybe different technologies, and gradually you learn how to configure your alerts, the thresholds you want. Maybe for the production system you want it more tightly, maybe you want other people alerted. So there was lots of knobs and tweaks that I had to manage, and I was like, where's the Terraform modules? And actually the only thing that, it's the only possibility you have. Either you run your own stuff or it was Terraform. At least when I got started with it. And there weren't a lot of modules out there already. And I have to say that I should have published mine way earlier on the Terraform registry, but maybe I felt more confident by the time I did it. So we do Datadog monitoring for multiple customers, and I quite early on said, hey, this is not the thing you're trying to make money with for Toyota. We have different customers where we would like to share the engineering time. We love Terraform at Cabisa. I always say Terraform all the things. Sorry for Pulumi, who were here earlier. I didn't find a Pulumi provider so far. Yeah, I like to use open source modules, and I like to share those modules as well. And so far, I haven't got any people who said, hey, I'd like to contribute, or thanks for what you've been building. We've been using it. Maybe there are. There's also a lot of anonymous users out there, I guess. Or I hope. I guess it's wrong. I hope. So the challenge is you really want to avoid ClickOps as well for managing alerts. I really like the idea that I can track the changes I did to our monitoring thresholds or who gets assigned, so that you can reason about why was it in this state when we built it, or why is it how it is right now. Yeah, like I said, we had a lot of repeating configurations, and when I thought of one thing, I need to implement this and all the other alerts as well, and yeah, then you go clicking over all the alerts that you have. By now I'm managing like 600 different alerts. I cannot imagine doing that by hand anymore, so I'm happy that I've automated things, but I do find myself building them quite a while, so it's taking some time, and I try to automate building the Terraform modules even. Like I said, we didn't have the real modules that I like to use when we started along, and in a nutshell, it's all about standardization of what we were doing. On the slide here, I'm showing some technologies that we do have modules for. Not all of them I've already put on the Terraform registry. There's also new ones coming up for Nginx Plus, Elasticsearch. Things I'm actually actively managing, for example, is the Kubernetes one, because, yeah, well, that's one of the more important things we use. The AWS one might be a bit confusing, but all we do is make sure that there's no service outages, and then we send alerts. So it's not like we manage all of AWS here. Basically, normal Terraform module structure. I have a Git repository with a basic module that I have for doing alerts the way I like to do them. Might be opinionated, and like I'll mention later on in the slides, the way I do things might not be suitable for you. I've got a lot of parameters to make it suitable for others as well. So I have this base module, and then I build larger modules based on that one. And like I said, I've already put quite a few on the registry, but yeah, mine are on third and last page of Terraform, so that's why I'm actually standing here. I'm hoping to get more traction for it. This is just an example of how you would monitor a normal VM, be it Linux or Windows. I've got quite a list of alerts that I've got there. Not all of them are enabled by default. Highly configurable, but the things you really need to configure, I try to keep it as small as possible. Actually, because I have got multiple modules, I also have a sort of template repository of which I base my newer Terraform modules on. And I terraform my Terraform modules, which I also like because terraform all the things. Also, I've got a small module that I've wrote to generate the documentation for. There's already a bunch out there for generating documentation for Terraform things. But the way I've structured it, I had just some customizations that I wanted to make. It's more opinionated towards what I would like about it. Here's an example of the documentation that I generate. I try to think of sane defaults, but like I said, they might not be sane for your use case. Please don't hold me accountable if something fails in your infrastructure. And yeah, Jules, your module, you were supposed to keep things alerted. 2 minutes. Thank you. Like I said, also, I've got this Python script that I can point to a monitor ID in Datadog, and I generate the Terraform out of it. I actually can generate an entire module, like 80, 90% of the code, based on some Datadog query I put inside my code, and out comes like the base framework for how I do a certain technology. Yeah, I've got a few closing notes. What I've learned is that Terraform plan minus target doesn't really hurt that much when you do just things that don't interdepend. It's one of the things you usually don't do. But for alerts, there's no interdependency. If I change a VPC, there might be a lot of things that drop out of your environment. For a simple monitor, it's not a bad thing. Like I said, my defaults may make no sense to you. I've got like hundreds of variables to tweak. That's why I also have sort of a my monitor variables.tf file for each alert that I have. Yeah, okay, maybe I should have led with that. A monitor in Datadog sense is what your alert. Near the end of the talk, it's not the right point to say it, actually. So yeah, like I said, I really like to find more contributors. I think I've got something built that's useful for a lot more people than just me, or just our company, or our customers. Yeah, if you can, if you're interested, really find me on LinkedIn, or yeah, find me somehow, talk to me, and yeah, pleased to meet. I'd like to meet some like-minded people.
Thank you so much.
Thank you.
No problem. You can put that there.
Yeah.
And given the nature of the lightning talks, we'll keep rapidly moving on. Something I missed at the top, even though we have the Slido up, the lightning format doesn't necessarily mean that we can take questions, so just to make sure that everyone's in the loop there. And
can we get the...
Oh, it's in the hub. Okay, and for our next lightning talk, Polly's going to talk us through great ways to slow down your CI/CD pipelines. Take it away, Polly.
So, it's great to see so many lazy slackers here too. Well, first of all, I lied. It's not going to be 5 great ways to slow down your CI/CD pipelines. It's going to be 40 ways to slow down your CI/CD process. And we've still got about 9 minutes left, so it's going to be a bit of a ride. I guess your first question is, why? Because that's a great question. Well, as most things in life, this thing started out as a joke too. It probably originally started from XKCD 303. Everyone who has seen this, and you can't talk about build times without coming across this thing. Well, to me, this also was a part of my reality. As a data engineer, I do a lot of error-driven development, which means that you try to build something, you get an error, you figure out what went wrong, and then you repeat this process until something works eventually. Well, this can take a bit of time. Back when Corona hit, we were working with a hybrid cloud. This was not during my time at Schuberg. And I was trying to connect to a physical device about 5 network hops away from Azure. That took me 38 deployments, going through DTAP, or in that case only DAP. And for deploying an Azure App Service Plan, it takes about 15 minutes each run. So when you're doing error-driven development over 3 weeks, I probably spent closer to 30 hours just waiting for pipelines to run. Plenty of coffee time, plenty of time for Reddit, but those kind of times aren't really productive. So why? This whole talk is about actually becoming mindful about the things that cause delays in our CI/CD pipelines. I'm not going to tell you what to do. You'll figure it out. I'm not an expert. I've done DevOps for about, I guess, 4 or 5 years of my life. So you guys probably know these things better. So today, I absolutely hope to teach you nothing. I'm going to teach you how. Well, let's start from building and deployment. Well, agents are fun. It's really easy to spend a lot of time waiting for stuff if you have no agents to actually do your work for you. If no one's around, I mean, nothing gets done anyway. So that's a great place to save. You can also share them with your entire organization so that they never become available. Containers are fun. They're what everyone does. You can use them for anything, and you can use them for absolutely everything. So why not do that? If you build them in an interesting way, and you don't do layers, you don't cache anything, you can spend plenty of time just waiting for stuff to build. If you want to go the next step, you can also compile stuff inside your containers, and then you just have so much time. You can also outhouse your dependencies so that you fetch them from somewhere across the globe, have no repos yourself, so you can always wait on something else. And if you want to go all in, then you can also couple your container and your data so that you can never do anything without actually rebuilding your containers. Let's get to pipelines, because everyone likes pipelines. The plumbing of CI/CD. Well, it's easy to spend time when you're building everything all the time from scratch. You're deploying everything all the time from scratch, and you're running everything all the time. If you're doing DTAP or DAP, do that always in order. Never parallelize anything, and you'll spend plenty of time on that. You can always also go with the track of failing out early, which means that when the first error occurs, your pipeline terminates, and then you'll spend a good deal of time just rerunning your pipeline until you get to your final step there. You can also go the other way. If you don't fail out early, then your pipeline will basically just run forever and encounter plenty of errors, and then it'll wait on your runners to become free. Also works. Most importantly, log like it's a murder mystery, and you'll spend plenty of time figuring out what happened there. If you're importing stuff from the weirdest sources, that also helps, because then you never know where things went wrong. Yeah, there's a little bonus tip for you if you want to do things even more terribly. I've got a couple challenges for you. Let's not really go into that, but involving a change management process in your pipeline is a great way to spend some time on that, and especially waiting on someone else to do something for you. Let's go to IAC. You can do the same thing here. Scrimp on runners, so you're going to be waiting on an agent or a runner to become free. You can share these resources across your teams and across your workspaces. Yeah, it's going to cause some delays. And of course, plan and run everything all the time. Ideally on a commit, maybe on a pull request, and then maybe leave your pull request open so it acquires more commits over time and then causes more runs. Great way to spend time. And absolutely prioritize nothing. Dependencies. Who doesn't want to spend time in dependency purgatory? The more you have, the more chances are you'll end up there. If you fetch stuff from weird sources, it's going to take time. And don't forget to do your security scanning every single time. It's even better if you have a free plan, so then you're rate limited and you can spend time waiting on that too. There's two ways to go about it. You can pin everything. That also works. And then never update anything until it's already broken, and then you need to update everything. Or you can pin nothing, which gives you a great opportunity to let your package manager find its way out by trying to find compatible packages somewhere across the world. Well, I mean, everyone's talking about mono repos again. We're converging on reasonable monoliths again. That's a great way. If you have a huge application, that's going to take some time to build. Or you can spread it entirely across your organization as microservices managed by different teams, and then everything is going to be broken constantly, and you'll need to spend time figuring it out. That's not great for your Reddit time, but that does add overhead to your CI/CD time. QA is best when it's someone else's responsibility. So just toss it over the fence, and it's no longer your problem, and it's your time now. The further away you move your QA, the more time you'll have. If it's across the world, that's even better. If it's done by humans, then plenty time. And yeah, do code reviews and require them, but yeah, don't actually do them. Just press the button. Yeah, test everything. I mean, we've all seen it. And don't do mocking, and don't do any promises. So your application boundaries will constantly shift, and you'll never know where the problem is. Let's not even go into development. And my personal favorite is that it only works in production. That's what happened with the Azure one. The networking only worked in production. Why? Well, I'm here to try to say that error-driven development can be a bad idea. As a data engineer, I do it plenty. Other people don't necessarily need to do it as much. Be mindful about it. So what can you do with this information? Well, indeed, be mindful, be reasonable, and if you have any more terrible ideas, just hit me up. Thank you for your time.
Thank you so much for the great talk. This is from us. No problem. And we have one more lightning talk for you. I think I've seen you on the stage before. Okay, I'd like everyone to please welcome Jason, who's going to be talking about tearing down silos with RFCs. Please, everyone, welcome Jason.
This one work? Yes, it does. Sweet. Hey, everyone. So I'm sure you've all seen this image before. We're all familiar with it. It's the software development lifecycle. You heard Emily talk about that yesterday, about how it's old and it's bad. And this is particularly bad, but not for the same reasons. It's bad because, well, it's designed this way because someone's great idea, whoever the artist was that came up with this, thought, well, we all work together, right? This is DevOps. We're all one team. So it's one continuous unit, except for it's not. Right? We all work in organizations, and it's often split up like this, right? You've got the dev side, you've got the QA in the middle, the ops side. Maybe you work in an org and you have no QA, so that means your devs are supposed to do QA, or you're not doing QA, or you're manually doing it. So the problem with this is it really redefines, or it reinforces the silos that we have, right? We have these things, and now it's a very clear boundary that we're not working together. And the problem that I have with this is that little plan section that sits in the development side. How many people are in ops, and you've had some sort of architect that's been like, I designed the system, this is what you have to do. And you're like, that's not possible. Or I was talking with Raita earlier, I don't know where she is, maybe she's outside, and she was like, yeah, that's my budget that you're playing with. But you designed it, but it's my budget. So this is bad. And it's bad because all of these need planning. You can't just do the planning and then write the code and be done with it. You need planning for how you're going to test things, how you're going to deploy things, how you're going to operate them. And so not only do all of these need planning, but if the planning sits on that dev side, the problem is that all of the teams that are involved in all of these need planning. So that's why I wanted to talk about RFCs and how they help tear down silos. We've used RFCs at plenty of companies that I've worked with. Surprise, I don't actually work for a company right now. So I am currently repping the Oregon Bartenders Guild. We make fantastic cocktails and drinks. If you need to get a hold of me, though, that's my contact info up there on the screen. So what is an RFC? How many people have heard of RFCs? Everybody. How many people are actually using RFCs? Very few people. This is sad. RFCs stand for Request for Comments, which is cool. Basically means that there's a proposal and a discussion and comments. They've actually been around for ages. So the Internet Engineering Task Force, the people that basically came up with the idea of the internet and most of the standards that we have, started the first RFC for them, for tech anyway, in 1969. There have been a lot of great RFCs over really interesting topics like IPv6 and other cool stuff. You should definitely read these when you get the time. But RFCs today are a little bit different. I've done RFCs at many of the organizations that I've worked for. They all look a little different. So I'm going to give you a quick overview of the parts of the RFCs that I like, that I find useful, and maybe what your RFC should look like. So there's 5 pieces. The first one is the summary. It's just going to be a short description of what you want to do. Could be a couple sentences, could just even be a couple bullet points. Doesn't have to be in depth, but just simply, what do you want to do? So this is probably smallish on screen, but let's say that we're going to do an RFC. We had these, this fantastic beer. Hopefully you had the beer yesterday, yeah? So thanks to the organizers. But I want to do an RFC. I want cider at our next DevOps Days Amsterdam barbecue. Yes, so we could do a custom cider. That's my what, super simple. The next part is the motivation. Why do we want this? Well, why do we want it? Some people love alcohol. I love alcohol. Not everybody loves beer. So that's a good reason, right? So pretty straightforward. Now we have the what and the why. Then you dive into it. The proposal is the core of what you want. And this is the point at which you should try to get everybody together. Your QA people, your testing people, ops people. This is where you dive deep into what do we want to do. Not only what do we want to do, but how do we want to do it, as deep as we can. So I always like to break this down into the build sessions, the testing sections, the ops, the monitoring. Think of the entire life cycle, put it in here, dive deep. And one other piece that I like to include is the alternatives. What other methods did we consider and why are we not choosing them? So for example, I've got my proposal here. We can talk about how we're going to craft our cider, where we're going to get it, how we're going to bottle it, how we're going to serve it. You know, similar to yesterday, we can have it out there. We can have our servers monitor for us and let us know when we're low. And then alternatives. Well, I like cocktails, but obviously bartenders take a long time and there's a lot of us, so we chose cider. After that, we've got dependencies, and this is extremely easy because with the proposal, you've gone through things, you've gone deep into how you're going to do something, so now you should have a clear idea of who should be involved. But then you ask me, well, why do we have dependencies if it's called out in the proposal? And that's because sometimes not everybody is involved in the how things are getting done, but they're very important for the discussion, right? If you look at the proposal here, I never talk about how we're going to pay for this cider. So when we think about the dependencies, we can start to think about adding those people. For example, we need a sponsor. Or real-world example, a friend of mine is a Salesforce administrator. He told me about a time when the product team built a feature, the sales team sold the feature, and then they went to invoice the customer. Guess who was never looped in? The guy that runs all of the sales stuff that would print out the invoices. He's like, that doesn't exist in Salesforce. Good reason to have those people in on the RFC so you can cover your full process. Last section is risks and questions. It's everything that you don't know about. All the ways that you could possibly fail, start to think about those so that you could think about how you can mitigate them. And then one of the cool things that the IETF does is they add experiments to this section. So what are the experiments that you can do to start to gather that extra data? So with that, some more additional tips, right? That's what your document looks like. Other tips, though, when you're running this process. Number one, set a limited time period. So 2 weeks for me is a great place to start. Just limit it. That should give everyone enough time to take a chance to read it, to comment. If you need to extend that time, you totally can. But I like to start with 2 weeks. The next question that people always ask me is, what tools do I need? You don't need any tools. Use the tools that you've got. Anywhere that you can write up a proposal, anywhere that people can comment. I've used GitHub Issues, I've used Google Docs, really wherever. Minimize the friction, so use the tools that you have. Be inclusive, right? So you're gonna come up with that list of dependencies, the people that should be involved, you're gonna invite them, but also invite your junior engineers and everybody else to be part of this, because it's a great learning opportunity. The fourth and most important tip that I have is build trust. There's two things that go wrong with RFCs. One is you write up the doc, people comment, and then people just dismiss those comments. This person doesn't know what they're commenting about. They clearly don't have the context. Rather than dismissing that and reinforcing the idea that their thoughts don't matter, provide some feedback. Similarly, the other problem that always happens is dogpiling. Someone writes up a proposal and it's awful. This is going to be a failure. And so someone writes out, this is awful, it's going to be a failure. And then other engineers join and say, yes, this is awful, it's going to be a failure. And the person that wrote the proposal now thinks, I should never write a proposal again. So rather than just saying things are awful, encourage people to comment back, propose solutions. And the final is to focus on learning. RFCs can seem like a heavy change management process. We all hate that. That's why we like DevOps. That's why we like automation and moving quickly. If you focus on learning, you start to reinforce the idea that this is a collaborative tool that we're all learning together. It's not there simply to manage our changes. So to close out, what is an RFC? Well, originally request for comments. Comments are fine. But to me, RFCs, request for collaboration. This is really what DevOps is all about. It's getting us all together, working together. Thank you.
Thank you so much, Jason. This is from us?
I already got one.
Oh, okay. Thank you. Okay, everyone. In just a moment, we're going to be kicking off our open spaces again, and I hope you've all got some exciting topics in mind. But here we've been at the Packhouses Viger. I hope you agree it's an amazing venue. There's been great staff. They've been so super welcome. Can you just give them a round of applause, everyone? But what you may have not seen is there's been one person running the show behind the scenes, and I'd now like to welcome Ilse. Could you come to the stage? Right, everyone. Thanks, Ilse. You've done an amazing job running the show. And Sheila, we have a present for you.
Thank you, Sheila.
Your contribution has been amazing. It couldn't have happened without you. Thank you so much.
You've been amazing. Thank you so much for all your help. My pleasure. We really appreciate all the help that you've been giving us. Thank you.
Thank you so much. Okay, so now I'm going to multitask and hope that my open space people are also ready as I try to get things done. Yeah, and I look some terrified faces over there. So, you want to take this mic? Yeah. I'm going to get some.
So, if you want to look cool, oh. So that actually goes to everyone. If you want to look cool, you can. So what really helps is having a really cool mug. So on your way out, after everything, when you leave, grab a mug, please. As a reminder, as a token. Nathan, where did I see you last?
That's a good question. Where did you see me last?
I don't want to talk about it. My birthday. No, you weren't there.
No, I wasn't there.
No.
I was using the law of mobility.
As you want to do. Good.
Yes. Indeed. So, who went to their first open space conversation yesterday? Let's have a round of applause for those people. They participated in open spaces for the first time. That's amazing. So you all remember the rules, right? What is the law? What's the law? Law of mobility. And what does that tell us? Use your mobile. Yes. Yes. Very good. Very good. Very good. Yes. Yes. Okay. So we have a great afternoon planned for you, and we have a great afternoon that has been unplanned for you. So we're going to turn some of this afternoon over to you, but as you can see on the schedule, there are a number of options that you have. Really, I would kind of classify these as 3 options. Cool. There's 3 of us.
Hold on. Yeah, okay. Yeah,
so maybe we could each talk about one option.
Cool. Which one would you like?
I know which one you want.
Do you?
Nope.
Okay, that's one thing. So much for telepathy then. So what I would like to, can I pick one that's not on the slide and that we haven't spoken about before? So what I love about these days about DevOps, and it's still, I think it sources back to, it starts with open source, which means it's people that care about the code. We tend to care about each other. And I think we try to build a lot of connections between people talking to each other. And one of the options that we absolutely want you to do, you're here for the talks, you're here for the open spaces, but if you find someone and you're having a connection, you're having a meaningful conversation, and you're learning, you're contributing, I want you to do that this afternoon. If you find those people, you find those persons, and if we can fire start with an open space, fantastic. But find someone, you know the terrace downstairs, you're having those conversations, do that. That's why we got you here. Find those conversations, it's an opportunity. So take that time.
That's right. It's like, you're not the boss of me. I don't have to go to your talks or your open spaces. I can create my own time and space and people to connect with.
Yeah, that's exactly what I meant, yeah.
Yes, yes. Hey, do you, you know, we've served some croissant here at the venue, yes?
Guilty.
Yeah. Were there any donuts? I don't remember.
I'm getting upset now. There weren't.
No, there weren't any donuts. Okay, that's good. Do you know why there weren't any donuts, though, boss?
Go on, then.
Yeah. So, when you're in a conversation, have you ever been in a conversation? It's going to be very hard, but stand up with me. Yeah, come on, you can do it. There we go. Right. Okay, so we might be standing in a conversation, and imagine that there were a number of us, and we were standing in a circle.
We were? Okay.
We might be the shape of a donut.
Brilliant. Okay, I see where you're going. Like it.
But what's better if we make the shape of a croissant while we're talking to one another? Oh. Do you see where I'm going with this? Yeah.
I'm feeling you.
So now, if we're the shape of a croissant while we're having a conversation as opposed to the shape of a donut, as a croissant, it's very easy for someone else to come and join our conversation. So we're showing with our body language that we're open to others joining our conversation. We're making space for that. And it's really an unspoken invitation for you to join our conversation. What do you think?
I'm taking notes.
Yeah, good.
Learning.
That's good. But you know what's better than croissant or donut?
2 croissants and donuts?
No. Picnic tables where you can sit down. Oh, it's nice to sit sometimes.
If only we had some of those.
Yes, so if you find an open seat, please feel free to join that group at the table as well. Yeah. Okay, so you can find and make new DevOps friends while you're here. You can join some of the talks that we have this afternoon. What do we have on in this space? Let's see.
So in the never-changing world of DevOps, the program has, as we promised, changed a little bit. So
continuous improvement.
Continuously improving, so indeed. So Stefan and Elke are up next from PostNL in this room. So there's a couple of great talks coming after that. So Farah, that's the change that we had this morning. So we had, luckily, Stacy step in. But she's still going to do her talk, so we're looking forward to that. Good luck, still here. So that's still going to happen. And then we have Matt after that. But in the same time, as we said, you can have that conversation, join an open space. And then, indeed, Ricardo for the reliability advocacy. Yes. Nope, still not. But anyway, that was my reliable English, by the way. So that's the best I could do. Doing the fourth session, and then actually what you don't see here is there's a couple of raffles going on that sponsors are running. So we'll do that right before or after Stacy's talk. So we could all be here, close the day off, share some learnings, share some adventures. I think it'll be a fantastic way to end the day.
That'll be a great way. I hope I win.
Well, yeah, I know some people.
Okay, all right. No.
No, I don't.
No, you don't know any people. Okay, so we've come to the part in our agenda again where we're turning it over to you. We're going to ask you what topics do you want to bring to the open spaces today? Maybe there's a conversation that you didn't get to finish yesterday, and you'd like to propose that topic again today. That's fine. Maybe you were inspired by some of the talks you saw this morning, some of the conversations that you've had, and you want to open that up to a bigger group. So I would ask that as I just say these final few closing remarks here, if you would start queuing up and getting ready to propose your topics, that would be great. So remember, we're here for discussions with one another. Everyone here is invited to propose a topic. You have to be passionate enough about that topic to start a conversation. You don't have to know anything about it. Your topic might be a question, but you are ready to start that conversation with some fellow folks here from DevOps Days. And of course, it is a conversation, so you want to listen as much as you speak, or maybe twice as much as you speak. And finally, our law of mobility. And just to demonstrate that again, if you are finding yourself in a conversation, hey Sheila, what's going on?
Oh, just making sure that I can get the board ready for everybody to walk in and post their Post-it notes. I have some markers here, so please start queuing up, and we'll make sure that your topic is
ready to go and on the schedule. Great. So that entire time I was getting something out of the conversation. It was great. But now I feel like I don't have much to offer, and I'm not really getting anything out. I'm going to invoke the law of mobility, and I'm going to go have a conversation with Chris. Chris, I don't know if anyone has complimented you on your shirt choices. Can we have a round of applause for Chris's shirts? Very good. Okay, with that, who wants to propose our first open space for today? Here we go. Yeah.
Thank you. So I would like to propose some ideas about hiring 2022 and beyond. Just come and join my talk.
Excellent. Come on down, people.
You can put it whichever.
So the only sensation I want to have, because I try to get people out of the room so the next conversation can start, is people to look at me angrily as they're still involved in the conversation they were having. That's what we're going for. Get those open spaces up, guys. And indeed, the terrace on the outside, that doesn't happen, it doesn't exist. So we'll make it clear that one table is meant to be that terrace outside. So
And
will happen this time.
Workspace and the third floor lounge are also not available. So it's just Isol Studio Expo 1, Expo 2.
Well. Yeah, so I'm currently trying to get rid of my WordPress websites by switching to static things with Hugo. And I just wanted to share experiences with that.
Cool. Excellent.
Very nice.
Yes, you're allowed to applaud in the meantime, by the way. Yeah, cool.
So I can, if we don't have enough open spaces, I can make the terrace available for.
Indeed.
Exactly.
Precisely.
We can just put up a A4 size paper and say this is where the open space is, but
excellent. That's fine.
Cannot
space.
promise. Yeah.
Hi everyone, my name is Tom. I'd like to learn about your Terraform disasters. I want to know what happened, what went wrong, and how we can make Terraform better to stop that happening.
Hi everyone.
Thank you.
I would like to hear your crazy remote work stories. So after remote work happened, I realized we could live anywhere. So I moved to a ski resort for a couple of months because I wanted to ski. I wanted to hear if there's other outdoor enthusiasts here and if they have crazy stories about remote work and living in wild places, possibly in camper vans or something, because I need some ideas.
Hi, I wanted to talk about how we can improve the sustainability of DevOps. How can we lower our CO2 footprint and so on?
Yes. Hi, everybody. I would like to discuss how to properly do operations as a product, as opposed to a process.
Yeah, and the security topic, ask me anything about the darknet and looking around the darknet to get some data.
Can you find my password? I've lost it, yes.
All right, cool. So I am Peter, and I can maybe join the other one who wanted to reduce our CO2 impact, and I want to talk about how to kill blockchain.
Hi, I'm Dave. I was talking to Chris, I was complimenting him and everyone who organised this amazing event, and I was asking how he did it, and he said, pitch that for open sources, because I would love to know how you build a community and something that's cool.
Nice.
All right. I think they did a great job as well. So thanks, Bas, for saying no to me yesterday. Made me more enthusiastic about topic HR retention policies, which how do we get the best out of our workplace, basically, and what did you make, or what were the particular reason that you transferred into another company? And I would like to understand that. And become, of course, the best DevOps employer in the world.
Nice.
Hi. I wanted to find out if we really know what our end users want and how it influences the choices we make in our priorities.
Good. I'm going to make open chairs happen. Okay.
Hi, everyone. After 3 days of organizing this, I would like to discuss with you about power napping. Like, how can we make sure... How can we make sure that we survive days like this and get a bit more energy?
Yes.
You should put it on the board. Yeah. Okay, so after discussing with the other organizers and with the venue, we can make an open spaces happen downstairs on the terrace if you want. So if anybody has any more topics, we can make that happen.
Everyone has a solid plan for the rest of the afternoon. Did anyone not hear at least 2 topics that they're interested in for this afternoon? Yeah, that's better. It usually doesn't work. Yesterday it worked well. All right, very good. Well, with that, let's check our schedule. How's our time look? Oh, so we have... Yeah, we're like back on time, aren't we?
We are back on time, yep. I have 2 more slides I'd love to share with the people, and then we can move on.
Great.
So one is at the DevOps, we want you to be as comfortable and having the best experience that you can have. If anything contravenes your experience, being the best experience that it can have, like harassment happening, etc., we need to know, we need to learn. So we have the code of conduct, and these people are out there. If you are there, so this floor upstairs. You've met Sheila. Please reach out, and you can also go there for the code of conduct on the website. Do not hold back. We want this to be as inclusive and as pleasurable for everyone as possible. So that's the call out there, guys. And like we said, oh yeah, there's raffles, there's people out there. So at the last talk, let me quickly take back. So with Stacy, so 4:45, back in this room. Let's see if we can share our experiences, come together one last time, get the raffle, get the Stacy's fantastic talk out, and then send you on your weekends. Good idea?
Hey, boss, before everyone goes, I need to have a meeting with you.
Donut, croissants, what are we doing?
So, my name is Steven. One last topic, I think, maybe second last. I want to talk about how to have discussions without meetings. Because we find we have things to talk about, we have lots of stuff to talk about, and we spend more time talking than doing.
Are you proposing a meeting to talk about that?
I am proposing a meeting to talk about the meeting.
That went very meta, very good.
Good. Oh, and one more.
Awesome. Yeah, I would like to make maybe some enemies today. I would like to talk about the cost of cloud, or of moving to the cloud, if it's really cheaper or more expensive.
Cool, excellent.
All right. Any final topics? This is your last call. If it's not on the board, you're not allowed to talk about it the rest of the day. Oh no, wait, that's not right. You can
Very inclusive, so proud of you.
Very inclusive, very inclusive. Yes. All right, well, just like yesterday, the board will be tweeted. We'll move it back outside of this room. And there's your schedule. So we will start the first open space session at 2:45. And of course, there's also a talk in here. Enjoy the afternoon. Thank you, everyone. Oh, yes, I will read slot 1 again. That's a good idea. Thank you. I needed one of those power naps that Daniel was recommending. Okay, so slot 1. How to discuss better discussions without meetings. Terraform, something, what happened? What happened? Yes? Oh, Terraform disasters. Thank you. Thank you. Sorry, yes. Share remote work stories, static sites like Hugo, and event and community building. Okay, so quickly, outside, how to have discussions without meetings. Step 1, get out of the building, right? So we'll hold that one outside. The Terraform disasters is upstairs on Izal. Sharing remote stories, also upstairs in the studio. And then in Expo 1, we have static sites, and Expo 2, event and community organizing and planning. And that all starts at 2:45. So thank you all.
Thanks, guys.
What's
that? Yes. And of course, it'll be posted on Twitter. Yes. If I get out of
Hey everyone, welcome back in the room. For anyone that's outside and not participating in open spaces, I'm not sure if I can be heard, but if you are still outside, please do make your way in if you're not participating in open spaces. We have some amazing talks happening in this track this afternoon. Sorry, it's been a very long couple of days. So up next, in fact, excuse me one second, there was an announcement that I had to make as well. I believe there was a winner of the Trilio raffle for, I think it was Arafat Khan, and if you are in the conference, please do go make your way there, otherwise we may end up re-raffling it by the end of this afternoon. So up next, we have Stefan and Elka, and they're going to be talking to us about improving the onboarding process of 150 DevOps engineers in 3 dimensions at PostNL. Yeah. Please take it away.
Yeah, welcome everybody to our talk. We're very thankful that you're here. But first we want to take you into your own experience of onboarding, to start you thinking about onboarding journey. So I would like to have a show of hands for everyone that received an itinerary for the first day. So you got an idea what you were going to do. I see a couple of hands, so that's really nice. Let's look at the first week. So who felt that they built a strong connection with their team in the first week? Okay, mostly the same, some other additionally people. And then finally, who was on call within 2 months? Also, some people. All right, so this is our interesting things that we're gonna talk about and tell you why these things could be important. So my name is Stefan Norhuis. I'm a freelance AWS and DevOps consultant, and I've been working with PostNL for the last year.
My name is Elke Salzman, and last year I started at PostNL as an IT trainee. And today we will guide you through our process of the onboarding journey that we have done ourselves in the last couple of months. So we will first tell you about the problems that we have encountered at PostNL. We have come up with a solution, and this solution consists of an onboarding journey with an onboarding guide that we have divided in 3 dimensions and 4 different phases. So let's start with the background. So more and more companies come along in the digital transformation. So we have a lot of digital native companies nowadays, but also more financial or logistical companies who claim they are a tech company with financial or logistical services, as PostNL, for example. And what we all have in common is that we need to hire good DevOps engineers to achieve our goals. And hiring them is already hard. PostNL has is now searching for 150 DevOps engineers. So finding them is hard, but then retaining them might be even harder. And we claim that retainment already starts before day 1.
So let's talk about the problems that we see during the onboarding journey. Firstly, in technology, we see an ad hoc approach to transferring the knowledge. So there's no structure, and the new hires become overwhelmed. So this results in a poor quality of transferring the knowledge. Then, in another dimension, we see that there's a limited focus on building trust. And trust and a social connection are the foundations of teamwork. And through the whole onboarding journey, there's also limited psychological safety. So people are hesitant to ask questions. Then finally, there's no focus on onboarding them into the organization. What is their place within the organization? What are key people? And only when you critically need people, then you have to talk to Chris or things like that. And then you're not introduced to critical chapters, guilds, focus groups that work on interest or that get to decide stuff. So you don't know, hey, there could be a test guild that gets to decide how testing is done. So these are the major problems that we see during the onboarding journey.
And we think that these problems could be solved by good onboarding of new hires. But let's see, what is the goal of the onboarding? Well, we say that it's a team responsibility to make sure that somebody who is new in goes as fast as possible from rookie to a new team member. Somebody who already adds value to the team and who can already write code as soon as possible. And this way, you build trust with your new engineer to make sure that you build an effective team as soon as possible. So let's see how we, what the solution is we have thought of for this onboarding journey. We have written a guide, and we say that these problems that Stefan mentioned before can be divided into 3 dimensions. First, the technical dimension, where you focus on the code, but in a really structured way, step by step and from the beginning to the end. Then the organizational aspect, make somebody part of the family, part of the company as soon as possible. And the last dimension is the social dimension. So build trust within your team, do fun stuff to make sure that you build trust and thus build an effective team. And now that we have seen these 3 dimensions, we think that you can already divide this onboarding journey into multiple phases. Like I said before, retainment already starts before the first day. So after signing the contract, you can already start onboarding the new engineer. So that's the start phase. Then on the first day, make sure that this one is unforgettable. This will be on top of mind with somebody who's new. And then within a week, somebody might already be able to add some value one way or another. And within a month, somebody should be part of the team, should feel part of the family, so that he or she adds value as soon as possible. And you should think of actions that you want to take in all 3 aspects during all 4 phases to make this onboarding as effective as possible.
So I'm going to show you some examples of the key things that we put in every phase to give you an idea of what you should add to your onboarding journey. So before the first day, at the start, what we emphasize is actually sending an email with day 1 planning. This is an itinerary of the whole day. So the new hire knows what he will be doing, or she, at the first day, what his afternoon will look like, and this really helps reduce anxiety. You could also include lunch plans or lunch options and a phone number in case of a problem, so he or she knows, hey, I can call if my car is broken down or the train is delayed. And then finally, if there is a dress code, you can include it, or you can say, hey, there's no dress code. On day 1, what we emphasize is actually a team lunch. What we want to have is a celebration of the new arrival. You want to have a get-together with the team to say, hey, we are glad that you are here. Sharing food is an Asian tradition, and it really works. You also get to spend time with everyone. Usually your first day, you spend a lot of time with a couple of people, but you don't really get to know and meet the rest. So it's time to start building that social connection. Then on week 1, what we emphasize is pair programming into production. Stacy already said this morning. It's a great way to transfer knowledge. But also from an onboarding perspective, you're not sitting alone, being the new hire, apart from the team, doing your own little chore. No, you're in there together with a teammate. Any questions can be immediately answered, so it's a great way. The second part is pair programming into production, because then you get to see every step in the value delivery. You get to build, you get to test, you should make a pull request, and then actually deploy. Then in month 1, what we think is a great goal is to be put on call. Because this shows trust to the new hire. You trust them to be responsible for the services. And also, you have to build this trust. So it forces you to actually start teaching them to be on call. Lastly, it helps them to also pick up a part of the burden of the team. They are put in the rotation. You can start with doing on-call during the day, and then later transition to being on-call during out-of-office hour.
Yeah, now that we have seen the guide that we have developed, let's talk about who should execute this plan. Well, I said in the beginning it should be a team's responsibility. Everybody should feel part of this onboarding process. But two people might be in a more important role during this onboarding journey. So first of all, the new hire itself, of course. And then second of all, we think that there's an important role for the newest developer, the last one in within the team. And let's start with the new hire. So this one, after months, he or she has seen a lot, has listened a lot to the team and to the company and other colleagues, and should now take action by making suggestions for improvements. These improvements can be either on the onboarding or on the way of working or the technical documentation. But this makes sure that the new hire goes from rookie to engineer as soon as possible. And it also makes sure that the onboarding itself improves every time somebody new starts within the team. And then secondly, the new engineer can already start by improving the documentation. So if something is unclear for the new hire or is incorrect, then this is the person who can collect the correct data and improves the documentation. So either again on the onboarding or on technical documentation. And this makes sure that the new hire can already add value to the team within 1 month. So, and then secondly, the newest developer can also play an important role in this onboarding journey. If by making the newest developer in charge of the onboarding, you lay a responsibility on this person, and you make from this newest developer an independent team member, and he or she has actually the most recent experience in onboarding. So by making him or her in charge, you'll improve the onboarding of the new hire as well. And secondly, make this newest developer explain the architecture. So by challenging this engineer to explain the architecture, you are immediately sure whether the architecture documentation is clear to everybody. Because if it's unclear, then you know that you should improve the documentation or the onboarding. And you can both push them to go to a more senior developer and make him or her explain the architecture if it's unclear for the new hire and newest developer. So by giving those two people a more important role in the onboarding journey, you make it also a learning opportunity for both of them.
Yeah, let me stand over here. What we've done is actually we started automating this in PostNL. So what we've did is we've built a Slack app actually, which will administer the team membership. So when you start within the company, you will actually join a channel, and this will represent you joining the team. This is a proof of concept that we're building right now, but it will start your onboarding journey and say, hey, welcome to the team. The first step is actually to get access to all the systems. So what it will do is ask you, hey, do you have access to GitHub? And in the future, this will be done automatically, either through the app or through single sign-on. And the app will continue guiding you through the onboarding journey, and this includes onboarding meetings. So it will tell you, hey, it's time to set up meetings with the architect to explain the C4 model of your architecture. So this is a great way to actually make sure that the onboarding guide actually gets followed. Then the next step is to meet all the key people. So it will say, hey, great that you've done the meeting. Now it's time to meet the CTO, for example, the product owner, to hear about the mission and the roadmap, etc. This can all be included later in the Slack bot, but we're just starting here. So finally, at the end of the onboarding, it will ask you, hey, what are now the improvements that you suggest? So if you want, you can read the full guide that we've created with a step-by-step checklist of the first day, the week 1 at my blog. It's at norbhuis.nl, onboarding an engineer. I think I'll also tweet it. I think I already did, actually. Yeah. Elke?
Yeah, so now you have seen our onboarding guide that we have developed for PostNL. So we encountered the problem that the onboarding of new DevOps engineers was kind of chaotic. So we have developed a guide for it. And we focused on the technical aspect, where you have a structured way of onboarding somebody in the technical aspect of the job. The organizational aspect should be to make sure that somebody feels part of the company as soon as possible. And also you should also focus on the social aspect of the onboarding. So by doing team lunches, for example, to build the trust within the team and to build an effective team. And you can think of actions you want to take in those 4 phases. So before the first day, whereas retention starts already before day 1. Make the first day unforgettable, and within 1 week somebody can already start coding, and within 1 month somebody can already add value to the team and be a team member if full. So we would like to say, start investing in your onboarding journey and make the first day of your new hires unforgettable.
Hey. Yeah.
Sorry.
No, it's okay. It's okay. It's a little gift for you.
Thanks.
And a little gift for you.
Yeah, thank you.
So we do have some questions coming in. If that's okay for you all.
Yeah.
You should see them beside us here. But does automating the onboarding procedure through Slack not limit the human interaction instead? How do you feel?
I think it's a great question, actually. What we say in the onboarding guide is that, for example, nobody likes asking access, so that should be part of the automation. The other part is the setting up the meetings. We actually would like to have that also automated to make sure that the social part is happening. So you want to set up meetings in advance in everybody's calendar, so it's not like, oh, this new hire is here, okay, I'm going to speak to them 3 weeks later. So we actually want to use automation to make the social connection happen as soon as possible. But yeah, we don't want to shift where we limit, decrease the social element.
Perfect, thank you. And how do you fight the new joiner imposter syndrome that they need to prove themselves?
Do you want to answer this?
Go ahead.
I think this really comes down to the social connection. So in the guide we also say have one-on-one meetings with everyone and don't talk about the work. I think having a social connection really helps to make it psychological safe, and I hope that way the imposter syndrome doesn't arrive. Yeah.
Cool. And there's one at the bottom there that I'm curious on. How did you cope with the onboarding over the last 2 years?
Yeah, I didn't mention that, but actually the team lunch, if you're in a remote or in co-located settings, still have that event where you celebrate the new arrival. This was actually inspired by the GitLab guide that they say, hey, really celebrate the new arrival. For me, onboarding during lockdown was really hard. I think you should still have the connection as much as possible. So have this one-on-one meeting with video. Try to get a time zone where you both can do it. So yeah.
Perfect. And let's do one more. Maybe that bottom one again. Did you collect feedback from people that went through the process that you can share?
Well, we have already onboarded some new people after publishing this guide within PostNL. And especially the teams are very happy that they have a guideline which they can follow. And also the new hires feel that they have something they can use as a checklist, so that if something is forgotten, that they have something to they have checklists to go with to their managers who say, okay, I haven't had a talk with the architect yet. Can we still plan it, for example?
Yeah. And the guide has been spread around my colleagues. I'm a freelancer, so I know a lot of people in the industry, and I've received some great feedback. Hey, I used it and I found it very valuable. So I can really recommend it, at least to get some ideas to think about the 3 dimension in the 4 phases.
Cool. Thank you very much, Stefan.
Yeah.
Thank you very much.
Thank you.
Okay, so we've been doing it live a little bit, and we've been switching up the schedule. So I believe our next speaker is coming to us remotely. Unfortunately, they were unable to be with us in person. I think we're all good to go and all ready. If somebody up there can give me a wave of yes, great. So I would still want to have a warm welcome to our next speaker, who's going to be Farah. They're going to be talking about setting up a quality culture and a scale-up, and from where to start. So please put your hands together for Farah.
Hello, everyone. I hope that you are all hearing me. So I was supposed to come today to Amsterdam to see you in real, but unfortunately, I got COVID, and so I was not able to be there. But today we can also be there with this virtual amazing tools. So I'm here with you to talk about startup query culture in a scale-up environment. So I'm Farah. I'm engineering manager at AncoStore, but also independent productivity advisor. And today I will be talking about a subject that I'm sure that you have already heard about, query. So my story began like 5 years ago. I started working in the technical field for more than 10 years, and I was working in a larger company. And then I get really the feeling that I have to see my impact in my daily job. Working in a more agile way, seeing the impact in the business value creation. And at that moment, I have decided to switch to a startup environment that became a scale-up. And that's how I have discovered scale-up and startup environments. And then I have made other adventures and always stayed in these startup scale-up environments. But before even going on talking about how to put up a query culture in a startup and scale-up, let me share with you something really personal. I'm a huge fan of Formula One. This mechanical sport is really amazing for me. The fact that it has a real complexity from the driver to the team to financial part, but also about the motor, it makes it really complex. And when I have joined the scale-up environment, I have seen a real common point between a Formula One driver and a scale-up environment. You can ask me the question, Farah, what is the common point? The two have a lot of competitor. The two have to race and win. And the idea is not only winning a race, but winning all the championship. And for that, you need consistency. You need to race fast and win all the races and being the best ever around the other competitors to be able to stay. This is how I have seen scale up from more than 5 years now. And I wanted today also to share with you this number, 26%. 26% is the number of startups that want to turn to a hyper-growth environment and that they are able to make it. So this number is really enormous, because it told us that more than 74% of startups that want to turn to a scale-up, they fail. Yes, they fail, and even some of them disappears. So what make a startup or become a scale-up and succeed on that? The answer is, again, like a Formula One driver. And for that, I really like the quote of Lewis Hamilton, one of the Formula One drivers that we have today with Mercedes. He said it's not only about the best driver, it's about the best driver competing for the best team, producing the best car they can. And in a startup scale-up environment, it's about gathering the best customer experience with a great product, with an amazing, talented team. And to be able to make it, you have to have also a great business model. Otherwise, it will not work. And when we talk about all of that, we are not talking about quality. We are not talking about excellence. So at that point, the lot of time when I came in a startup environment that become a scale up, what I have faced is that we are thinking about query when we are starting about the growth path. And when we are thinking about it, we are already racing very fast with good speed, but we are missing a tile. And this tile is unfortunately quality and excellence. And so the most, I would say, the most craziest part about it is when some of the company that call me, they are on what I call the nightmare flywheel. This viral loop of things that happen and that make really query a critical part of their growth path. This nightmare flywheel is like that. They are starting having the more and more important number of incidents that are even not detected internally by the teams, so they are not observed, they are coming from the high complaint of customers, and teams start making a lot of time on analyzing the issue to see if there is a huge issue or not. And so they are missing proactivity, and in the same time, so they are not dividing their time on creating business value, and so they are less productive. And even when they are productive, they are not concentrated enough on creating business value, and so they are creating a new incident. And this is the viral loop, how it will start. This is the nightmare situation for every startup that wants to turn to a hyper-growth environment. Really, trust me, because when you are you have to deliver very fast and a reliable product, if you are in this loop, you are no longer able to make it. So where to start? This is the question. We are here in this nightmare flywheel, where to go? So the first thing that I have said is to evaluate the query maturity. This is a very important thing. Having an understanding of why we have to improve things and what we have to improve, understanding the things before even thinking about solutions is the most important part. And for that, let's pick some KPIs to really highlight what are the main pain points. So for the high number of incidents, maybe you can track your change failure rate and see if you have a lot of incidents and a lot of rollbacks and hotfix each time that you're introducing a new change in production. To see if you are already enough proactive or not, let's go and see the time to recovery. To see if your productivity is impacted, let's go and follow the lead time to change or even the deployment frequency. Like that, we will be able to see what are the major pain points and be able to track them. And these KPIs are the DORA metrics. I don't know if already some people here know about them. I knew that two days ago or a day ago, there was also a conference about that. But DORA metrics are metrics that are identified by Google DevOps research and assessment team, and they enable you to evaluate the team performance. So once you know really where you are in terms of DORA metrics, then you know maybe what are the parts that you should really address. But before even going further, let's don't think about it not only in the operational way, but also in a business impact. As a technical teams, we are always thinking about the operational part, then we think about the business part. But the idea, if we want a query as a global vision, in the company, we should address it as a global topic. And for that, query have also a flywheel and an impact on the growth and on the business value. So maybe your priority is about improving the business value creation, and so having more and more feature, and that could be addressed by query. Maybe your business priority is about increasing customer satisfaction with less incident and more reliable product. It could be also about decreasing the churn by being more aligned with your SLAs and obligation. Or even if you are working with fintechs or banking, it could be guarantee your duties and fulfillment and fill compliant parts, and this is also could be tackled by query. Now you have a real vision about your problems and what you want to achieve. But the problem is that you have seen the problem, but you have different solutions. Today, for query teams and query organizations, there are different models. You can go on a startup, a scale-up, a huge company in the USA or in Europe, in France, or another way. You will see that there are really different organizations, and it's very difficult also to see what is really your need in terms of organization. For that, you have different models. The first one is query assurance. Query assurance is really about the classic way of making query, having testing like manual testers, testing things at the end of the delivery, and being more in a V-cycle. You can also think about query engineering, a more modern way to think about query, and thinking about automation, parallelizing the automation and development, and agile testing. You can go also for another model, query assistance. I don't know if you know about it, but it's really a vision from Atlassian with having query coach, coaching from product to developers, and creating a common vision about query best practices. Or you can go for Google Vision with the productivity engineering and not thinking about query only about testing, but from testing to observability. And so with a shift left, shift right vision. Or even you can go to another way of thinking about it, which is a Shopify vision, which is no QA expertise and having the developer team that are accountable and responsible for testing and query. Now that you are aware of these different models, how to choose the right one? It's all about the tactic. For that, I would say, go and observe your teams. This is a very important thing. Like, go and talk with the different people that you have, from developer to product manager, to product owner, to DevOps, to business-oriented people, and see if they have the same vision of query or not. If, for example, you have one developer that have already like automated test, but you have also in another way a product manager that always worked with a manual tester, you will need someone that came here across the two to unify the vision. If you have already this expertise in your team, go for it. Otherwise, you will maybe need to hire someone. So what we have seen here is that to master your need, it's really like a real cast, because you have different models, different environment. It totally depends on your maturity stage. So think about your organization, the pain points that you want to address, and pick a right objective to be sure to really target the right need. Then you have the need, so you are ready to accelerate. How to make it? The first thing is about setting a clear objective, the goal. Something that I have really encountered different time is how to take into consideration the business challenge in the goal that I want to set. When I have joined AncoStar, the company where I am today, we are in a hyper-growth environment. And my CEO told me, Farah, like query is something that we want to put in place, but we don't want to decrease our delivery speed. So I cannot like say to the people, guys, we will make a task force for testing. That will not work. But saying that Quarry will push for a better speed because we will have less incident will be like the right targeted speech for everyone. The other part of the goal is that it should be achievable. When we are talking about change management, if you set in place like a goal that is not achievable, you will probably fail. And with failing, you will maybe have some people that will be disappointed and they will not follow you. So your change will be fragilized and you will not be able to have the right buy-ins and the right backups to go further. So don't be too optimistic on the goals that you want to target at the first level. This is a very important thing also. Now that you have the goal, go and pitch Quarry at all levels. From DevOps to product manager to the CPO to the CEO, this is a very, very important point. You want to change in a culture at the very, at the all levels. So go and experiment your vision. And for that, you need a targeted speech. You cannot talk with the developer the same speech that you will have with the CDO or with the CEO. You really you have to rethink your manner of making your speech to make it more like in words of the person that you are addressing. And with the targeted speech, in the same time, go and collect this feedback. Like pay attention to the verbal feedback, but also the non-verbal one. Maybe some people will be surprised by what you are addressing and by the need that you have faced. So these feedback will be really precious because they will help you to review your pitch. And then when you will review your pitch, you will experiment it again and it will be more targeted for everyone. And so you will get more buy-in and so more sponsorship. Then now it's the time to operate the change. What I have seen in a very hyper growth environment is that we have a lot of hiring. In my previous experience, for example, at Livestorm, we had 20 new joiners each month. Like it was huge for a company that was only from 100 people at that time. So the first thing to put in place is to make sure that we have the same statement, that the statement that we have at the company level, at an engineering manager and engineering level, we have the same statement. Like that people, when they join, they are able to see what are our principles and they will follow them. At AncoStore, for example, we have made testing as an engineering principle. And each time that today we have a new joiner from backend to frontend to DevOps engineer, they know that they are accountable for testing and that testing is something very important for us as an engineering team. Once you have made that, go and hire the needed expertise. In a hyper-growth environment, you will need someone senior because you need to think about the foundation and a foundation that scale. So you don't really have the time to have a junior person to make it. Or at least if you have someone junior, you have to be able to assist him to create this foundation. Then, if you want to make the change at the very good speed, go and take radical choices. We never take enough radical choices, but this is a very, very important point. Something, again, an example that we have made at AncoStore. 6 months ago, when we have seen that we are hiring a lot, we have decided that testing is something important for us. So we have decided that each time that we have a new PR, the code coverage should be more than 80%. Even that code coverage is not the perfect KPI for that, but at least it will force people to write tests and be more comfortable with testing. And this radical choice has made a change that we move from 20% of code coverage to 60%. And everyone in the team is now aware about how to create unit tests, integration tests, and end-to-end tests. And this is a very important thing. So radical choices are a good move if you want to make the change at a very good speed. And then, at this hyper-growth environment again, go and work with the most prepared persons. If you are operating the change and you are losing a lot of energy to convince people to follow you, again, you will lose a lot of energy and you will not get a reward. But if you will go and work with the most prepared people, you will be able to really see the impact of the change at the tiny level, and you will be able to lead by example. And then everyone will see that these examples are working very well. For example, in a previous company where I have worked, I have introduced observability as something that is part of the definition of done in a team. And once we have done that, all the other teams have seen that it's too good, that they wanted the same thing for their development also, and they introduced the change also on their sides. And to be able to lead by example, I will never say it a lot, but empowering the success and make it visible. For that, it's not only about communication. I would say it's more about marketing the change. Go and create a newsletter about query best practices. Go and maybe have a content, a vision about some articles, or get some speaker in your teams to talk about query and to talk about the success that you have made at the whole level of the company, from the all hands maybe for all the people to like a team meetings. So this recipe helped me to make the change on 3 scale-ups. In the first one, we have made a change of improving the query on 2 years. The second one, we have made the change in 6 months. And today, I'm leading the change at Ankostar. I hope that this recipe will also help you. So go race and win. Go and put query everywhere around you. I hope that that will help you. Thank you, everyone, for hearing this speech, and I hope that it was interesting for you. Here are some references. Thank you.
Hey, Farah, can you hear me?
Yes.
Hey, this is quite strange. I'd be here giving you a speaker gift, and it's quite strange to be doing it like this. But first of all, on behalf of the organisers, I hope you have a good recovery and the best of health to you. I hope everything goes okay. So we have some questions coming in, if that's okay.
Yes, for sure.
So are the DORA metrics the silver bullet? And with good metrics, do I have a high-performing team?
I think that the DORA metrics are great metrics to give you a global vision about the performance of your teams. But they are not the only ones, because it's a very macro vision about what's going on. If you want to go deeper in detail about the performance of your teams, you have also to maybe think about other metrics. And especially, for example, if you have a not like a very good time to release, so your cycle time is impacted, maybe the most important thing is to see like where is the CI time, the CD time, how much you have flaky tests. So these kind of metric also will help you to improve the productivity of your team. But for sure, like DORA metric is a first KPI that will give you a macro vision, but you will need to go deeper in detail to work for the performance like in a deeper way.
Thank you very much. And we have another one just come in. How do you drive change when there's not enough resources for it? For example, no resources to hire the expertise.
This is a very, very good question. I think that for all of that, it could, like the dynamic of change should for sure like came also from deeper, like from the team deeply, and not only from one expertise. This is like something that you have to see in your environment. Maybe if you have already like some developers that are sensitive to query, to talk with them, and you can maybe create a community of practice and animate all this change around the community of practice. As I have said, there are some models like Shopify, for example, they never get like any expert in terms of query, and they were able to make the change. But to be able to do that, you really need like to see if you have people that are sensitive to that and they want really to push the change and make it by, I would say, like opportunity with these people.
Thank you very much. If we have no other questions, I think it looks like there's none more come through. So again, on behalf of us, I hope you feel better and everything goes well. We will get you your speaker gift, and we have a lovely drawing of your presentation that's going on through here. So please, everyone, put your hands together for Farah.
Thank you.
Okay, we are now running slightly early, which is a surprise, yeah. And up next, which one? Yeah, get set up. Oh, you good? Yeah. Let me just help you here. Clear off the water. Cool.
Do we want to start on time or early?
I think early's good.
So that I can go longer. Yes! Yes!
I've got maybe one or two announcements to make first, but so I just want to remind everyone that there's been some raffles going on as well with our sponsors. So please do come back. The sponsors are going to be doing the distribution and the announcing of the winners live on stage around about 16:45. They'll given our awesome timekeeping this week. We'll see how that goes, but it should be just prior to Stacey's talk today. So if everything's looking good, and it does look good from here.
Yeah, let me just go ahead and do a slideshow.
Cool. Well, everyone, I would appreciate if you could put your hands together and welcome Matt to the stage. He's going to be talking about application design parables with what real life teaches us about proper application design.
As soon as it comes up. Okay, 1 second. I guess it's not gonna. It was up a second ago, wasn't it? It was. So that's why we get a little extra time. All right, we'll try again. See, there's that. And then slideshow. And play from current slide. We'll try that again.
Can we have tech and standby laptop on as well, just in case?
And then I don't know what was going on there. It wasn't working earlier. I swear, I tested it. We tested
the joke this week has been, it works on my machine.
Yes, yes.
Can we have a backup laptop on standby, please?
Oh, wait. Now, there it went? There it went? Okay,
hey,
fair enough.
Look at that.
Yeah.
Once
Just
more.
took a couple...
Please
yeah, couple things. So, hello everyone. I know it is Friday afternoon and you're all really excited to probably go hang out at the bar. So, I'll try and make this quick. It's only a scant 174 slides for me, so I'll go really, really fast, hopefully. So, I'm Matt Yakovit, head of open source strategy at Percona. How many people have heard of Percona before? Okay. Good, fair number. So we do open source database software and services for MySQL, Postgres, Mongo. We have backup software. We also have Kubernetes operators in case you want to run your own private database as a service. So I also speak at quite a few conferences. Head of Open Source Strategy is a cool title because it is the HOSS, H-O-S-S. And I get to say the HOSS talks about FOSS, free and open source software, so it rhymes. It's kind of cool. So I'm quite happy with that. So, you know, about half the audience here knew something about Percona, which is awesome. I'm not going to talk a lot about Percona in this presentation because what I'm going to talk about, well, I do have to have the obligatory we're hiring slide if you're interested in working for us. I'm going to talk about what I call the Pied Piper of dev, or the parables that go on in the application space that you can pull from the real world. How many people have ever attended a talk by Amazon or Google or Microsoft or someone massively big and said, wow, I need to try that? Okay, it happens quite often, right? Because let's be honest, a lot of people are really excited about what other people have done, and they want to emulate the success that they've seen. And we often forget that you can also learn from things outside the tech community. And that's a really important thing. So, you can look all around for both good and bad examples of what you should do when you're designing applications, building infrastructure, designing your next systems. And so I want to talk a little bit about some of the more practical or more eclectic things and, kind of compare what we see in the tech space today with what there is out in the real world. So, I'm going to advocate here something for you. Americans love fast food. I don't know if anybody else likes fast food here, but Americans love fast food. And so, did you know that you probably could and maybe would benefit from building your infrastructure like a fast food company in the United States? Seems a little weird, right? But how many people have ever gone to the United States and ate a Chick-fil-A? Oh, okay. Then let me explain Chick-fil-A. So Chick-fil-A is an interesting restaurant. They just sell chicken sandwiches, fried or grilled. They actually have a very simple menu, okay? Same ingredients are used over and over again, so they can have probably like a dozen ingredients, and then they can have lots of different things in the menu. So almost like a microservice architecture where you plug in and start pulling things around. It's previously was referred to as Taco Bell programming, where you could pull different menu items to create tacos. But they created a very simple menu. But really, what I really want to focus on is their stores. Okay, so how many people have ever gone through a drive-through? Okay, fair enough. You're running home, you need to pick up something quick, and you're like, whew, got to do that. So sometimes the drive-thru is pretty popular, right? And so you get stuck in a line. Sometimes that line looks like this. All right, anybody just say, nope, I'm driving by. I'm not even gonna stop because it's too busy. The weird thing about Chick-fil-A is no matter how long the line is, you're always out in less than 10 minutes. It doesn't matter if it's wrapped around the building 4 times. Because what they've actually done is they've started to introduce different kinds of practices. I would call them unconventional practices to deal with long queuing situations. And in order to speed up people getting their orders and make sure that they can get enough people through that queue, what they've done is started to do things like deploy people who are workers who go out to cars in the middle of those long queues, walk up to your window and take your order. And then they'll run out with your food wherever you are in the queue. And so they've actually designed, this is my super crude drawing. I am not an artist. I don't pretend to be. But it looks like a 3-year-old drew it. I'm going to just say I had a 3-year-old draw it because then I don't have to take credit for it. But what you see is they actually have 2 drive-through lanes that you go through. They have a call-ahead lane where you can call ahead, and you can also come in as a mobile order and park over here and get your stuff delivered to you. So they have multiple ways for your work to be delivered to you, right? Whatever your food is. And they have these order takers who are constantly flowing in and out. They actually have a drive-through window and like the order box that you would, order your food from, but they never use it because they're always running people up and down unless it's really, really important. So it's really interesting how they've done this. In fact, they've been so successful at this. The US government during COVID, when we had drive-through COVID testing, they got it all screwed up for like months. And they called Chick-fil-A people to come fix the queues to get COVID tests. Because, wow, they know how to queue. Now, how does this apply to, from an application design perspective? There's a few unique things that we can learn from here, right? So when we talk about building an application, you have a very data-centric application. And you maybe are using like a queuing system. Maybe you've got, Pulsar, or maybe you've got Kafka. Maybe you're doing some streaming. Maybe you're doing some queuing with, RabbitMQ or something. How do you get data to where it needs to go faster? And if we look at how Chick-fil-A has done it, we can look at some things like pre-validating things. So they're going to the people out there and taking orders before they're ready and making sure that it's pre-ready for them whenever they get to the place where they can pick up the food. They also pre-fetch some of that food and bring it out to them to get them through the queues quicker. They segregate, if you remember back to my handy-dandy slide, doesn't want to go back, my handy-dandy chart, they actually segregate, different types of orders, right? So the call-ahead orders, the mobile orders, the drive-thrus. So as you talk about designing your systems, having something that is designed to be super fast, get you data as fast as it can, and then other things that can wait, and other things can wait a little longer, that helps. And so those types of things work not only in the real world, but you can apply them to your application design. And you're always trying to build this kind of like setup where it is easy to use, but it also gives you the different SLAs or the different requirements for each type of data you're trying to retrieve. So this is just one example where you can look at something that is tangible that you could just drive past, in the middle of the day and say like, how could I apply that to what I'm building, or how I'm building my, CI/CD pipelines even. So building aside, this struck me, as something important because I work in the open source space. But let's say you're designing that system, you're designing the different, queues, you're designing the different access layers, and you decide to use open source. I'm hoping most people here are big open source fans. I'm pretty sure you all are. But which version of open source, or how do you define open source? And I want to talk a little bit about that. And to talk about that, I'm going to bring up Vegas. How many people have been to Las Vegas? Okay. How many people have ever eaten at a Las Vegas buffet? Has anybody else eaten at just a buffet, like, you go to a buffet? Vegas is known for their all-you-can-eat buffets. And I had the unfortunate incident of having to do 4 weeks in a row in Las Vegas once. It was like conference after conference after conference. And at the end, you're like, no more buffets. Please, no more buffets. And you've tried all of them. And there's all kinds of different buffets, okay? You've got the free all-you-can-eat buffet, the free continental breakfast with a paid upgrade to get eggs or bacon. You've got the buffet with a free minimum, drink purchase. You've got buy 3 buffets, get 1 free. So there's all kinds of different ways that they emulate this. And at the end of 4 weeks, I started to think of everything in terms of buffets. And so I came up with this analogy that right now, the licensing side of open source is really an all-you-can-eat buffet. Right? So if you look at like the different types of licensing that are out there, right? So you've got the free and open source licenses, Apache, MIT, and as you're looking to choose those are going to definitely be the free all-you-can-eat buffet. Then open core, okay? So where there's an enterprise version. That's the free continental breakfast, but then they're going to pay for extras, right? The hot upgrade. Or SSPL, where it's like, you can have this, but there's restrictions, like you have to buy a drink in order to get the buffet. Source available. Eventually open, like the BSL, that's buy 3 buffets, get 1 free. The freemium cloud, right? So you can try for free, then you're gonna get stuck in the cloud. That's the pay per pound model of the buffets. So again, we look at like things like this, and it's something that's super easy. It's something that you run into, and sometimes it's easy to explain or get inspiration from something as simple as a buffet or a Chick-fil-A restaurant. And the tech buffet right now, even outside of the open source spaces, we've got more choices than ever, which means that there's a lot of weird fusions of food. And if you look at buffets now, you can add like, eggs and, salmon and, all kinds of weird stuff all together and mix it up into an eclectic mess. And a lot of people design their applications like that because we have so many options, And so understanding that, there are that many options and you can do that is important. But helping to articulate that, especially to management and other people in the organization, is equally as important. But I like to kind of move through, if we've kind of decided or thought about how we can pull in some examples from the ecosystem into building the application, and then pick some licenses, pick some software. When I think about picking the stack, I look to the children. And children, they are our future. How many people have kids? Okay. Are any of your kids ever annoying? No, never? Man, you're lucky. So how do you deal with annoying kids, right? And so, I was thinking about this, a few weeks ago. My daughter's 20 now, but man, there were some rough times back then when she was younger. TV shows, right? And I mean, as a kid, I also was annoying, and TV shows kind of got me like, ooh, TV, right? You just stop and woof. And for me, I was a fan of, Transformers, G.I. Joe, Thundercats, those types of things. For my daughter, oh my God, it was so bad, right? But here's the thing that, we can learn from, what our kids are doing and their TV habits and how they go out there and start to become fans of different things, because what this actually leads to is a lemming situation. How many people have ever played Lemmings? Yeah, see, I knew that would get some people. Where, you've got the kid who really, locks onto something, and they're like, oh, I really love Barney, I really love Teletubbies, I really love Furbies, whatever it is. And that becomes, the whole family has to like it, right? And everybody has to follow along. And that means that there's lots of fads. So what was the hot toy? I don't even know what the hot toy was the last few years, but like back in the day, it was the Furby, right? And like, as a parent, you had to run to like 5,000 stores and like sit and like snipe people on eBay to try and get a Furby. Otherwise, your kid wouldn't have a happy Christmas, right? I mean, like, I don't know if anybody else experienced that. It was always horrible. And, like, thank God there's some other things that are iconic and they have staying power, like, SpongeBob. So you can sometimes mix and match, but those iconic ones don't always offset the fads. The fads are the ones that all the kids want. And this really gets to talking about choosing different software, choosing the libraries that we've got going on, because let's be honest, fads come and go, especially in technology as well, right? So how many people have tried software, used it for a year, and then never wanted to use it again, right? Like, how many people have software that they wish they never would have tried, or maybe a programming language that they developed some stuff in and they hate it, right? Like now, because it's like, oh yeah, I really wanted to learn that thing, And I mean, these trends, they come and they go, and you have to understand that they're not all gonna have staying power. And part of the problem with trends is it's incredibly hard to keep up with a lot of the trends. And unfortunately, from a developer standpoint, I like cool things. I want to try cool things. I don't like old stuff. Like, I don't know if anybody else here's like me, but I get a little ADHD when I'm doing the same thing all the time, right? So if I'm developing something in Python all day long for months, weeks, years, then I'm like, oh, let me go try this other thing. And you want to be part of that cool trend. There's a herd mentality there. But there's a downside to the herd mentality, right? And that means that as a company, if you're hiring, well, how are you going to find those trends? It's going to be very difficult. Also, if you are, thinking about long-term sustainability, is this something that's going to go away? Is this going to turn into something that's either going to be tech debt or it's going to be regretware, right? Because that's something that is significant. Because, a lot of people come back and they say like, ooh, I really regret that. So let's say you did choose some of those technologies that were trends, they were fads, they were awesome, you really enjoyed them for 5 minutes, and now you hate them, right? So you have to know that those are gonna come and go, just like some of these technologies. So we just need to, figure out what the next trend is, get ahead of it, right? So I'm gonna start this as the next trend, as the DevOps dude. I found this on stock images, which is kind of cool. So moving and building fast, as part of this, as you start to pick those technologies is, super important, but it often leads to unintended consequences, right? So, you've kind of decided on your systems, you've picked some programming languages, you picked your stack you're gonna use, maybe some of them are trendy, and then you come back and you find that there is some significant issues, even after you may have been successful. Look at the growth of industrialism in the last 200 years, the growth of factories, the growth of industry as a whole. It's been massive, and it's been good times for a lot of people. We've had access to things that 2 generations ago wouldn't have even been heard of, but at what cost? So in the 1970s, for instance, America was rampant with runaway pollution. We still have a lot of pollution, but it was really bad in the 70s. And so they wanted to come up with some ideas. And part of the catalyst for that was the Cuyahoga River. Has anybody heard of the Cuyahoga River in Cleveland, Ohio? This is the Cuyahoga River in the 60s. Yeah, isn't it nice? Yeah, they have a beach there too. It's really nice. I used to live in Cleveland, not in the 60s. I'm not that old. But you know what happened to this river? It caught on fire. How many people have had their applications catch on fire, right? Probably a few. And this was actually the catalyst for some change, okay? It was an unintended consequence of, the amount of industrial waste that was put into the water without any sort of like thought or concern about it. So I'm going to take a PSA here. When I say unintended consequences, those in the AI and machine learning, please do not accidentally make Skynet. I'm just going to leave it at that. All right, so back to the rivers. So as we talk about like rivers, not only were they getting polluted, but they also had some invasive species for a plant life. And so it was really difficult for barges to get through the garbage and to get through the plants and everything else in the rivers in the US. And so they had to come up with an idea. And they wanted something that was cheap, easy, something that wasn't going to, cost a lot of money. And so they started looking around, and some enterprising people said, well, how do we get rid of garbage and stuff we don't want on vacant land? And they go, people use goats, right? So goats as lawnmowers, that's a thing. I mean, there's actually like articles on the internet about that. But we're talking about waterways. So how do we do that? And they go, who are the goats or the garbage eaters of the waterway? You know who they are? They're carp. Anybody know what carp is? It's a big fish? Yeah, okay, yes, awesome. Yeah, so carp are the, the garbage eaters of, the waterways. And the US introduced 4 different species to eat the garbage, take care of pollution, clear out the plant life. And they did it in small select places to test it out. And, it was a success in some cases. Because carp like to eat. That's actually that's a real picture. Like carp get big, okay? But what they didn't realize is waterways, when they flood, they spill into other waterways. So if they're trying to clean River A, but River B is fine, the carp all of a sudden just flood over to River B, and so now the carp are in A and B. Well, because these carp like to eat, guess what happened? They started killing off all the native fish. So then all the fishermen started to complain that we can't make a living anymore. And we're having this massive problem with carp. So now we have taken a problem that was horrible, and we have fixed, well, not fixed, we've mitigated it a little, but we've introduced this horrible other problem, okay? How many people do that, have ever done that in software, right? Like as you've designed something, like you have this tech debt that you regret. Maybe it's an application, maybe it's a programming language you did and then you decide to rewrite it and then you're like, God damn it. Oh, I don't know if I can say that, but I said it anyways, gosh darn it. I think that, why did I do that, right? Because, that tech debt was real, you wanted to fix it, but you might have made the problem much, much worse. Okay? And you might be looking at integrating, cool applications. Maybe you found some new, open source software on, GitHub that looks cool, and you try and integrate it in. And if you don't know what you're doing, you could potentially cause drastic consequences, right? Just like the carp. It's the carp issue, okay? And what works for someone else doesn't necessarily mean that it will work for you. So just remember that, as you start to look at tech debt, and as you start to look at tech regret, which I'll talk about in a second, be mindful that not all solutions are going to make the problem better. They may introduce a whole nother level of issue. Now, I separate regret and debt a little bit. So how I define tech regret is I regret doing this. Personally, I want to make a change. But that doesn't mean that the users will actually notice the change, right? So I don't know about you, but sometimes I look at code and I go, oh my God, I can't believe I wrote that. That's awful. It might work, but it's awful. And so I want to rewrite it. I don't consider that necessarily tech debt in all cases. I think that's more tech regret. And the reason that I bring that up is because that mentality of I can do better, it exists. How many people have ever said, I want to rewrite this because I want to do a better job at this because I know I can do a better job personally. And, I like movies. Does anybody else like movies? Cool. You know, I was a big fan of movies in the 80s, 90s. Movie sequels, though. I got a problem with movie sequels. Is there any movie sequel on this list that you actually thought was better than the first? And this is where it's interesting. There's a few exceptions where you do make, Empire Strikes Back or The Godfather, where the sequel's better than the original. But we're really tempted to redo code that's working well. It doesn't have a negative impact on the users, but you think you can do it better. And if you're not introducing new features, the question is it worth it? And that is a question we all have to ask ourselves, because otherwise we're going to get the Teen Wolf 2 sequel, or Fletch Lives 2, which is not a good movie. It's not good at all. Trust me on that. If you've never seen it, you don't want to, okay? And that's one of those circle of life things that you want to be mindful of is, yes, you might have pride in what you wrote and regret what you wrote. Doesn't necessarily mean that you should go back and rewrite it now, or that it will be beneficial for you to do. Not only could it introduce the CARP situation, it could also fall flat with your users who are expecting regular releases on bug fixes, features, other things that matter, and if they just get a rewritten code that may be a little less flexible, maybe they're not used to it, you could see a significant decline in usage. But when I talk about that regret and the things that you should and shouldn't fix, it comes to the question of when you're shipping features, when is it ready, right? And for far too many people, that answer is a little flexible. Maybe it's a little wrong, right? So this is my house. I bought this house 3 years ago. Nice house. They had built it before we got there. And, they had nice bathroom, plumbing fixtures, like everything else in here. But there was a problem with this house. And we didn't find out about the problem for 2 years. It turns out that the toilet, okay, you can kind of see one of them, they didn't put a piece in right. So underneath the floorboard, it was leaking a little bit of water, just a little bit. And for 2 years, it worked perfectly fine. And then 2 years later, we had to rip it all out, right? Because they forgot this one part. Now, when we talk about tech debt, tech regret, and we talk about fixing problems, and how do we avoid them, one of the things that you have to be mindful of is the worst thing for shipping code or shipping an application is it works without any other context, right? Because if it works, but it doesn't work correctly, that's a significant issue that 2 years later someone else is going to have to deal with. Now, the problem is, right now, the average tenure of an IT person or developer at a company is 2 years. So by the time they find the broken toilet, that person's gone, so it's going to be someone else's. So if you just started a new job, watch out. This is coming for you, right? So it works is not enough here. So, but we want to avoid those problems with the toilet, the bathroom issues, missing those things that are really important to drive, to completion and to ship. So what can we do? And, a lot of us are going to talk about, well, we want to, write a test for that, right? We want to make sure that, before we sign off on this, it has passed all the tests. It has gone through all the, user functional testing. Everything's been perfect. Well, you can look back to the Cold War for a really good example of this. And I'm going to use, I don't condone nuclear war, but I'm going to use a nuclear war, thing from the Cold War. How many people have heard of the Strategic Air Command? Okay, a few people. So their job in the Cold War was to send a plane anywhere in the world within 15 minutes to bomb someone. Not a great job, but that was their role, and this was the time where mutually assured destruction was the thing, and that was the philosophy that the world lived by. And what's really interesting about the Strategic Air Command is they're talking about thousands of installations worldwide, distributed workforces of 10,000 people plus, and they had to have recruits that could come on board and learn really quickly, okay? Kind of sounds a little bit like the situation we're in when we talk about like a lot of our applications, distributed everywhere, lots of people using it. How do we get people onboarded? But I'll get to that in a second. Now, when the Strategic Air Command was created and the mutually assured destruction, philosophy was put into place, One of the things that happened was they rushed this in, slammed it in, and said, we're good. Well, after a few years, they started to find out that it was all bullshit. They couldn't get anywhere in 15 minutes. They said it would actually take weeks to get somewhere if they had to go. And they found out that all the tests that they were doing were inflated because they were testing in a very closed environment. Does the plane take off, go down the runway, loop around and land? Yes. Win. You know, we're good there, right? And when they did do like testing for dropping bombs, if it was within a 10-mile radius, it was good enough. Right? And so there was also a high amount of failures where planes were not ready to take off. Right? So all of these things were like huge problems, and they wrote, Charles Lindbergh, the aviator, wrote a document on this where, you know, he went in and did this study on the readiness of this, and it was like, oh, it's horrible. So they went through an immense amount of effort to retool this, okay? And they came back with four areas that they really thought were key. Number one, teamwork, leadership, consistency, and standardization, okay? The Checklist Manifesto, anybody read that book, you know, like way back in the day? You know, yep. So they were actually one of the first organizations to really enforce checklists. 600 points. Like, you're not flying that plane until those 600 points are taken care of. You know, they made people do drills and tests. Does this work in extenuating circumstances? What happens if this goes down or that happens? What happens if your cloud provider? Oh, wait, there was no cloud provider back then. Goes down. But those are the types of things that they had to plan for. And they made sure that everyone followed that same recipe. They even built everything from the ground up for repeatability and scale. So all of their bunkers, all of their missile silos, all of their entire infrastructure was exactly the same, so they could go from place to place, send crews, and it would be the same. The same, you know, airbase, the same layouts. If, you know, you're gonna change parts, it's the same place. Everything is repeatable and consistent down to the nuts and bolts. Now, this is where, you know, you look at that level of rigor, process, and automation, and I think we all strive for that in a lot of our implementations that we're working on, right? We want to take that approach where we can take a copy of something and make sure it's consistent across the board so we can get some assurance of how it's going to behave and run in the real world, okay? We also want to do regular testing, but a lot of times I find that people do the minimum testing. They don't test the unusual things, and those are the things that come back and bite them, right? How often are you verifying that, you know, people are actually following the processes that we set up for them to follow? Not everything can be automated yet. Now, while we want to and we strive to automate as much as we can, there's still a human element, especially as you're checking in code, especially as you're releasing things. You know, there can be things that go wonky. As we bring on new people, onboarding and hiring is a classic problem that we all have because it's, you know, oh, it's automated, here, read the manual. You know, so we had to talk earlier on, you know, building a team, onboarding people, right? That's important. So final thoughts here, because I'm almost out of time. You don't need to look at, you know, to just big tech companies for inspiration. All around the world, people have solved really complex problems with automation, with, you know, designing, you know, complex systems. And we can take a lot of those and apply them to the real world problems that we're trying to solve today in the computing space. And there's a ton of really good, interesting things out there. And I would encourage you, if you're really passionate about something, whether it's sports, whether it's, you know, cars, whether it's, you know, something else, you can apply that to your work and talk at conferences and, you know, speak on how this applies to, you know, what work you're doing on a day-to-day basis. And, you know, use common sense. You know, some of the things that we're doing now, it's counterintuitive to what other people have done for years and years. And thank you for beta testing my talk today. This is the first time I've given this, so you're my beta testers. And we are still hiring.
Thank you for that, Matt. Amazing talk, amazing energy. Loved it. This is from us.
Oh, thank you.
No problem. We have one or two questions, if you're willing.
Ah, yeah.
Yeah. So what are you... Oh, they're jumping around. I'll go for the bottom one because it's getting long. What do you think are the current trends / fads that we should skip?
Oh, that's a tough one. You know, I think right now we're seeing has anybody seen the CNCF landscape of applications? Like, it's like this big. Yeah. So yeah, it's huge. It's massive. And I think everybody's releasing very similar software in the exact same space. And with the way that the economy is going around the world, there's going to be some consolidation there. So, you know, when you see someone who's maybe in the storage space or maybe doing something with streaming or, you know, some technologies, ask yourself, do they have the ability to withstand kind of the next 3 or 4 years? I think that's really important because the economy is going to hit a lot of those smaller startups because there was a lot of free money available that's not going to be available now. And so if they don't have a business model, they're not going to get to that next phase. They're going to get gobbled up by somebody bigger. So I would be careful on what you look at there. I'm also a little bit hesitant on the a lot of the infrastructure as a service, you know, independent players right now, because that's where I think you're going to see the most consolidation, right? Now, I love a lot of different companies in this space, but there's a lot of competition there, and a lot of them just aren't profitable yet, and they've been relying on VC money, which is going to dry up.
And we do have one more, using the example of USB-C as the standard in Europe. Standardization in most industries is a golden standard. Should we do this in software dev tools?
I think choice is good, right? We don't want to eliminate choice here, but I think that there should be some common standards, and there is for certain things like, you know, ISO standards or security standards, like you have to get PCI compliant or you have to be GDPR compliant, right? So there are standards. I don't think you want to dictate the tooling themselves and the actual pieces of software you should use. But I think that, you know, you want that competition, you want some variety, because it's okay if, you know, I prefer IDE 1 versus IDE 2, right? You know, that's okay. It's just that we need to be careful that we don't have too much sprawl out there.
Cool. Thank you so much.
All right, cool.
Once again, thank you, Matt. Okay, if everything is going upstairs, I think we're going remote again. So up next we have Ricardo, who's going to be talking to us about reliability advocacy, and hopefully everything kicks in and we're good to go. Hey, good morning, Ricardo, or afternoon.
Hi, hello, good afternoon.
If everyone can give Ricardo a round of applause.
Thank you. So, hello everyone. My name is Ricardo Castro. I'm from Porto, Portugal. And today I'm going to talk to you all a little bit about reliability advocacy. So let's delve right into it. So what's on the menu for today? If you're familiar with the work of Simon Sinek, you know that he has the concept of the golden circle, and he talks a lot about that we need to understand why we do things before we implement the hows and the whats. So that's exactly how we're going to start this. So we're going to try and first understand why reliability is important. And we're going to use an example from the real world, something that we use on a regular basis, something familiar to us all. We're then going to do a quick transition into our world of IT. And before we start talking about reliability advocacy itself, we're going to quickly define what we mean by reliability. We'll then go into what we mean by reliability advocacy. We're going to talk about different stages of how we can approach this, and we're going to mention several quick tips and practices that we can implement at each stage to make this reliability advocacy thing a sustainable practice. And before I leave you, I'll acknowledge a few resources that helped me a lot during my work and learning about reliability, and that were the basis for this presentation. So without further ado, let's start why reliability is important. And I'm going to use a fabulous example, which is a supermarket, right? So a supermarket, if we think about it, it's kind of a microservices architecture. So the interaction that I usually have with a supermarket is that I go in, I select whatever I want to buy, I pay, and I go out. But underneath the covers, there's a lot that needs to happen and needs to be reliable so that my experience with the supermarket is actually good. So for starters, someone needs to order things from suppliers so that I can buy them. Suppliers need to send trucks to the supermarket. Someone needs to unload those trucks. People need to stock the shelves. There are meat stands, fish stands. Someone needs to register what I decided to buy. I need to pay. So there are here several teams, several practices, several people that need to work together and ensure that the supermarket is reliable. So still in this concept of the supermarket, let's just quickly see a few examples of how the experience can be reliable or not. So let's imagine that we selected a few things to buy. I go to check them out and pay, and it's taking too long to pay, right? So if it's taking too long to pay, I might say that my experience with the supermarket is not reliable enough. Or even going further, I can say that the supermarket is not being reliable. If it takes me 1 hour just to pay a few items that I want to buy, I might say that the supermarket is not being reliable, and probably next time I will decide to go somewhere else. Analogously, I go into a shelf, I select a product, and the product expiration date has passed. So if this happens and starts happening quite often, I might also decide to go to another supermarket and buy my stuff elsewhere. Doing a quick transition into our world, we can draw a parallel between this and, for example, taking too long to pay can be seen as a latency in one of our systems, and a product expiration date might mean that I have an error in my system. So the idea here is that we have many teams, many people that need to work together so that these things don't happen, or at least happen at a negligible amount of time. So transitioning to our IT world, I'm going to use my company as an example just to quickly introduce what it means to be reliable on our areas. So I work for a company called Anova. This slide is a little bit outdated, but we have more than 2,000 customers. We operate in more than 80 countries. We monitor more than 1 million assets, and we operate, like I said, in the industrial IoT space. So what do? We collect data from industrial sensors, we process them, we store them, and then we develop services and applications that our customers can use to provide excellent service to their own customers. So we do a lot of promises to our customers, right? So just like with the supermarket, there are many teams that need to work together to ensure that our customers are happy with the service that we are providing. And the idea is that it shouldn't be the responsibility of one team in particular, right? This should be a concern from the whole company. Everyone involved needs to have this reliability mindset. So the ones that start the movement to start thinking and embracing reliability need some kind of a practice to actually start building this mindset. So that's why we're talking about reliability advocacy. And before we start, what do we exactly mean when we mean reliability? So if we go to a dictionary, and this is an example taken from the Cambridge Dictionary, we can say that reliability is the quality of something that is behaving well, right? So if something is behaving well, we can say, okay, this thing is reliable. But that's a little bit abstract. I like the Alex Hidalgo's definition from his excellent book, Implementing Service Level Objectives, much better. So the answer to the question, is my service reliable, should be, is my service doing what its users needed to do? So the idea here is that we treat reliability as the perception that my users have with my service, and it will be them that actually say that if my service is being reliable or not. So how do we instill this type of mindset? So it's one thing to understand and to live by these reliability principles ourselves, but it's something completely different to spread these ideas throughout our organizations and getting other teams and other people working alongside us. So this in practice will mean things like we have teams interested in using error budgets, teams interested in discussing how and when we should implement feature freezes. This means that people will start relying on the reliability advocated by other teams. So these types of practices like SLOs, are most powerful when everyone is following some kind of process and are interested in building reliable services. It will be a lot easier to iterate on our systems and improve their reliability if the systems we depend on are doing the same thing. And if we are working alone, it's going to be a continual battle for priorities. So getting these things off the ground has many challenges, and it can be very difficult. So adding measurements, setting up monitoring, setting up alerts can sometimes be done in a couple of days. But changing how our organization works and how our organization sees reliability takes more than a few package install or setting up some configuration files. Luckily, we are not the first ones to try and go through this journey. There are a lot of resources out there, and today we're going to talk how we can approach this. So we're going to divide reliability advocacy into 3 stages. We're going to talk about the crawl stage, the walk stage, and the run stage. And it's exactly what you imagine. So the crawl stage will be the beginning. How do I start this out? The walk stage will be a stage where we're starting to get some traction and we want to progress and scale our practices. And the run stage is a stage where you kind of think that things are starting to get into some kind of cruise control and we're going full speed and want to keep scaling our practices. So let's start with the crawl stage. So within the crawl stage, we're going to see tips for how to approach research, having a sales pitch, producing supporting artifacts, doing training, having some pilots, handling changes, and spreading the message. So let's start. What do we mean when we say research? So if you are starting any practice or any cultural change within your organization, you have to gain knowledge, right? So you need to know what you are talking about. So this is when you start a reliability practice, you will have to do the exact same thing. So in a way, and for at least some amount of time, you have to turn yourself into the expert. So you will be the person, you or whoever is starting this practice will become the de facto experts. So there are a lot of resources, and I'm going to leave a few before I end my presentation. But the idea here is that for a period of time, you will have to gain a lot of knowledge, research, start defining what reliability means to you and inside the organization, and you will be the de facto expert within your organization. Coupled with research, it's very useful to have a sales pitch. So the idea of a sales pitch is something like an elevator pitch, something that you can quickly deliver like in a couple of minutes. And the goal here is to have something that is very, very clear, very direct, that people can understand with the goal of enticing them to want to know more about reliability. While you're doing your research is interesting, and it's actually a good practice to start creating supporting artifacts that will enable your reliability practice to kick off. So we're going to see a few things about documentation and supporting artifacts for training. So regarding documentation, you can have a one-page strategy document. So this will be kind of a sales pitch, but in a written format, and it will be something that people can read in a few minutes and understand what you mean when you talk about reliability and the framework that you're probably going to use to actually assess that. It's also very important to have some longer documents, something like a 2-3 page document that describes your actual framework. For example, if you decide to use SLOs to assess how your systems are being reliable and how you are going to measure it, it's actually very useful to have a documentation describing that, describing what are SLIs, what are SLOs, how you are going to measure things, so that people can refer to you when they have doubts and you can point them to those documents. Another very interesting document to have is a frequently asked questions document. So these are things that you already know that people are going to ask, but with time, people will start asking some of the same questions. So you can build that document, keep expanding that, and then you can reference people, and people can work at their own pace just by reading that document. And of course, some written document, some supporting documentation that is very useful to have are tutorials. So that people can work at your own pace. You can, for example, create tutorials on how to instrument a service to collect the necessary metrics to actually assess if a system is not reliable or not. If you're using SLOs, for example, you can have a written tutorial that show people how you can set up, for example, your SLOs, set up dashboards, set up alerting. And you can also have a written tutorial done with one of the services within your organization. It makes it a lot easier and makes it more relatable for people to actually assess that. Regarding training, you will need to have supporting artifacts. And here, this will differ greatly from organization to organization. But for example, you can have videos for that. You can have, for example, a 30-minute video explaining what SLOs are. You can have GitHub repositories for the hands-on workshops for what we said about instrumenting a service or defining SLOs. And you can also have videos for that. So, but the idea is that you build a knowledge base that will support training. So regarding training, so when you're trying to do a big shift within your organization, it's also always useful to actually train people. So sit side by side with them and help them achieve what is your intended purpose. So training will, in this case for reliability, will most likely be in the form of workshops. So try setting up workshops with teams and perform them, if possible, with people that already have some SLO knowledge. So the idea here is that this will be hands-on. So the goal is for teams to start like adding these metrics, setting up SLOs on a practical fashion. Very important, always collect feedback and iterate. Some things will work, some things won't work. So it's very, very important that you ask people for feedback, see what works, expand that, see what doesn't work, and cut that out. Eventually, you will have people that have gone through your workshop, people that know what the documentation is, know how to instrument a service, how to collect SLO. So you're in a good position to start piloting this. So the idea here is that you select one or two services within your organization, choose a small service, something that you can iterate quickly, and pilot your reliability framework within that with that service. Start by creating SLI visualizations. For example, use things like Sloth and Grafana to actually see have a visual what your reliability target is, how reliable you are being, if you are burning or not error budget. So start building this trust with teams by piloting them. Again, just like with training, get feedback and adjust. And very important, document this pilot as use a case study and add that to your library documentation. But of course, you should expect some resistance on reliability adoption. Again, it's a change. In some organizations, it's a big change, and many people maybe will not take this easy. So you'll need to provide the tools. So you'll probably will need to be tools to make people's lives easier, and you will have to maintain good documentation to help this process to be scalable. Don't forget, very important to handle changes, track reliability as any type of work. We want that reliability becomes part of our daily practices, becomes a concern from everyone. So you should track reliability work as any other type of work. If you're using tools like Jira, for example, you should have tasks related to reliability. And of course, build on previous successes and turn people into evangelists. So the people who have gone through the training, your workshops, maybe the teams that start piloting out can start advocating on your behalf. And of course, with any effort, you need to manage communications, right? So you need to ensure that everyone is aware of your reliability efforts, how are you going to approach it? And here are a few ideas of how you can do that. So you can promote internal talks, you can speak at external events in the name of your company, you can publish a training schedule, you can create a mailing list, create some Slack channel, start a reliability newsletter, and have an office hour. So the idea here is that you keep reliability in everyone's mind during this process. When you start getting confident that you already have a pilot, people have gone through the workshops, you can stop crawling, you can stand up, and you can start walking. And at this point, you will start have early adopters because you've done a pilot or two, and you want to start onboarding more services. So the idea here is that you don't scale your team linearly with the amount of new services that come in. Teams must be self-sufficient. So try choosing early adopter teams from different services so that you can build a base that can grow on itself. So for example, if you have teams developing services, pipeline services, or continuous computing, or batching, or streaming, business critical, whatever it is, start onboarding these as early adopters so that they can then advocate on your behalf. Publish a scheduler sessions to assist them. So make sure that teams feel that you're there for them and you can advocate on their behalf. And also very important, with these early adopter teams, define a timeline for completion. as we've talked before, reliability work should be tracked as any other type of work, but you should define with teams clear goals and a deadline for them to achieve those goals. Always very, very important at this stage, it's to celebrate achievements. It's easier to start getting into cruise control and forget how far you've come. So always celebrate your achievements. And help team be confident. So if teams get stuck, be there for them. Try to understand what's working, what isn't, how stuck they are, and help them. Again, start simple. Don't go overboard. Don't define thousands and thousands of SLOs. Just start simple, define a couple of them that make sense for the team and build on that. And whenever necessary, bring someone knowledgeable in a difficult area to assist a team. At the walk stage, we're starting to grow our practices, so it's very important that we keep and maintain a well-structured documentation that you can point and reference teams to. So grow your internal use case studies. So like we did with the pilot, you can start using these early adopter cases as examples of how a team can do that. If you get overwhelmed, so your team is small, you can't keep up with so much stuff, try referring teams to your documentation and referring to teams to the office hours that you've set up previously. And of course, at this point, you will have early adopters, you have teams that have gone through the process, so you can train people to deliver training sessions more regularly. And always important, scale communications. You need to keep reliability at the center of your practices. So maintain your regular office hours that teams can just show up and ask questions. Keep updating your facts like we've seen before. Be available for one-to-one consultancy if necessary. And teams should be capturing reliability work as any type of work. And last but not least, we arrive at the run stage. So at this point, you already have a good reliability mindset, so you start entering some sort of cruise control when it regards reliability. So keep expanding that case study library, have concrete examples of success. So at this point, you probably already have several examples of how things have been done, so you can start referencing code and specific examples. Use services that you already have, use teams that have done it in the past, and use concrete things that they've done and the good and the bad of what happened. Of course, more and more people are working with reliability in mind, so you can expand this community of experts. So engage with the early adopters and make them XLO experts, like the ones that you start by being at the beginning. And don't forget that add them to those internal communication tools that you have, your Slack channels, or your newsletters or emails, and allow them to reach people to reach them. And of course, keep a mindset of continuous improvement. So review your SLOs and your documentation regularly. Perform deep dives, invite other teams to join and promote discussions. And eventually your platform will need some changes. So be prepared to work with the teams to ensure that the type of reliability that they want to achieve. So before we go, a few acknowledgements of a few resources that helped me a lot. So the first one I have mentioned before, so it's a book by Alex Hidalgo. And if you want a good overview of how to implement SLOs, and a lot of what was said in this presentation was based on the teachings of Alex about reliability advocacy, I highly recommend this book. And of course, the other two books are familiar to most people, which are the famous Google SRE books. There is a lot of information in these books, learnings that came from almost 20 years of coining the SRE term and being practicing. So they will be they talk a lot about what worked, what didn't work, how they scaled things, and they have a lot of teachings of how you can build this reliability mindset. And last but not least, shameless plug from my end, but that is related to this presentation. So I'm writing a book that should be out by the end of the year, beginning of the next year, which all about SRE and some anti-patterns that we can fall prey to. And we'll have a lot talk about here about reliability advocacy. So if you are interested in this subject, just keep this in mind, and the book will eventually be out. And this is all from my part. I hope this was informative for you. I hope that you got a few tips on how you can start a reliability culture within your organization, and practical things that you can do within your organization. So thank you very much, and have a great conference.
Hey, Ricardo, can you hear me?
Yes, I do. Yes, I do.
Hey, thank you so much for the talk. Sorry you couldn't be here, but on behalf of the organisers, we hope to bump into you at some point soon. We do have a speaker gift for you, and we have an amazing drawing that's been done on the wall here, and we'll hope to get that to you soon.
Yeah, thank you very much.
No problem. I see there's been no questions on the Slido, but if anyone does have a kind of ad hoc on the fly question, I'm more than willing to take it.
Sure.
That's also okay. But once again, can you please put your hands together for Ricardo?
Thank you, guys.
Okay, so I think I'm pretty much just winging the next bit, and I'm hoping some of my organisers are kind of rallying around and figuring out what's going on, but we're going to be doing some giveaways and some raffles before our final talk for today. So I'm aware of who and which raffles we have. We have one from Contrast, we have one from Adian, and we have one from Mondu, but I have no idea what the running order is, so... Yeah, we have a Contrast here.
There you go. Hey, did you not forget me this time? No. That's the downside of being the beer sponsor then.
Yeah, one to many.
No worries. Yeah, thanks guys, and thanks for staying late. And we are obviously doing a raffle. We have like a digital system, so I wrote a few names on a piece of paper, hoping that everyone's still here. But first, I would like to thank the organizers for hosting this beautiful event. So if we can get a little round of applause. Yeah, I thought it was a great event, and I hoped you liked it too. So we're giving away a Nintendo Switch, so we'll ship it to your house, and the winner is Mark Burkles. If he's here. Mark? Sounds like a no. Then we have, well, then we'll go to the next one, just to be sure, because it's nice to, you know, if someone's here. The next one is Goran Manot. Also no? Yeah. Nobody wants a Nintendo Switch? Okay, yeah, it's fine. Luckily, I wrote down a third name. Dia Mona. Oh, nice. Nice. Well, you're 3 times the charm, right? But congratulations. Thank you very much. And I'll write down your contact details and then we'll ship it to you, yeah? Thank you. Who's next? Ah, you are.
I always am. Up next, I think we've got Adian. Yeah? Oh, look at all this Lego. Bring it on stage.
All right. So, finally.
Thank you very much. So, the way that we're going to do this is we're going to ask somebody impartial to pick out the tickets. And Reiter is going to be our impartial volunteer. You have just been volunteered. Thank you. So if your ticket gets called, you may pick any of the 3. So we've got the Van Gogh, we've got the Millennium Falcon, and the Saturn V. Would you please select a ticket?
My ticket's also in there.
In that case, no, you can't do it. Who here does not have a ticket? Floor? Ready? And? 35. Are you joking? Hang on a second. You need to actually have your ticket. Does anybody have ticket number 35? If it is you, this is not going to look good on me. Yeah? Amazing. Which one would you like? Okay, we're not letting Floor pick the next one. Which one would you like? Yeah. Okay. Yeah. Do you have a ticket? You don't have a ticket. You're going to pick the next one. Ready? He's going to pick mine now. Yeah. And?
51.
Number 51. Who has number 51? All right, we redraw. Ready?
Number 150.
115, 115. Ooh, no. Okay, we're going again.
Am I broken?
Apparently.
No, you're doing great.
Yeah, you're doing amazing.
Keep the excitement. 75.
75. Wow, people don't want Lego, apparently. I didn't expect that at the DevOps days.
0.
0? What?
I mean, you can check it. It's pretty...
What? Go again. Test, yeah.
Oh boy. It's either... No. It's 99.
Number 99. Yeah. Hey! Oh, and of course. Is it 99? Are you 66?
I am both,
you're 99. Yeah. Number 9. Well, which one would you like?
Which way?
Yep. Congratulations, Michael. Hey. Who else does not have a ticket? Chris, you don't have a ticket. You're going to pick our last number. Ready?
Yes. Without looking.
Yeah.
23.
Number 23. Well done. Yay! Thank you all very, very much. Lovely stuff. Yeah. Oh, well, take a photo of this lovely guy.
With the prize.
Yeah.
With the prize. Thank you.
Lovely. Thank you. Thank you, everyone.
Thank you.
Thank you. And as I juggle many a thing here. Oh. Yep. So up next we have the raffle from Mondu. Hey, Sue.
So we try to do something different and not Lego, but I think we made a mistake. So we did a season pass for the museum here locally in Amsterdam. And the winner is AJ Badrara. Go AJ! Okay, second is Motaba Kiani. Go Motabi, yay! Oh no, they only gave me 3 names. Anastasios. Yay!
Thank you. Hey, you are there? Sheila?
Good thing you didn't try the surname.
Congratulations, thank you.
Thank you.
Okay, I see a lot of people lurking at the back. Please, come on, sit down. We've got one more amazing talk today. Yeah, we do. And Stacey helped us out a lot earlier by being our backup speaker, and now you've come equipped with ears. It's great. So, everyone, please welcome once again to the stage Stacey, who's going to be talking about embracing the pitfalls, our stop-start journey to change.
Thank you very much.
Please welcome to the stage Stacey.
Can we see that? Yes, we have it on the screen. This is awesome. So, hello again, everybody. And, well, thank you for staying till the end. So, at OmniPlan, we have a successful application for making financial advice. It's got 25 years worth of effort and experience poured into it, and it allows us to give our customers quite deep insight into their customers' finances and how they can help their customers change their finances. Previously, it was written in Silverlight, which I'm sure was fine at the time when it was picked. But you know, Silverlight's kind of end of life, and it's also like out of support right now. And it needs IE, which is end of life and kind of out of support right now. And more than that, it limited people to Windows, which I am sure 25 years ago was okay, but these days, yeah, not quite so much. It was time for something new. Now, a few years ago, they made a start. They ported it to an Angular front end and a .NET C# Web API backend. The developers poured a huge amount of effort into making this work. There was this incredibly complex system built up, and it kind of did what it was supposed to do. But as development progressed, there were a lot of diminishing returns on that effort. It was getting really difficult to deploy. It was getting really easy to break things. It was actually quite easy to break something that was seemingly completely unrelated to what we were doing. So in the autumn of 2020, the architect and I brought in that year to help the project, went to management and went, you know what, we can rewrite this faster than we can finish it. It wasn't an easy decision. As we've heard earlier today, a lot of the advice that you get when you decide you need to do this is don't, and for good reason. Most of the time, it's not necessarily the right idea, as Matt suggested. But just like every other developer that's been in this position, we knew that we were right. We were that case where this was going to make sense and it was going to work. I'm happy to say that we got permission to try this. Now we just needed to prove that we really were in that 1%. So we started our new application, and one of the first things that we did was have a very different mindset on how we were going to go about developing it compared to the one that we were throwing away. It was going to have a completely different architecture, still using Angular, still using C#, but the way that we were going to build it was going to be totally different. Also, we were going to make sure that we had the right documentation in place, the right quality assurance in place, and the right deployment strategy in place. Could we make this work? Well, to quote River Song, spoilers, yeah. But not without some serious issues, and not without issues that still require some more ongoing work to really get solved properly. So, hello again. I'm Stacey Cashmore. I am not going to go through too much of this because I'm sure some of you heard it this morning, but I am Tech Explorer DevOps for Omniplan, who is a couple of doors down from here. And as I say, we make financial advice software. I've been building software since the 1990s, MVP for 2 years for Microsoft, which just feels completely surreal still. And yeah, it's been fun. Now, outside of the software, one of the other things that I really love to do in my job is learn. I love learning about new technologies. I love learning about how we can use technologies and how we can improve our work. As I said, this includes the way that we build our software, and it never stays the same. This thing evolves constantly. We build software differently to how we did 10 years ago, and I'm sure we're going to build it differently to how we do it 10 years in the future. I heard an awesome quote about XP. If you're doing XP and you're doing XP the same way you did it 12 months ago, you are not doing XP. And that's how I view software development. So what we tried to do with this rewrite is actually try and build that evolution into the process. We wanted to learn from our successes. We wanted to celebrate the successes. It was needed to get some celebration in there. But we also needed to learn from our mistakes, recognize them when they happened, not do a blame game, but try and do a blameless thing to figure out what went wrong, how it went wrong, and how we can make sure it doesn't go wrong in the future. And we've learned so much in doing this. We've come a long way. We've still got a long way to go. What I want to talk to you about today specifically is something we've learned with our CI/CD process. And it started in 2020 when we made the decision to rewrite. The first decision we took is we are no longer going to have manual gates on our deployment. As of now, when we go to the trunk, it goes to production automatically. Or or it doesn't go to production automatically. But either way, we weren't going to have somebody sitting there checking it at the last minute before it went live. We wanted to do those 10 deploys a day to make sure that when we change a service, it goes live. Not that we're not quite sure where everything is because it's at different points of a gated deploy system. And we didn't only want to do that for the code, but also for the infrastructure. We recognized that the old system that it kind of had infrastructure as code and kind of didn't. We wanted to make sure that we did this properly from day one. So we actually had a rule. If you were making a new service, the first thing you had to do was write the infrastructure as code and make sure that there was something to deploy to in every environment that we have. And we did that using ARM templates. We want to move to Bicep because seriously, I hate ARM templates. But that's a work in progress. And the second one is when we're actually deploying our services. We also wanted to make sure that that first check-in for a service was actually going to result in something deployed to production and working. So it meant that the first check-in needed to do two things. One, it needed to make a service with a default endpoint. And I'm going to be honest, I don't care if that is a weather service that you get out of the box with a C# web API, just as long as something is there and it is available. And it also needed to have the pipeline for the build and the test for our pull requests, and the build and the test and the deploys to make sure that it always goes out every time we make a change. And thereafter, every change we make to the trunk rolls out to production with the correct associated tests included in that same PR so that the teams can be sure what they're deploying is actually what they intend to deploy and it's working as we want to. There is literally not a single point in this process that wasn't different to what Omniplan was doing before. Everything was thrown on its head, and we had to recognize the scale of change that we were doing. We couldn't just do this. We've got an amount of developers used to working in one way, and we're now saying, right, as of today, that's gone. Now we do this. We need to make sure that they can learn this and they have the materials available to them. A lot of developers like Pluralsight, so we made sure they had access to a Pluralsight account. A lot of developers preferred different ways of working, so we made sure they had access to something that was useful to them. And this went really, really well at the start. In just a couple of months, we had some seriously complex stuff live in production. The customers loved looking at it and playing with it and seeing what they could do. For every change, we did a couple of manual checks because we didn't want to automate all the things. And we had some automated checks to make sure it works now and in the future. And we had a few lessons learned during this process. There were a few hiccups and a few stumbles. Like I say, it's an evolution process. We learned from it and we moved on. Everything was looking super rosy. Then we kind of had a little bit of a crash. And we kind of had a little bit of a crash because we had a huge planning problem. This project had been running for 18 months. And at the 18 months mark, we took that code and we kicked it. Awesome. We were sure this was the right decision. We were making Empire Strikes Back. We weren't making Fletch Lifts 2. But we still had a planning issue. And it started to cause an amount of stress within the teams. And it started to cause an amount of stress in the company because we have this deadline looming and looming and looming, and we can't go live with an MVP because we're replacing an existing application. And this is where we got our first big problem. As people, we like to help people. As people, when we see people in serious amounts of stress, we want to help them get out of that serious amounts of stress. And when you've got a team that's trying to learn a new way of working, and they see somebody in stress, it's like, okay, I don't want to spend this time writing the unit test, so what I'm going to do is just skip the unit test for this one, show them something that looks like it's working, make them wipe their forehead and be happy, and then we can move on. Later on, we can fix this problem when we have the time, and I've heard that so many times in my career, and it makes me cry every single time. So, moving on from that point, we started to see some bad things happening. We started to get pull requests to add tests to preceding pull requests. Those preceding pull requests are already in production. And now we're adding the test to see whether or not what we've pushed to production is working. We had unwritten or half-written documentation, which at the beginning we decided we want decent documentation for this from the word go. We don't want to get people lost. And it started to get harder to bring people up to speed with what different services were doing when you open the README in the repo and it simply said, this is your README, you can fill in stuff here. It's like, awesome. That doesn't help. And all the time we're doing this, we've got more and more stress from that deadline, and it's getting worse and worse. And I've got to say, we did unfortunately reach a point where we could no longer do course corrections. It was not a pleasant time to be doing this project. Everybody was totally stressed from the deadlines. Everybody was totally stressed because we know we're not building it as we want to build it, and we can't catch up on those shortcuts that people have taken and still move forward. There were arguments. It was just not a pleasant time to be working there. But there were good things, and we tried to make sure that there were good things that were coming out of this. And it came down to the choices we made in the beginning. So we had a lot of issues. We had a lot of shortcuts taken. But because we decided to move to a service-oriented architecture, most of the issues, although we had them in different services, the issues themselves were limited to one. So we didn't have one issue that spanned multiple things and was going to be an absolute nightmare to try and fix. Even within those services, we tried to build things in such a way that everything was disconnected enough that we could actually replace very small parts of the system. And we could add to that system without really hitting some of the issues that we added to it. And most importantly, we had teams that desperately wanted to improve, desperately saw where we needed to go to and the things it was going to give us. And I cannot understate how important that last one is. So we reached the deadline, we took stock of where we were, what we needed to do, and started to move forward. We've now got an ultra-complex application again. We have feature parity and things are working, which was awesome. We'd actually proved that we could do this. And like I say, we could add and change the code as we needed to. And these three things meant that we actually had a path to move forward that meant we didn't have to do the full rewrite we did before. We could actually try and do this in an incremental way. We didn't need a hardening sprint. We didn't want to do tech debt sprints. We could actually, as my boss likes to say, keep the shop open, improve, and keep the shop open at the same time. The first step that we've done to try and fix the problems that we have is to really take the teams back and help them in their refining, because we can see that this is where a lot of problems start. You actually see the problems later on when we're building, but if you trace it back, a lot of the problems start from not necessarily doing the right things in refining. So we asked them to introduce a few questions when they were looking at new features. So why are you making this change? How are you going to prove that this change is doing what you expect it to do? How are we going to improve what we have during this change? How are we going to actually approach the change itself so we have a little bit of a plan, and then check in with the team to make sure that everybody is on board? So that first question, why? Does everybody understand the problem that we are solving? What are we doing for our users, or what are we doing for the customers of our users? And I've seen it too many times in lots of different companies where somebody's working on something, and you ask the question, why are you doing this? Oh, because that's what the spec says. And that was the amount of knowledge that people had. I don't think that's a good thing. I am a really idealistic person, and I view my job as a software developer, it's to try and make people's lives better. I want to know why I'm doing something, first and foremost, because I want to know that what I'm building matches my personal ideals. I want to make sure that I am doing things which don't make the lives of the end customers of our customers worse. I have, in some companies, actually refused to implement some functionality that was requested because I didn't agree with it. If you don't understand what it's doing, what you're solving, how can you answer these questions? I've also been in the position in the past where there was a stakeholder in a team and they were asking for some supremely complex thing to be built. And the team was saying, this is going to take like 4 weeks. And the stakeholder was saying, that's ridiculous, this should be built in a few days, what's the problem? And they had huge arguments. I was brought in to try and resolve this issue, and the first question I asked is, well, why do you want this? And it turned out they wanted to connect to a web service somewhere, and what they'd done is figured out, well, to connect to this web service, we have to get this data, we need to turn it into an XML, then we need to put it into a SOAP envelope, and then we need to send the SOAP envelope somewhere in order to make it work. Now, obviously, as developers, as soon as we hear this, it's like, oh, so you want to talk to that web service? Yeah, that's a couple of days. And we managed to solve the problem, but because nobody had asked, well, why do you want this amazing chain of stuff? We couldn't actually answer that question. So it's important for developers to understand just what they're trying to achieve and how they're making the world a better place. Second question was, how are we going to prove that what we're building actually works? I've seen too many developers work with incomplete sets of data knowing what the software is actually supposed to do. They have a little bit of a spec, and they build it to that little bit of a spec, and then they send it on to QA, and then they keep their fingers crossed and hope that it doesn't come back. And that just adds extra time, extra complexity. Everybody gets annoyed, and I want to ask the question of the developers doing this. If you don't know what your code is supposed to produce, how on earth are you actually writing it? I can't get my head around that one. But I see it far too often in lots of different places. I have a spec, and I'm building to the spec, and that's it. So now what we try and do is make sure that the team ask at the beginning, with everybody together, how are we going to prove that this works? We know what we're doing and why. Now we need to ensure it's actually correct. And at this point, we're not talking unit tests. That comes way down the line. But once we have the list of questions that we know we're going to try and answer, or to prove it works, we can then ask the question of, okay, which one of these do we need to automate? Like I said, we know we can't automate all the things because you get a very low return on investment if you really try and do that. So which ones do we just need to prove works now? And which ones do we need to prove they work both now and in the future every single time we deploy? And we want everybody involved in this decision at the start so we're not arguing about it later. And so when we're building it, we actually know what tests we want to build, and we're not looking around for it at the point where we're playing around in code and then going, well, this is too hard, we'll just add the test later when we've got time. Next question that we wanted teams to ask is, how do you make sure you're not breaking anything? Because it's not only the new functionality that has to work, you need to make sure you're not breaking functionality next to what you're building when you do so. So let's pay special attention to the functionality that we're building, the interaction with other functionality that we're building. Let's have a look at the code base that we're going to be working in and figure out which parts of this we need to pay special attention to as we move forward. Make a note of them so that we don't forget. And then ask a question of what automatic regression tests we have to cover the stuff that we might break. As I said, we'd skipped a lot of unit tests, so we know we've got an awful lot missing here. But if we can ask a question before we start playing with code, then we can actually start to add those tests, and it can be functional tests, it can be unit tests, whatever, to make sure that before we make any changes to the code, we know if we've broken something. So now we can actually start to pay back our automation debt that we started to build up because we'd skipped things earlier on. We don't want to make changes without impacting the user, without 3 weeks of regression tests, and all the steps so far have been designed to try and do this. The other reason why we wanted to do it in this way is, again, because we don't want to make Fletcher Lives 2, we have a lot of code that we know works, and we don't want to be replacing all of this code just so that we can move forward. What we want to do is pick this up bit at a time and pay back that automation debt as and when we need to change it. If we've got code we're not changing, then why do we need to spend 3 weeks adding tests in order to make sure it doesn't break? Whereas we can change the stuff that we know we are changing and actually move forward and improve at the same time. This also introduces problems, especially at the start. Some of the code that we have, it's not easy to test. It's not easy to test because people were rushing. And that means we're going to have to figure out how we can actually write tests in order to cover this existing code. And we actually know that for a while, our testing pyramid is not going to be the right shape, because some things we're going to need to test from the outside in a horrible way so that we can actually change it on the inside. And again, no, we've not broken anything whilst we do that. I have done this in the past, and it's really nasty when production breaks for no reason. So we hope that this gets better over time, because as we add more and more checks, when we start new changes, there's less and less stuff that we're going to need to backfill in order to get to the place where we need to be. So now that we know what we can break, how we can check it's working, we can actually get to the fun stuff for the developers of, right, what technical things are we going to change here? What is the approach we want for fixing this? What strategies are we going to use? Where in the system are we going to make this? Are we going to feature toggle it? Are we not going to feature toggle it? And really come up with that plan beforehand. So again, when we're actually in the sprint making the changes, we're not thinking on the fly, thinking with the keyboard, and doing random things inside of the system. The other reason why we want to do it at this point and make these ideas is because we can see when we look through the system what we need to refactor. And I'm going to be honest, things we need to rewrite. And we wanted to separate the two. So we can spot right now, when we're working out our plan, what we're going to need to refactor before we start making changes to the code, because we want that separate. I have seen big refactorings done at the same time as introducing new code, and it didn't work. Lots of things broke. And nobody actually knew, did it break because of the new functionality we added, or did it break because we refactored something incorrectly? So we want to try and keep these things atomic as much as possible. I've been guilty of doing this in the past, and it's not fun. The last thing that we want to do inside of the team is this check-in. We've now gone through all of the steps with all of the team. The product owner, the tester, the front-end developer, the back-end developer. And with all of these different roles, responsibilities, and personalities, I want to check that we understand the changes we're going to be making, and check that we agree with the changes that we're going to be making. We have a plan of action, and I want to make sure everybody is on board. Now, at this point, I'm not saying this because I want to get rid of any dissenting voices and you must agree and move forward, but I want to do this because if someone is a dissenting voice, then they've probably got a good reason to be dissenting. So what concerns do they have that we haven't answered so far? Why do they not think that this plan is the right one? Let's have this discussion, let's start it before we start the work, and make sure that even if we don't all agree that this is the best way, that we can all agree this is a good way, and if it doesn't do quite what we want, we have a second approach to it. By doing this, what we've managed to get rid of is the whole, this was your idea, and it's all gone wrong. Sorry, Flo. But rather change it so that this is our idea. I want the team to own this change. I want the team to take responsibility for this change. So let's just have a quick check-in and make sure. Now, we've started this in one team so far. It's actually an experiment that's about a month old. And so far, the results have been quite good. I have loved watching some of the discussions the team's done. And I've loved seeing some of these questions that they weren't asking before and the extra information that it's brought to the team. We've even identified complete gaps in features, so we're actually helping the user by doing this and making the software more flexible and easier to maintain at the same time. Only time is going to tell if this works long term. I don't know. It's going to be interesting to find out. I hope it does, because it's my job, but things might change when we get a lot of pressure and the team suddenly, again, start to go back to, okay, but I can do this really quickly this way. And we've got to figure out how to stop that happening. But we're not going to do that now. We're going to figure it out at the time so we can help the teams. There are some things, though, that we can do now to try and ensure that this change stays in place. Throughout the whole of this story, there is one thing that I have had to learn, and I wish I'd learned it sooner. Do not underestimate the amount of learning needed to go from working in one way to working in an entirely different way. We had that one. We tried to offer people the different ways of learning, what did they want to do to move forward. What we did underestimate is the time needed to do the learning. We thought that we were giving the teams this time. They were told several times by management, you need to take the time to learn this. It's important to you, it's important to your future, it's important to the company. And yet people still found it hard to actually take the time. And I struggled to understand why this was the case at the beginning. It's like, you know, the management's saying that we should do this, so why aren't we taking the time? What is the problem here? And I came to realize eventually that the problem is that it's easy to tell people they need to take the time to do things. It's actually a lot harder to get the teams to do it when you're sending mixed messages. If you have the management on one side saying, this is really important, you need to take the time to do it, and on the other side saying, do you guys realize how close this deadline's coming? You know, so this deadline's coming, the customer's on our back. Have we got anything that we can show? Can we do something yet? Can we just add one more thing? Can we just skip that for this one? Do we need pizza evening to go forward? When you have that second set of communication from the management, you need to take the time. It's just simply not enough. People will ignore that and they will focus on the stress side of things. So we've changed that. We now schedule time for the teams to learn. We have started to do growth days once a month, where we tell the teams, on this day, you do no work. We don't do deploys, because we're not changing anything inside of the trunk. We will only fix high-priority SLA issues on production. The rest of the things we'll put in and we'll pick up the following day. And it needs to be self-improvement, whether that's experiments that you want to try, hackathons that you want to do with your current team, with another team, working with lots of people, or you just want to learn a new technology or a new way of working. That is what this day is for. We've been doing these since the start of the year, and they've provided a lot of value. We've seen a lot of things come out of it, new technologies that we're using, new ways of documentation that we're using. Our management team and our product owners have learned a lot about product thinking because that's what they desperately need to learn in the coming time. And mostly, it's good. There's one other thing that we've had to learn here, and again, this is the whole evolution thing. If you've got people that aren't used to being told, take this day and go and learn, and you dump it on them, which is what we did originally, they have this day, and it's like, well, what am I supposed to be doing? What am I supposed to be learning? What is this new way of learning? I just don't know what I'm going to be doing here, so I'm just going to be going back and fixing this bug because I don't understand this day. So what we've had to try and do now is give a little bit of direction to some of the people. And it's like, right, where do you want to be in terms of technology? What are you struggling with on day to day? And just try and make a little bit of a plan for them without making it too prescriptive. Just give them a little bit of a nudge so that they can find their own path. The main thing that I want to give you today to take away from the interesting stress that I've had over the last couple of years is, in order to improve, we do have to be continuously learning. We have to be continuously looking for what we can improve. Experiment with yourself, your teams, and your company. Take a look around you, see what there is. I really hope you've enjoyed this conference. It's been awesome today. Thank you very much.
Thank you so much, Stacey. I'm willing to take one question from the floor if anyone has it, but if not, then I think we're good. Okay, I want to hold your attention for just one more minute if I can do so. And I would like to.
Do you want the power?
I would love to. Thank you so much. How many laptops can we fit here? Yeah. I need to steal this. Thank you so much, Stacey. Okay. See what what we've got. Hopefully it all just rolls immediately. Okay. We are almost there. I swear, I'm just going to take one more minute of your time, because honestly, I've only got one more minute left in me. So I want to make one call out to DevOps Days Eindhoven. The call for papers is closing on the 14th of July. And we're still looking for sponsors as well. And I think there was a comment or a question earlier I seen on Slido that the early bird tickets are still available, and it's until August the 1st. Now, I think this is probably the most important bit, and I hope you can all join me in some appreciation of everyone today. So not only, I would like everyone to put their hands together and thank all our sponsors that have made this event possible. So please, a round of applause for our sponsors. The next group I'd like to thank ever so much is our venue, and Packhouse de Zwijger for hosting us. So please. Now, you may not have seen this, but I've definitely been seeing them all the time. I'd really like you to all thank our amazing AV staff who have been really helpful throughout this entire event. And there's one group of people that I would really like to thank as well, just from a personal basis. I would really like to thank all the other organisers that have contributed and helped, and please, you can give them a round of applause for making this possible. Now, lastly, and probably most importantly for me at least, I would like to thank every single one of you for attending, contributing, the active communication and conversations you've been having in the last few days. It's been amazing to see you all back in person, and I really hope you enjoyed DevOps Days Amsterdam 2022.
Okay. Chris has thanked everyone, but let's all give a big shout out to Chris for being an amazing MC. You've been amazing, powering through for the past 2 days with your awesome shirts and your hair. But yeah, a big shout out to you for doing this. Thank you so much, Chris.
And lastly, I really hope we get to see you next year in June. So please come back, please watch out for us on Twitter, and I hope you enjoy the rest of the day. Thank you.